create some interaction. And again, it's on my second screen here. So when you see me watching to my other side here, it's not because I'm catching up on emails. It's literally because I'm trying to look at some of the questions and make sure that during the time frame that we got allocated, your questions are actually getting answered. So what do you think, Unai? Should we jump in and start introduction?
I think we should get started. So as we said, this is going to be an introductory level in learning experience for Git. Okay, Git is a version control system. There's many different version control systems. We'll be discussing that. Okay, and we'll see what is the actual power of Git. Okay, so Git can seem a little bit cryptic at first, but it can be also even frustrating at times. Okay, so we'll try to put the base here, like let you know what you should know, what's happening on the background, because what Peter and I will be sharing here, you may be doing it later on with some few different graphical user interfaces, but here we are going to be showing you the actual Git power from the command line. Okay, so seeing what's happening on the backbone, and especially because we are seeing that Git was quite famous already for software developers, but lately we are seeing it being used in many other IT profiles right now. Okay, so people working on configuration files, people working on infrastructure as code, people even working on documentation. They are using Git nowadays. Okay, so it's not just a tool for software developers. That's why we want to make sure everybody is onboarding correctly into this tool.
Well, it's what I told you, right?
Yeah. Tell me, Peter, sorry.
Well, no, it's what I told you. Like my own experience with Git was once I started looking into like Azure DevOps, and yeah, my background is like building Microsoft data centers before Azure. It was all on-prem, but obviously now been using Azure for quite some years. And yeah, that's what got me into like the interesting DevOps world. And I can imagine it's the same for our audience and checking some feedback. So there's some feedback like Git is complex. Some other ones are sending some information like I love Git and I couldn't live without it anymore. And I guess it's about the same feeling as I have, where it's just becoming your day-to-day tool, almost like checking your phone every now and then, where you're just going to use Git to check in your code. And as you mentioned, updating. Why not creating documentation, creating ebooks, creating blogs, and anything else you can do with it? But back to you, Unai.
Yeah, sure. So Peter and I will be showing you some demonstrations that are building up on an scenario. Okay, so the scenario we are trying to imagine is that we are a software developer at a company. This company decided to start working with Git. And in order to get us ramped up into it, we don't want to start working on the real project directly because we are going to make a lot of mistakes probably with Git. So what we are going to be building is actually a cat website. Okay, so a website where people are going to be able to upload cats. I was telling Peter before, I actually hate cats. I prefer dogs, but this is the scenario that the Learn product team decided to create for you. And that's the one we are going to be using today. Okay, so just creating a cat uploading, picture uploading website and see how we can start initializing that repository. How can we set it up? How can we start tracking changes and making going forward on those changes we are applying?
Well, I was actually more looking forward to the aviation company website you were talking about, but for me, cats is fine. I do have a cat at home, so I had dogs before, and I'm not even really decided like, am I more like a dog person or a cat person? But I think for now, our demo scenarios, using cats is obviously perfectly fine. But enough about cats and dogs. Let's maybe talk a little bit about one of our key statements in using Git, but taking a few steps before diving into Git itself and sharing some insights on version control. And that's really the magic word for today. Now, if you ask me like what is version control, you could think about your local file system. For the ones who are using Windows Client for a couple of years back already, you could integrate versioning, which means you're going to create some kind of file, could be a Word document, could be a PowerPoint file, could be almost anything else. And if you want, but as an end user, you needed to enable it, you could go back and enable version control. Now, it's obviously not exactly the same, but overall, the concept would be pretty identical. So by using a version control system, sometimes abbreviated as a VCS, it allows you to track changes. Whenever you're going to make a change to a file, could be a small change in some application source code, could be a change in a PowerShell script, maybe an ARM template, Terraform template, or why not, if you want to create documentation. My own blog is written using Git as well, where whenever I'm blogging, but not always publishing it already, I'm relying on Git to check in my changes and from there moving forward. So super important, even before jumping into all the nice things about Git, is really having that concept about version control. And it's going to make your life so much easier.
Sorry, Peter. I was just jumping into the Git documentation right now.
Oh, cool.
I'm quite surprised to see. So the actual main site for it is git-scm. Could you tell me what SCM stands for?
Well, in my legacy data center days, I would immediately think about like System Center Configuration Manager, but that would be SCCM, so that's not what we're talking about here. It's actually pretty cool what they did with URL. So you could assume that you would go to git.com, but what they actually did is like using version control and SCM, which by the way stands for Software Configuration Management System, and you can use the two like interchangeable as well. So it's or a version control system, a VCS, or it's also called a software configuration management system, SCM. And that's where I would say that little cool gimmick in the URL is coming from as well.
Okay, that makes a lot of sense.
Good. Well, since you had some time to read the documentation website, right? While I was presenting on what version control is, but could you maybe provide a summary on like what is version control? Why would you use it? What are some of the capabilities? Since you read the documentation anyway.
Sure. So what I can tell you, I mean, one of the main focuses of Git is enabling collaboration. Okay, so for collaboration, what we need to know is when, who, and what. When did the change happen? Where did it happen? Who did it? And what did they actually change? Okay, so that's something that we are going to be able to track with Git. Apart from that, we are going to be grouping changes, and every operation called commit, Peter will be explaining it later, will have a message linked to it. And not only message, people were talking about DevOps before. So in DevOps, what we find super useful is the traceability of the changes you apply in code, because they can actually break your code. Okay, so being able to link it to your software planning tool. So I may have some bugs, I may have some tasks pending. Are these changes linked to that one? Okay, so we can trace it back whenever something happens. Of course, being able to retrieve past versions. Okay, so going to the history, we may need to roll back our solution. And finally, of course, for collaborating, creating branches and all that, we'll be covering that mainly on session number 3. And applying tag to a versions. We'll see here that in the end, Git will be taking snapshots of your situation of your repo. Okay, some snapshots are going to be more important than others. Maybe one of the snapshots is the actual version number 2, version number 3 of our code, and you want to put a clear pointer to that snapshot. So that's something that Git tags will be actually providing us. Sounds interesting, right?
Yeah, I was just checking if there's some input coming in from our audience. All good for now, so no urgent questions coming in.
Great. So apart from that, I mean, that's all the advantages that version control tools have, specifically Git. Git is versatile, is cross-platform, is highly scalable, free, and open source. Okay, and just out of curiosity, it was created by the creator of Linux, okay, Linus Torvalds. Okay.
Oh, okay, cool. I didn't even know that, but it actually helps a little bit in understanding. Like, I had like quite some friends like years ago already using Git, but they were all like using Linux, where I was using my Windows machine, and honestly, I never heard about Git before. So that could also explain why they started using it already years ago, when I was still like in almost 100% Windows world. Now, one of the other things we need to talk about, I guess, is the version control. I know we started talking about version control, that you could use it to keep track of changes and some of the core capabilities that you mentioned. But there's another thing that I actually need to emphasize from the start to make sure that our audience know what we're talking about. And if you open up your search engine, and if you're maybe not immediately going to Git, although again, yes, the session is obviously about Git, but one of the other aspects is the difference between version control systems. Because what I explained before is that out of that VCS, the version control system, it's allowing you to keep track of changes. But not all changes are the same, and it also means that not all version control systems are the same. Now, when you start using version control today, and I would say probably using Git, if you enjoyed this session, I could only hope that you start using Git within the next hour or so. But when we talk about Git, it's known as a distributed version control. Now, before drilling down on what a distributed version control system stands for, let me take a few steps back in time. You already know I come from the on-prem data center world, been working in IT for about 25 years. And for quite some time, at that moment in time, internet was still pretty new. And working from home was like almost non-existent. I know for some younger ones in the audience, this might sound like, oh my God, that guy is so old. I still feel pretty young, but every now and then I feel pretty old as well. But what do we mean with a distributed version control and centralized version control? So at present, if you start onboarding to some version control system, preferably using Git, it is distributed. Now, before distributed, we were using a centralized version control system. And again, just sharing some of the examples like on-prem data centers, everybody was working from within the office, where it just somehow made sense that you would share your files, your source control, your application code, your, I don't know, batch scripts. Maybe somebody was using VB script already at that time, and storing them centralized. Where obviously the benefit, the mindset also at that moment in time was that you would have one centralized system where all developers and maybe system engineers were all working together on the same files. Now, some of the challenges, but again, I'm talking a little bit of history here where we didn't know about anything better. And some of the challenges was like a single point of failure, because you would create your central database system. Think of it as like a SQL or Oracle-alike database, but it wasn't really using those tools, depending a bit on the systems or solutions you were using. But you had a centralized database where obviously no rocket science there, but if the database is not available, it means that you cannot touch your source code, which means you cannot make changes, you cannot deploy applications, and anything that's blocking you from, I would say, working efficiently. The other one is also like really forcing you to have connectivity to that central system. And we had solutions like VPN, allowing you to maybe work from home or from somewhere remote. But without that VPN connection to like the headquarter office, probably, it was not even possible. So don't want to spend too much time on everything that's like not okay or maybe not anymore with a centralized system. And I see some feedback coming in from the audience like, oh, we're using centralized version control in our organization. Are we doing it wrong? So definitely there's nothing really wrong with it. But I would say we're going to try to share some insights and getting you excited about the new way of working, which would be a distributed version control. So what is distributed? It's giving you all the benefits that we didn't have with the centralized one. Where, for example, one of the first statements is that any developer or operations engineer, like what we would call DevOps engineers today, each and every one of them that are part of that team or the project are able to create a full end-to-end full copy of all the source code to their local machine. So imagine, and we're going to show you, not specifically today, although we're using the same backend environment, but throughout the 4 sessions, we literally going to build up from, this is like me just working on my local machine. And then in the next session, we're going to integrate with some of our team peers and sharing code, collaborating on file changes. But we're not going to touch on that already today, but it's coming in the other 3 sessions. Now, what we're going to do with the distributed model is really like literally cloning, creating exact copies of all information. So I'm storing all the files. If Unai would connect to my project out of the distributed VCS, he would get all the files as well. Obviously, the biggest benefit is that each and every member of the project will have a full copy, which also means you can work offline. And I know most probably for most, if not all of you on the call here today, you're going to probably work from home and you do have a decent internet connection. But I remember not that long ago, like a bit more than a year ago, where before I was like traveling the world for the last 7, 8 years. And you don't want to know, and I'm not proud of it, and I wouldn't really recommend it doing it, but you don't want to know how many like PowerShell scripts, ARM templates, even full web applications I've been coding while on a plane because it's not always that exciting, right? And then whenever I'm like arriving at my hotel or going to the customer site, I could immediately check in my code, updating it, synchronizing it, and all my team members were immediately up to date as well. So the biggest benefit I would say is distributed model, each and every team member working on the same project, using the same project folders, and we'll talk about some terminology in a minute. We all have the exact same copy. Next to that, we can also learn from each other. We can create some features like, oh, I got this cool idea. I'm going to inject it, but I'm not going to force all my colleagues to already accept it. And a lot of other cool things that we're going to show you later on in some demos.
Sorry,
so that's
Peter.
In short what. Yeah, go ahead.
So you were mentioning that I'm able to copy the repository. What about history? Because with centralized options, I was only able to see the history if I was connected to the repo. If I get the full copy of the repository, as you are saying, am I going to be able to check the history when I'm offline too?
Yeah, definitely. So again, whenever you're going to like check in, connecting, and we're going to use some specific terminology later on, it's allowing you to keep track of all the changes, validating all the history, maybe fixing some issues that you had before without everybody else already knowing about it.
Great, that sounds interesting. Now it makes sense why many customers were trying to ask me on helping them migrate into Git. So great, let's jump then into the terminology. Okay, we are going to start reviewing main aspects related to Git. We are going to be doing that by jumping into a whiteboard. Okay, so having some clear idea of how Git is working. So let me share the whiteboard with you. And here we are going to be seeing, not moving that arrow, just coming back to this first place, that in Git we are going to have 3 main different states. Okay, the first one will be the working tree. Okay, so the working tree will be some file directory on your computer that Git will start monitoring. Okay. I'm going to start changing some files. I'm going to start adding some files. From those changes that I'm maybe applying, it will be quite interesting for me to define what are the changes that I want to include into the next possible change. So the next possible change will be grouped on what they call the staging area, also called the index in Git. Okay. And finally, we'll see what are the commands to move your changes from the working tree to the staging area, from the staging area to the repository. Okay, so the repository is the main place for Git. Okay, so the repo will have the full history. Well, repository or repo, people normally call it repo as a shorter way. Okay, we'll see that the repo is that place that we are going to have with all the tracked changes, and we'll see later, okay, how important it could be to so mainly talking that the repository is what travels from your computer to a server, from the server to those people that are going to be collaborating with you. But more about the insights related to Git, Peter, I heard a little bit about hashes, object types. Can you tell us a little bit about it?
Sure. So, and I know it's a little bit about terminology, but obviously whenever you want to learn something new, like getting introduced to Git, it's always easier to like grasp some of the theoretical part and then mapping it with some demos that we do have upcoming in the next couple of minutes. Now, the hashing is some kind of checksum, if you want, that allows you to, or at least Git as the process, allowing you to really identify the changes. So imagine you do have a file like some application source code or some template or anything else that you start creating. And in the backend for that specific file, it's creating a hash. Now, whenever you're going to make changes to the file and you're going to save them, quite important, never forget to save your changes. Whenever you're going to save your changes, that's validating out of the Git process, like, oh, something happened, something got changed, and it means that it needs to create a new hash. Now, it also means if you're like opening the file but not making any changes and just closing it again, then technically no change is happening. And that's where no new hash is getting created as well. Now, for some technical questions, I just saw one coming in like, yeah, but like, can you share some details about the technical components of the hash? So just some information I will try to show you later on. But the hash itself is 160 bits long, where the full hash is represented as like a 40 character long string. And I'm not sure if I'm the only one, but technically it's quite hard for me to remember like 40 characters. So without doing anything more detailed, like checking log files, for example, Git is only exposing like 7 characters. And that's somehow a little bit easier in communication.
Great.
Did it help a little bit, Unai?
Yeah, that makes a lot of sense now. So apart from that, I think we already mentioned there's different branching, okay, and that's the actual power of Git. Okay, we'll see that branches will let us group link commits, so people can be working in different versions of the same code. They are great for experimenting, as we can see it here. People will have independent environments. And what about the default branch? So some people have the default branch as main, some other people have it as master. And I think it makes a lot of sense for obvious reasons. We are transitioning to main as the name for the default branch, okay? Important to mention also what we call head in lowercase letters and head in uppercase letters, okay? So when we mention head, and we are going to be trying that with some few commands, head is the current commit we are showing for a branch. Okay, so we are going to be reverting, we are going to be going back to some few commits before. You can put head minus the number of the steps that we are going to be jumping back into. Okay. Also super important to mention, so here you see it, repository and remote. Okay. How multiple people are going to have the same repo, how we are going to be synchronizing between each other, will be done by defining for your repository what is the remote location, the remote path, where it has to be looking for updates. Okay, can you tell us a little bit about it, Peter? What are the commands mainly used for this synchronization?
Well, yeah, so there's a couple of different commands that we're going to use, but at least for now, in I would say getting started with Git, two of the main commands you should try and remember is like git push and git pull. So what you're doing with git push, like the name says, is literally pushing from your machine into the centralized repository, and git pull allows you to like grab the latest files from the central repository and making sure that you're like completely up to date. And if you have like a fast changing project with a lot of collaboration with your developers or your operations teams, and there's a lot of changes coming in, then what I'm personally doing is like running that git pull like maybe once or twice a week to make sure that everything that I'm having in my local copy is actually stored and fully in sync with everybody else on the project. So git push, git pull, that would be like, I would say, 2 prime important commands to remember. And there might be another one that could be useful, but we'll talk about that more towards the end of the session, would be like git reset, where you could, besides just using the main keywords, you could also use some specific parameters. And then later on, we're going to walk through like git status or git log, and then you can add some specific parameters to that one as well. So git would always be the starting command. and then adding like some task detail that you want to get out of it, like pushing, pulling, logging, pulling up a status, and from there you can define some specific parameters. Now, I can imagine that not all of you are waiting to just memorize and learn like Git commands by heart. And honestly, it's not really what we're doing. But again, in this introduction session, once more, I think it's important to know like how is the tooling actually working before we're going to integrate it in some other tooling. Now, as you can see here, there's Git integration with a lot of like traditional development environments. If you're using Visual Studio, if you're using Visual Studio Code, maybe you're using GitHub Desktop, it makes your life a lot easier. It means that you don't have to memorize all those commands. Now, one of the side remarks here is that out of the integration in your preferable IDE environment, it's not always giving you all Git capabilities. So what it means is that every now and then, typically when you see some error message coming up from the tooling itself, that every now and then it's not always that clear. And that's where having that notion about the actual comments in the back of the tooling could be beneficial. And since we talked about GitHub and mentioning Git every now and then, I think it's maybe interesting to mention that it's not exactly the same. Now, GitHub by itself is obviously based on Git. So it's that version control system distributed, allowing developers, operations teams to collaborate and check in changes, make changes, and working together. But the version control part of GitHub is only like one subset of the actual capabilities. So what you can do with GitHub, and for the ones who are waiting for more details, we're not going to cover them in this session, but we have a lot more coming up around GitHub and a lot of other tools that integrate with the Git version control in session 3 and 4. So you need to hold on for a couple of weeks, but looking forward to see you back already. Now, in short, what GitHub gives you besides version control is project management, allowing your team members to create issues, starting up discussions, integrating GitHub Actions, allowing you to run pipelines, pushing specific deployments to cloud environments, to on-prem environments, overall performing some project management. So it's a lot more in GitHub than just using the version control of Git that we already talked about.
Yeah, I think what we need to leave really clear is like Git and GitHub are completely different things. Okay, so GitHub is a place where you can host Git repositories. If you're going to work with Git technology, GitHub will give you the server functionality to host them in their servers. Okay, great. So I think it's time, Peter, to jump into the first demo then. Are you ready for this one?
Let's hope so. Let's see if we can do a little bit of magic here and switch over to my screen.
Great.
And for the ones who are following along, feel free to just have a look at that Learn module. So if you missed that link, it's aka.ms. Learn, Git intro, and dashes in between the keywords. And if you start up the exercise from there, what it gives you is Cloud Shell. Now, it might be a little bit confusing at first, but Cloud Shell is just our way of giving you access in an easy way to using Git. Now, you don't need the Azure Cloud Shell to use Git, but it's just out of the Learn module. If you don't have a machine that you can use, or you don't want to use your corporate machine or maybe your personal device, because maybe you're not 100% convinced about Git yet, out of using that Azure Cloud Shell, it's a command line based, browser-based integration, so you don't need to install anything locally. And it's just going to make your experience out of the Learn module so much easier. So I'm just going to follow along and showing you what it looks like. So once you're authenticated, you get access to a Bash environment. If you don't like Bash, you can switch to PowerShell. But for Git, it doesn't matter. The experience is the same. On your local machine, in another scenario, if you're not using Cloud Shell, you can go to that Git SCM website, download the version for your platform, macOS, Windows, Linux, you install the tooling, and from there you're going to start validating. So one of the first comments that could be interesting is just running Git, or why not checking Git version. Think back about my push-pull example. I already briefly touched on it. So one of the easiest ways to validate is just running Git, but that's just going to give you like some feedback. And why not checking the version? Now, based on what Unai was reading in the documentation, I somehow discovered that we have, in meantime at least, the most up-to-date version would be 2.31. So why the Cloud Shell is running behind a little bit, honestly, I have no idea, but it's not going to block you from using all capabilities from Git. If you want to update it, just keep in mind that within the Cloud Shell, you don't have the admin permissions to actually install it or update it at least. But you don't need to really worry about it. It's already pre-baked out of that Cloud Shell. Now from here, let's check back what we have, and to not mess up our files too much, I already created an application folder. And since we're in version 1 today, let's go all this way. And Una, you talked about creating a cat website. So let's create a new folder, and super original, we're going to call this one cats. Now, before using Git, one of the other interesting things we need to do is defining who we are. Now, there's no real authentication. It's not because I'm authenticated into the Cloud Shell that Git automatically knows who I am. So what we're going to do is using another Git command, would be git config, like writing some configuration, and we're going to use global. Now, if you check in the documentation, you're going to find there's 3 different levels. You got system specifically for your local machine, or in this case, the Cloud Shell environment. Global is, I'm going to make this valid for this repository. And you could also define git config local, and that's going to be specific for one single repository.
Where next that looks super interesting, Peter, right? So if from the same computer I have some repos for working on with my company and the other ones for some personal projects, that could be really useful.
Yeah, for example, why not? So we're going to identify who we are. We are the user learn TV Git. That should be good enough, I guess. And if you do have some options to send email, you can add your email address. And then I just need to update my parameter where it's not username, but it's going to be user email. There we go. And then validating is always a good thing. So we can do git config once more and reading out information. So if I want, I could now go back and do git config local and using my own name. And that's not working yet because we didn't initialize the repository. So what we did up till now is defining overall Git information. Like I'm going to identify myself as being the Learn TV user, just to show you how you can switch from like one identity to another and linking it to your overall Git tooling or using it specifically for your repository. Now, talking about the repository, let me clear my screen a little bit and check back, and I already created that cats folder. So that's going to be my application source folder. Now, once I'm here, I'm going to initialize this as being a Git repo. And not going to make it harder as it should be, but it's really as easy as running Git init. Now, depending a bit on the version, it's could be a little bit more complex, where it's not just accepting Git init anymore, and it would require you to add git init initializing with the name of the branch, where in the older versions, like the ones I'm using here in Cloud Shell, I could actually create my own branch, and that would be git init, adding -b for the parameter, and there seems to be a standard to use the main as Unai explained on the whiteboard. And I think that's about it, but it doesn't seem to like it. Did I make a typo? Git init, maybe double B's.
No, I think it needs to be git checkout -b.
Oh, that's right.
Which one was it? Okay. Yeah, it depends on the version, as Peter is saying. If you want to call your default branch main, it depends a little bit those first commands.
And then eventually here it's telling me like switch to a new branch main. And remember, some of the other commands we briefly touched on would be git status. And that's going to show you like there's no commits yet. We didn't create anything. We just initialized the folder. And we are using the main branch. As you can see, it's highlighted in red, which means there's something new, but there's no changes yet. And the other thing we have, and this should be super familiar for like Linux or macOS, but on Windows, it's just working in a slightly different way. So if you want to pull up like the hidden folders, we have obviously the root of our project. And more important for the topic we're talking about is that .git folder. That's what Unai was talking about on the whiteboard. That's what we call the repository. And I think that's about it for now.
Yeah, I think that's about it. I mean, in the end, the .git folder will be telling us, we'll be keeping the insights from the snapshots and all these different internal Git related stuff that will be happening on your repo. Okay, so cool. Let me take it back. We jump back into the PowerPoint. So Peter has been covering how to configure Git, setting up the repository with this global configuration, local ones that we can define. And finally, also, we'll see how we can use the Git ---- help in order to get some more information from all the possible commands that are available, even if you're going to be using mainly 4 of them on your day-to-day basics. Okay. So what do you think, Peter? Should we jump into the first knowledge check?
Yeah, let's do that. And then we could spend some time checking back if there's any question coming in from our audience. So
yeah, I think we have one of the questions that will be covered right after on the next session. So I'm going to leave it for later.
Okay, cool.
So the first question we have here is, which is of the following scenarios? It's a common use case for version control systems. Deleting earlier versions of a project file, so you know you are working only on the most current file or data. That's option A. Option B will be making experimental changes to your project in an isolated branch. And C, gathering feature requirements for a large project and communicating them to the stakeholders. What's your opinion, Peter? Which one do you think would be the correct one?
Well, like always for the ones who are taking Microsoft exams, there's always like multiple choice. And then a lot of the options are somehow similar. So it's always a little bit confusing. Let's see. Deleting earlier versions. Yeah, why not? I mean, it's yeah, probably what we're all been doing for so long. Making experimental changes sounds interesting, where I'm not really, I would say, the best coder. So I'm not always that proud of the coding I'm writing. So it might be useful for at least myself to experiment with it a little bit. And before I'm like 100% convinced that it's actually useful. Yeah, but then option C is also an interesting one, like gathering feature requirements, communicating with stakeholders, like sending some updates, knowing who they are. Yeah, why not? You need to help me, Unai. I have no idea.
I think we gave enough time, so let's go for the answer. And this time, answer will be option number B. Okay, we said that Git is mainly for experimenting and collaboration. Second one. So the second question would be, what is another name for a version control system VCS, sorry. Okay. Version management software, VMS, software control management, SCM system, software configuration management, SCM system. And I think, Peter, I was asking you something similar when we were talking about Git documentation, right? If I don't remember wrong.
Yeah, I know we joked about it a little bit, but there's nothing more important than remembering jokes. Now, before checking back on like the answers for this one, we had 100% correct answer for the previous question. So let's see what our audience is coming back with. We don't have anyone going for the first one. So nobody's going for option A.
I think
And we
that's
have
obvious,
about, we have about 50-50 for B and C. So
okay, so let's see.
it's still changing a little bit. So we might give it another couple of seconds before we expose it. Cool. Let's check back. Oh, there was a small change in the numbering, but most of the attendees actually are paying pretty
We're
good
correct,
attention.
yeah.
So thanks for that. And they went for answer C as the correct one. So good job for all of you. For the ones who didn't pick option C, obviously there's nothing wrong. You're all here to learn. So I would say pay a little bit more attention for what's still coming in the next 45 minutes and making sure that you are still enjoying the session, similar to what we're doing.
Yeah, great. So let's be jumping then to the basic Git commands. Okay, start working with it, and that's going to be related to one of the questions that popped up in our windows. Okay, talking a little bit about is staging the same thing as Git adding and all that. We are going to be covering that right now. Okay, so basic Git commands. We told you before, if you run Git --help, you're going to see a huge amount of commands. But in the end, you're mainly going to be working with these 4 main commands that we see up here: git add, git commit, git push, pull, and some few useful ones that some graphical user interfaces will let us see that information in a nicer way, but the status log and help that will be super useful. So let's jump into the whiteboard and see what they actually do. Okay. So jumping into the whiteboard, first one that we have will be the git adding, okay, command. And that's the one that happens right here. So this one is useful for answering the first question we had, okay? It's git adding, same as staging. It actually is, because it will tell us what are the files that has been modified and you want to move them into the staging area. What about commit, Peter?
Yeah, so commit is like I would say the name stands for where you're literally committing, like confirming changes. Now, commit is actually like twofold, where it could refer to using the git command, like I'm going to commit something, where I would tell you like, hey, Unai, I'm going to send you some updates. So first I'm going to commit it. So that would mean like initiating the git command commit action. But it's also like the noun where the commit is literally forcing, making changes to your source code and confirming, sharing them with your peers and confirming that everything should be up and running.
Yeah. Apart from those ones, so we also have the ones for push and pulling that Peter mentioned before, so synchronizing with a remote repository. From the ones that we were mentioning on the slides, we see here one of them is the git status. We'll see it in the demo. It's super useful. It will give us as an output the information about which are the changes you have on the working tree. Did you move them to the staging area? So what is the actual situation you have right now before jumping into doing a commit? Okay. What about git log, Peter? Can you remind us? Can you tell us what it is?
Yeah, git log. So that's where you can literally pull up like logging information. Remember I talked about the hash before. So if you want to find out like some more details about the hashing, that would be one of the comments to provide you some insights. It also allowing you to keep track of like who made the change. Remember, we ran that git config username, user email. So if you want to find out like who committed that change, it's going to show you the commit ID, like the hash, also showing you the timestamp, like when did that change happen. And I would say, yeah, super useful command. You're going to use it in real life quite a lot. But the other interesting thing, Unai, that I find out, like 2 slides back, is where in the end, again, we started where Git is like super powerful and you're going to use it, giving you a lot of capabilities. But in reality, you just need to memorize like 7 commands and you get basically like 90% of the functionality. That's pretty mind blowing.
Yeah, and actually
Would you
related
mind?
to GitLog, I have to say, Peter, I've seen some customers doing super interesting things. So the history that is being shown gives us a lot of information about changes, when they happen, what has been modified. So I've seen people even using it to automatically create documentation. So you see there's some few interesting stuff
one.
people are doing in the community. Okay, so Just the last one we have to talk about here is git help. Okay, so same as many other command line tools in the end, with the help parameter, you're going to be able to see and understand a little bit better information
That's the
about
one I'm
each
using
command.
most.
I think so. I think so. I'm either jumping to help or just jumping into documentation myself. Great. So let's try it, and let's try to follow with the demo here. Just remembering we are building the scenario of working with this CATS website. So Peter worked before on initializing the Git repository. Now we are going to be jumping on staging our first file, making our first commit, modifying a little bit the file, seeing with the git status command how everything is going. Let's start making some few commits here. Okay.
Sounds good. And
So
I'll check back for some more questions coming in from the audience. If you were joining in a little bit late, know that this session is live, which means you can get your questions answered. So please keep them coming while Unai is switching to the demo environment. I'm watching the screen if you got any questions, concerns, and remember it's part of the Learn module, aka.ms, Learn Git Intro.
Great. So I'm going to restart the Cloud Shell for me because it gets frozen after some time. Jump into that folder we have right now. Let me just try to remember it. So there is learned git live repos, cd first session, if I'm not wrong. Let's see. Git session and the cats folder. So we are located back on our repository. Okay, I'm going to clear it to make it a little bit nicer. And let's start by playing with it a little bit. So the first command that I'm going to be running here is nothing Git related, will be the git touch index. It's just a Linux-based command that will create that file and or modify the metadata for the modified date. Okay, so I'm just creating an index HTML file right here. Okay, if I go now and we try for the first time git status, you're going to be able to see that we have some untracked files. Okay, untracked files will be the ones on the working directory. It's telling me, hey, Unai, you have an index HTML file created, but you didn't git add for it yet. You didn't move it into the staging area yet. Okay, so let's do that. With the git add and the dot, in this case, I'm not selecting individual files. I'm selecting all of them. Okay, so adding it will move it to the staging situation. So I can run again the git status, and we'll see that now the output is a little bit different. What actually happened here, so we see some few more files, is in the first command that Peter was running. There's some main files, main branch related files that have been created. Okay, but let's just hold on to the index HTML one for now, just to make it simpler. So the index one, together with all the rest, have been moved into the stage situation right here. Okay, so I think we are ready to create our first commit. And how do we do that? By running the git commit command right here. Okay, telling it that we want to create a commit for the index HTML file, and with the -m, what is the message related to these changes? Okay, so if we run it right here, it was successful. One file has been changed, 0 insertions, 0 deletions. Why? Because this file is completely new. We'll see some changes happening here when we are modifying an existing file on our case. Okay, so we can jump into another git command that we've been talking about on the whiteboard. Running the git log. Peter was saying it will tell us the history. Okay, we just have one commit. This is the hash Peter was talking about, right? Peter, if I'm not wrong, this weird identifier.
Yep, that's the hash, but you only need to memorize the first 7 characters.
Oh, that's interesting. Because I'm really bad remembering names. I cannot imagine numbers. And here we have also the pointer to tell us like, hey, the head is pointing to this commit. This is where we are actually located right now. Okay, so let's try to modify the index file again. Okay, and in the Cloud Shell, if you click on code and the file, it opens an editor quite similar to Visual Studio Code where we can modify our file. Okay, In my case, I'm just gonna modify and put just some HTML property right here, pretty simple one. Save our feline friends. I'm gonna just close it. I did the change for it and I saved it. And let's check the Git status again. So with the Git status, we see, hey, Unai, you have modified the index file and you didn't stage it yet. Add it again. I'm not gonna be adding it now, and that may be a surprise for some people, okay? But it's not maybe for others, because maybe somebody was kind of asking us like, hey, Unai, I've been able to do commits directly without realizing there was a staging area in between. And that was my situation when I first started with Git. Okay, so that's what happens when you run git commit -a. Okay, it jumps directly from the working tree to the hidden to the index HTML file. Okay, so it jumps directly from working tree to repository without going through that middle stage. So that will create a new commit, and we'll see right now that if we go again to the git log, this time we have 2 commits right here. Okay. So we can actually see that we created 2 git commits during this demo. Okay.
Pretty cool stuff.
Yeah, right, Peter? Should we run an only check to see if everybody got it correctly?
Yeah, just doing a little time check. I think it might be better to move on and then doing maybe some other demos to just show them. I'm pretty sure that most of you are following along, so it's just validating some of the steps we did in the demos. If you still know what we're doing, but we might speed it up a little bit for like the last part of the session. We got about 30 minutes left and still got some other things that we want to show you. So maybe let's move on, Unai, and skip some of the questions for now.
Sure, and we can come later if we have time then.
If we do have time, why not?
Perfect.
Quickly checking if there's any question from the audience. You were going to answer that one question, right? Like, how can we undo any ads? So you added a file, but can we also undo that? And if you force the commit, how we can undo that? So we might try and show some of that in our outstanding demos. I think we are actually covering some of that.
I think we are actually covering when we talk about fixing mistakes with Git. So how we can revert back, how we can reset it. So those questions will be answered on the end of the session, on the last part of the session. Great. So with that, let's leave the knowledge check for later if we have time and jump into the next demo. So following with the same demo right here. Okay. So let me jump back into the Cloud Shell. And right here, we are going to be working again with the index HTML file. So I'm going to open it again in code. And I'm going to be adding some few extra lines right here. Okay. So if we modify some lines right here, save it, close it again. And let's run the git diff command. This is a new one that we didn't talk about, but we want to share it here on the demo too. So here you are going to be able to see, hey, what was the line that I used to have? With your change, what are the lines you are adding? Okay, so what's the difference between the state the repository had to the one that you are introducing right now? Okay? And you'll see that many tools like Visual Studio Code will give us this functionality in an easier way without using command line and so, okay, but that's how it works on the background. So let's try to create another commit right here. I'm going to quit that one, clear it again to make it a little bit nicer, and run a commit for those recent changes that I just did to the index file. So now we can see it. One file has been changed. I didn't add it. I was deleting one line. 12 lines have been inserted. Okay, so you see that this one looks a little bit different, right, Peter?
Oh, so it's not just keeping track of like the whole file change, but literally like everything you changed within the file itself?
Yeah.
Pretty nice.
And if we run the git diff right now, so let's just run it again. This time we are going to see that, hey, your working tree and the actual repo, they have the same state. There's no difference on that. Okay. Mm-hmm. So the head in the working tree and the head in the repository are actually aligned. What else could be interesting here? And I think this next command will be quite useful to the issue we had from the beginning of the repo. Okay, so if we just look for all the directory, we see that there's some main folder right here. Okay, and Git has some kind of functionality, which is the .gitignore file, which is quite useful because we can specify what are the folders and so that we may want to ignore. Because I want to ignore the main folder. I may want to ignore also some temporary files and so depending on the editor you are using in Linux, some temporary files will be created, some .back files will be created. So this is mainly the place where you're going to say, hey, these are local files. I don't want to be synchronizing them in the repository. Okay.
So that could be your personal files if you want to keep track of some of the, I don't know, your personal documentation, but you don't want to integrate them as part of the repo. Some files you don't want to share with your colleagues because they're not really part of the project, and excluding them from the Git sync. That's really what you're doing here.
Or imagine if you're a software developer, the outputs from your compilation, you don't want to be sharing them with the rest of people because you're going to do that with the DevOps tools. So let's ignore those local files that are being created whenever you are running building commands on Visual Studio. And so, okay, so that could be really useful too. So I think I saved it. Yes, so I'm going to close the editor for this one. Let's run the two commands that we need, git addin, all, and the commit again. Okay, so ignoring editor backups. That's the message that I'm including for this one. Okay, so one file has been changed, 3 assertions, the 3 lines that I've been creating right here. Okay. So let's keep on improving our demo, right? Because we only have an HTML file. What about the style, Peter? Maybe we should create some CSS files right here, right?
Yeah, go ahead. You're doing awesome, and looks like the audience loves it. By the way, could you do a little shout out to Kingston? She's one of the Learn Live fans, apparently. So, hey,
Perfect.
Kingston, thank you for
Kingston.
joining us once more. Hope to see you in 4 weeks from now for me and Unai next week as well.
Yeah, I'm going to be watching for you next week. I'm going to be waiting for you. So I just created another folder. And as you see, if I run git status right now, surprise, I created a folder. Git is not tracking it. Okay, so Git track files. It doesn't track folders. Okay, so that's something that is quite interesting and it may surprise you in the beginning. Okay, so that's something that we need to be aware of. Now what I'm going to be doing is I'm just going to be creating some simple style file. Okay, so just creating a git kit file right here and moving it into the staging area. So I'm creating a style file and moving it into the staging area with the git add command. Okay. If we run now git status, sorry. So we can see that a new file has been created right here. It tracks the file. It didn't track the folder when it was empty. Okay. But I don't really want this file. Okay, I want a style file. So I'm just gonna remove it right now. It was just an example to show you how the git status will be able to track it. Okay, so just remove that one and really create the one we need. So we need to create the site.css file, and I'm gonna open code for modifying it. Here, I wanna be adding some few lines to define the style of my solution. Okay. Opening code, saving those changes, closing the editor, and let's see, because I want to be modifying the index file too again. I'm going to be adding some few things on that one. I have to jump back to the previous folder, to the root folder where the index file is. Opening the index, I'm going to be adding after the title some other element of my HTML file to make sure that it's using this new style file that I'm using right here. So with all of that, I think I'm ready for creating a new commit right here. So let's run again the git add dot and the commit. We'll see that now the history became a little bit longer, right, Peter? It should have become longer. And maybe it's not that easy to understand it right now, right? Imagine we've been working, Peter, for a few days right here, opening the Git log and getting so many messages. It could be a little bit difficult.
Overwhelming.
Yeah, overwhelming and difficult to track, right? So for making this information come a little bit shorter, we can use the git log -- or -- one line. Okay. So you see that now it's much easier to read, right, Peter? And as you were saying, I think you were mentioning this one, right? I just need to remember the first 7 characters of this identifier.
Yeah, because I mean, like before, we briefly touched on it, where well, it's always interesting to like know the comments, but you don't really need to memorize them depending on the tooling you're using. But like in Visual Studio, VS Code, even in other DevOps tools like Jenkins, TeamCity, and whatnot, you're going to see that they're all keeping track of all those commit changes. But if you're not using any of those tools, nothing would technically block you from just telling like your colleagues, like, hey, Unai, I just committed change 6EF. And then you could immediately check the Git log and finding out like, oh, Peter made a change and adding some CSS style sheet, because that's the reference to the hash that I mentioned you.
Great. That looks super interesting. So let's go back to the slides. So here we've been starting to modify the index, creating subdirectories. Reminder, it doesn't track directories. It tracks only files right here. Right, Peter?
Mm-hmm. Yep. So, no, go ahead.
Go ahead, please. Sorry.
No worries. So, yeah, it's tracking the changes. So, in short, what we did in this demo is starting from that folder, creating the cats directory in the previous demos, creating that index HTML, making some changes, adding the CSS file, replacing files, listing commits, validating the logs. That's everything we did for now. But up till now, everything worked out pretty well. But I can imagine, and if I look back on some of the feedback, it's not always that easy, right? Like every now and then something can go wrong. So why not spending some time talking about like how can we like revert what I call the oops admin, where you did something, you're like, oops, sorry, made a mistake. And maybe sharing in the last 15, 20 minutes we have, like how we can fix some of those changes.
Sure.
And I mean, in the end, anything can go wrong, right? We're using technology, we're using maybe some, I would say, unfamiliar tool, although I hope out of this session that the ones in the audience are becoming a bit more familiar with Git. And again, if you've already been using Git for a while, feel free to share some feedback in the chat box as well. But no matter how long you're going to use it, even earlier today, in one of our internal Teams channels, I saw a message coming up like, oh, I made a mistake just by firing off the wrong Git command. And I mean, it all happens, right? You might be super experienced, you might be totally new to the tool. And in the end, we all know that at some moment in time, something will go wrong. Now, the good news is that Git is there to help you from the start, giving you a lot of capabilities, and at the same time, also allowing you to go through some easy fixes. So a couple of scenarios, and Unai is going to close with that in a demo. But for example, imagine that you made a change in your file, but it's not like that important change because you just made a typo. Like when Unai was injecting that link to the style sheet, and it could just be a typo, like the file is not called like site.css, but we typed in like site.cs and just missing like one character. You could go through the file, make the changes, committing the changes, creating a new update, but maybe you just want to make that update without like creating a new commit. So one of the small mistakes you made, like a typo in your code, you could easily like hide that update and reusing the commit using the -- amend flag. So that's going to allow you to like update the change you made, but actually using the previous commit as the argumentation for that. Or you could also extend it and adding another parameter where you're going to add the no edit. And that would also help you to amend the change. So it's allowing you to update that, for example, index.html file we're using and updating the path. Where now you're going to run git commit, and Unai will show you that in a demo in the next couple of minutes. Git commit, add the amend setting and the no edit parameter, where the -- amend option is committing the change, but using it as like changing history. And how cool would it be if you could actually go back in time, like maybe Back to the Future, or just going back in time and pretending like nothing really happened, you didn't make any mistakes, and the file is still up to date. So that's definitely one other convenient command, I would say, that allows you to make some changes without committing a new change. And talking about changes, we already touched on like the cool thing about Git and using that for history. So what you can do is literally changing history. And I know it sounds weird, but it's super useful. You're going to find out that whenever you start creating documentation, updating template files, or updating full application source code, that every now and then you're going to make some mistake, little oops, something happened, and I'm just quickly going to fix it. And I don't need to do like a new git add, make the changes, new git commit, and you can just revert history a little bit. That would be I would say the main message. Or
yeah, I would also add here that we have to be really careful. Like history in GitHub can be changed and it actually needed sometimes. So imagine that I'm introducing some sensible data on a file. Even if I delete it from the actual file, we have it on the history. People can go back to it and check that information. So treat it really carefully, but it's actually a super powerful tool. And we'll see right here. So one of the commands is using the checkout for recovering a deleted file. Okay, so if you deleted the file from the working tree, remember we have the index and the repo. By using git checkout, you're going to be able to come back to the state the index was having. Okay, so that's a way of easily recovering a recently deleted file. Okay, that's because we only deleted it on the working tree. What happens if we delete it also and we let Git know that it has been deleted? Then the checkout wouldn't work because it has been modified from the working tree and it has been modified from the index. We'll need to use other two commands that we are going to be mentioning right now: reset and revert. So reset and revert. So reset will be that one that will give us the option to take changes coming from a repo. Okay, but we'll see it here that resetting is actually something that will modify the history. So we have to be really careful with this one right here. And I'll try to open the whiteboard later to show you the main difference between revert and reset. Reset, you go back to a commit, and the ones that you left there hanging are going to be deleted in the future. Okay?
That could be tricky as well, right?
It can be really tricky, especially when we work with remote repositories and so. The other one, maybe a little bit easier to use, maybe. We'll see it later on this whiteboard. Reverting, what it's doing is not deleting some few commits we have in history. What it's doing is, as the name says, do the opposite as a specific commit we are specifying. Okay. Right, Peter? Do you want to jump into the whiteboard maybe let's see this difference between the two of them, and you can explain it maybe here in a graphical way. So,
yeah, just go ahead, I would say. It's your whiteboard, so just go through. I'm just going to check if there's any last questions coming in.
Perfect. So from what we've been explaining, reset, so this is the one that is missing right here. Reset head -1 will take our repository to the previous commit. This one will be deleted in the future. compared to revert, which is the second option we see right here. If I say git revert head -2, we are going to be adding an extra commit that will undo what we did in this one right here. So you see here the difference between resetting and reverting.
Way cool.
Great. So maybe we can try quickly the last demo we have for this session. Let's jump into the same environment we've been using up to now. Clear it. And let's imagine that what we were mentioning before, I'm going to be removing the index file. If I remove it, so you can see, I don't have index file anymore. Okay. I just see the CSS and the main folder. What if I do the checkout? This way of recovering what we had in the index, so recovering that file. So right now, I get back the index file. Okay, so you see it, nice. Super useful right here. Compared to the other situation, what happens if I remove the index file, but I'm telling Git that I'm removing it? Okay? Then the checkout won't work. Okay, if I try the checkout right now, I get an error message. I don't have it in the working tree. I don't have it on the index because I let Git know, right, Peter?
Makes sense.
So that's when reset comes to the rescue. We'll tell the repository, hey, reset the head and get the index file from it. Because we know the head, that was the last commit, has the index file. So we can come back to that. Okay? It will appear as an unstaged change. So if we check it out right now, so it's like it moves it to the index. And from the index, we have to move it back to the working tree. So that's what we can do with the checkout, as we said before. And that will give me back the index file on the working tree that I have. Cool, right?
I love it, man. I love it.
So I think that's pretty useful in terms of demos. Should we be jumping to maybe the last knowledge check and from there to the end of the session?
Yeah, so a quick time check looks good to me. Well, I think it's probably a good time to wrap it up a little bit. And I would say to our audience, congrats, you somehow made it through this first session. We're not 100% finished yet, but just want to close in a nice way. And just quickly going back to
Hello, everyone. Good morning, good afternoon, good evening, wherever you are. My name is Laurent Bugnon. I'm a cloud advocate with Microsoft. Sorry about that. And today we are going to talk to you in this new Learn Life series about Git source control. And I'm going to be joined out of Spain by my colleague Unai. Hello, Unai. How are you?
Hello, Laurent. I'm really happy to be here for this second session on Git. Some of you may remember me from the first one. My name is Unai, Azure Technical Trainer, and I'm really happy to tell you more about Git. I've been helping many customers working on Git, migrating from centralized to distributed, and can't wait to show you, again, for the second time, the cool benefits Git is bringing us. What about you, Laurent?
Yeah, I'm very excited too because Git has, taken such an important place in my life. And you're a little bit younger than me, but I'm old enough to remember when source control was this. Okay, that's a 3.5 floppy disk. And what we were doing in the times when I started coding in the 90s was basically doing a zip file and putting this zip file on a 3.5 disk and then saving that somewhere. So this was source control in the days. But of course, after that, we started using, software. And the first source control software I used, I can't remember how it was called, but it was on DOS back then. And then after that, we went to a Visual Source Safe. And so Visual Source Safe is one that I really remembered. It was a centralized source control system. Later, we got Subversion, which was also centralized. And then eventually, we finally got, distributed source control with Git. And of course, GitHub, which which is a real game changer for the collaboration. And so for everyone here in the audience, we want to remind you, or possibly tell you, if that's the first one that you see, that this is the second of a four edition series on Git. And the very first one was last week. We have this one today. And last week, you, Unai, and another trainer called Peter, you talked about the introduction to Git. And today we are going to do the collaboration with Git. And then after that, next week, you are going to talk about branching and merging with Git, and eventually talking about GitHub. So maybe it's a good place to remind people that, first of all, this is an introduction. So if you're looking for 400 level, this is not the place to be here. We are doing an introduction to Git. It's a great place to maybe remember some of the concepts that you learned a long time ago, or maybe even to learn a new concept. And also, Unai, I think we are not really going to talk about GitHub here, right?
No, so we have other 2 sessions coming. We may reference GitHub a little bit because that's how we mainly work normally. Even if we are looking for the insights of Git here, we'll show you the normal ways or the more frequent ways that we work with Git in the end. Okay, just reminding you, this is a live session, so please let us know where you come from, what's your experience with Git. Let us know any questions you may have, and we'll try to answer them. Okay, so as Laurent was explaining, 4-part series. This is the second one, and it's related to this module that we call Collaborate with Git that you can access through aka.ms/learn-git-collaborate. If I actually open it on my screen, let's try to show it to you. So I'm going to try to load that website. You'll see that this is a real module we are going to be talking about, okay, composed of multiple sections. We are going to be covering cloning, pushing changes, stashing the changes, so letting them a little bit outside, and how to do this pull requesting flow in the end. Okay. Today, more from a command line perspective. Probably in the next sessions will be more related to this GitHub kind of flow with pull requests. Okay, so please feel free, once you watch this session, jump into the module, review everything Laurent and I will be explaining. Feel free to try it, right, Laurent?
Absolutely, and in fact, like you mentioned, this is a live session, and we have moderators who can answer your questions. But we are also happy to answer your questions ourselves. And so, if you have questions that you want us to answer live, please put them in the chat. Either the moderators or ourselves are going to be able to do that. And we also want to hear from you. For example, I would be very curious to know: are you using Git right now? If yes, are you using Git with GitHub or with another system? Maybe it's Azure DevOps, or maybe it's even your own, source control. We'll show you in the demo a little bit later how you can do that if you want to put, a repo on a share, and then after that have people pulling and pushing from that. So definitely, we'd love to hear from you. What do you do with Git? How do you use it? And any questions that you might have. So without further ado, let's go into the introduction and let's get started. And like Unai said, Unai has already presented the first session 1 week ago. And this session was an introduction to Git. And I think it was something about cats, right, Unai?
Yes, so it was just the very beginning of working with Git. We started covering a little bit what were the Git configuration options, how we can configure Git locally on your computer, define different configuration settings for each repository in case you may be working on personal projects together with some company-related projects. And in the end, what we see here, we just show you a little bit how we keep track of changes, how can you recover from mistakes. And we did all of that based on a demo scenario that was creating some website for cats-related pictures. I told Peter the last time I prefer dogs actually, but we'll keep it, I think, for this session too with this cat-related website, right?
Well, the good thing is that literally nobody ever thought of putting cats on the internet. So I think you might have a winner here. You might have really the next big idea, and maybe you'll become rich with that. So I think this is really cool idea there.
Great. So yeah, I think that for that one, right? we are going to be following that demo scenario, right?
Yeah,
Laurent,
exactly.
maybe...
So we are going to be following the demo scenario and basically building on top of the demos that you gave in the first session. We are going to see now how you can collaborate, because building a website is the first step into becoming rich, but at some point you're going to have to collaborate with people. And of course, Git is going to be a great way to collaborate. And so let's imagine that, you have this great idea about the cat website that you mentioned, but suddenly you realize that it's a little bit too big for you, and you maybe go to a pizza party or something, and you decide to collaborate with people and to have them help you with that. And I see that we have already a few answers. So we see some people, JScript, which I think shows that he's using JavaScript, at least I hope so, says that yes, he's using Git daily with GitHub. And so this is great to hear. Like I said earlier on, we are not really going to talk about GitHub in this particular module. That will come later. But again, it's a refresher about some basics of Git. Mohammed said also yes with GitHub. And Andrew says no, he's just learning at the moment. So I think this is the right place to be for you, Andrew, because you're going to see the basics, and then after that, if you stick with us and continue later next week and the week after that, you're going to see how you can start using Git with GitHub as well as with other tools like Visual Studio, for example, Visual Studio Code in particular. So in these pizza parties that I mentioned, we have people who are there, notably our good friend and cat lover. She's a little bit more of a designer, Alice, who says she wants to help us to build this website and maybe to design it a little bit better. And so we are going to have a few steps. So where do we start, Unai?
So in this case, first session was just about ourselves working on a Git repository. Now we have, as Laurent is saying, Alice that wants to help us a little bit with this project. So we'll have to divide or clone this repository. So we need a copy of the first repository, sync between them. We'll see what are the terminology we need in here. The first one will be actually cloning, that will say, hey, I want to be copying repository number A. I'm going to call it B. You can put the name you want to, but in the end, it's going to be kept length. There's going to be a link between the both of them. Okay. And in our case, we are going to be trying to see how we can clone in the same file system. But the most frequent scenario for those ones that are telling us they are using GitHub in this case, the main repository, the original repository, will probably be hosted in GitHub, Azure DevOps, or any other kind of Git hosting service in this case. Okay, so file system, we see it in the actual next slide, right? We have file systems, SSH path, and URL access. Those are the three ways we have for being able to clone a repository. Okay. In our case, as we are going to be based in the scenario in a local computer, local file system, we'll use the first option right here. But the most common one, I think, will be the URL one. What about you, Laurent? I just used, I think, the third option mainly 95% of times.
Yeah, I would even go as high as 99.9% of times, to be honest. And I think the 0.1% of times where I didn't use a URL was when I was doing the demos of this Learn module and training to give you the training, right? So rehearsing and etc. Because it's true that the most common scenario is probably that this repo, the naked repo, if you want, the original repo is probably going to be placed on a website somewhere, possibly GitHub, or maybe there are other providers. For example, Azure DevOps works with Git as well. So this is the most common scenario. But interestingly, using the file system actually allows you to try things out, and without risking, to publish anything to the world or etc., allows you to really try things out for yourself. And it's been actually a very interesting scenario for us to work with that. So the demos that we are going to do, this is something that you will be able to do later when you want to work again through the steps of the Learn module, and I'm going to show you that in a moment. So what are we going to do? Well, first thing, which is really important, is that when you see, we are going to work with the CLI, right, with the command line interaction in a console. You're going to work into a sandbox. For us, Unai and myself, we are going to use the Cloud Shell so that it allows us to collaborate a little bit easier. But whatever you do, you really need to type every single character, because in the command line, every single character counts, and you will see what I mean in a moment. Also, notice that we are going to use a unique syntax. So, casing matters. For example, if you have an uppercase or lowercase, it's not the same in Unix, which is slightly different from Windows. I'm a little bit more used to Windows, but this is good to know. So what are we going to do? In this demo, we are going to clone the repo, which means that we are going to set everything up, and we are going to start by really just creating a repo. This is going to be me playing my role, or myself and Unai's role. And then after that, we are going to take the role of Alice and clone the repo. So let's see how this is going to work out. So I'm going to go into a web browser, and here you see that I have the module open. All right, so this is exercise 1, which is cloning a repo that we are going to do now. And like I said, when you go to this module, it's going to give you a sandbox. And so just to remind you, if you have already done some Learn modules like that, or to show that to you if you have never done it, you have the possibility to do that in a sandbox, which means that everything will be deleted later. So like this, there is no risk. It's absolutely free. Also, you don't need to pay anything for those resources. However, in our case, we are going to do that in the Cloud Shell. It's just so that Unai and I can collaborate on that a little bit easier. So let's see what we have here. We see that we have Git session 1, Git session 2. I'm going to change to Git session 2, which is the one where Unai and myself are going to collaborate. And notice that this is empty. So this is where we are going to start our work. So I'm going to make a directory, and I'm going to call that cats. Let's do that. And then I'm going to change to cats. And then in this repository, I'm going to start creating something. So as you see, here's the instruction. I have already done that. First thing I'm going to do is git init. And here it depends a little bit on what version of Git you are running. So you need to be a little bit careful here. So let's check out what version I'm running. I'm just going to type git version. And as you see, I'm running a relatively old version of Git here in this environment, which is 2.20. So 2.20 means that I need to go here. If you have a newer version, 2.28 or above, then you can use here the first set of commands. So I'm going to copy that. And the first command is the most important. It's git init. It's going to tell Git to basically prepare this repository for later. And then we are going to do git checkout with a -b. So the way that Git works, as a quick reminder, is that you have the git command, and then after that you have a subcommand, which is in that case checkout. Here in that case we had the subcommand init. Sometimes later you will see we have pull, push, commit, etc., etc. And then we have options. In that case, -b, which is the shortcut for a branch. So we are going to say, please check out the branch called main. And main is very often what people use for the default branch in Git, in GitHub, etc. Sometimes if you go into a little bit older repository, you may see the name master, but we are trying to move away from the terminology master because it's a little bit loaded connotation. It's not something that we like to use so much anymore. So now typically we say the main branch is actually called main, which totally makes sense. Cool. So the next thing that we are going to do, we are going to configure Git, because every time that you commit something, that you push something to a repo, we want to be able to identify you. And this is important because we can, like this, track down what happened, the whole history of what happened. So to do that, I'm going to type git config, which tells Git to configure. And this is something that you're going to do just the first time that you use Git in a given environment. Okay, so git config user.name, and then I'm going to type my name, El Bunion, or I could say, well, in that case, I'm going to be, Unai or myself, etc. So in my case, I'm just going to say El Bunion here, and then I'm going to say git config again, user.email, and just enter my email address at microsoft.com. All right. Once this is done, we can go and start creating files. So you see touch here. Again, if you're coming from Windows like myself, it's a little bit unusual, but this is actually something which tells here bash, so Linux, to create a new file. And so I'm going to create the new file directly into this cat folder. So I'm going to touch index.html. And so if I do a dir now, you see that the file has been created. That's cool. And then we are going to create a new folder CSS and then touch something inside there as well. So let's do mkdir CSS, all right? And then I'm going to touch css/site.css, which is creating this file. Now, at this point, I have one folder and two files created, and I'm going to add everything into Git. And to do that, I'm going to type git add period. And so again, remember earlier on, right, I told you that every character counts, and the period character here in the command line means this folder. So it means that I'm going to add everything which is inside this folder. And if you forget the period, it's not going to work in the same manner, okay? So be careful about that. And finally, once I have added everything, I'm going to do git commit. So again, this is a very important command in Git, because it's going to tell Git that now I have added everything into Git, but I also want to do a commit, meaning that I do kind of, if you want, a milestone in the history of my project here. And so I'm going to do -m, which is a message, that's the option. And I say I added index.html and site.css. Try to give a meaningful message, especially if you collaborate, so that anybody who's collaborating with you knows what happened here. All right, you see that I have some confirmation. I have added those. This is good so far. So now we are going to use code. And so Unai, are you using code, Visual Studio Code in your environment, day-to-day environment, or what do you do typically?
So I'm normally giving workshops to customers, and we use Visual Studio Code, the full Visual Studio,
right.
A little bit of everything in this case, and mainly just reminder for those that came to the first session, you've seen that Laurent is using the git config without the global parameter. Why? Because as we are telling you, we are trying to simulate this scenario from the same computer that we have multiple collaborators. So each repository, each folder will have a different owners. In this case, the first one will be Laurent. Yeah. Also, maybe reminding from the first session how Laurent was saying to use git add period. We said in the first one that you can also skip that step if you put the git commit -a, which is kind of the same thing. It's just moving from the working directory directly to the repository. Just reminding a little bit those facts we explained on module number 1, on session number 1, sorry.
That's very good. That's very good to remember. And in fact, later we are going to do a git commit -a. And so again, we have shortcuts, etc. But it's good to know that you have those two operations coming up, right, when you do a git commit. So this is good. So Unai, you said you are using Visual Studio Code, and I'm using Visual Studio Code a lot. But, you can also use Visual Studio Code directly in the Cloud Shell. And this is quite impressive because it gives you a full-blown editor. And for people who have used other editors in Linux, like, for example, Vim, you know that code is kind of an improvement on that, right? So I'm going to open here the index.html in Visual Studio Code. It is empty at this point. This is correct. I have created it using the touch command, but I have not added anything. But here I have a chunk of HTML code. So I'm going to take that, and then I can go and simply here paste it. And then I will save this and close the editor. So here I have a very nice editor in here in Studio directly. So this is pretty good. So once I have done that, the next step is going to be to also edit the CSS file. And so let's change to the CSS file, CSS folder. And then I'm going to do code site.css. You see that I typed a little bit faster here. I use the tab command to autocomplete. Okay, this is something you can do in Bash, which is quite convenient. And then after that, if I go down, you see that I have here again a block of CSS. So I'm going to take this and put this here. Let's go and let's go and save. All right. Sorry, I zoomed out a little bit for some reason. I'm not sure what happened here. Voila, now I zoom in a little bit more. Perfect. And so at this point, I can go and save and close the editor. All right. And now it's a little bit too big, so I'm going to zoom. Here we go. Those shortcut commands played against me a little bit here. All right, so now at this point I have saved that. So now let's go back to the cats directory, which is the top directories that we created earlier on. I'm into cat, and now we have done some changes. So again, what we are going to do is commit those changes again. So to avoid having to type everything, I'm just going to copy that and paste it here. So in order to paste, you do a right click and then you paste. The first one was executed automatically. Second one, it's waiting for me to press enter, but here it says git add period. I add everything, all the changes, and then git commit -m for message, add simple HTML and style sheet. Let's do that, and we see that we have 2 files changed, 15 insertions. So basically it's counting all the lines that have been added, and that's good. Now, one thing that you can always do in Git is check what happened in the log, check the history if you want. And we are going to do git log, but if you just type git log, it's expanded. It's a little bit hard to read. So here again, we can use an option which is -- online. And so what's the difference between -- or single minus? Basically, the single minus is often a shortcut. It's a shorter version to do. Like before, we have -b for the branch. If you have the expanded version, it's -- So here, if I do not online, but one line, be careful, then you see that you have everything on one line, and you have here every commit appearing on one line here. So this is convenient. All right, I believe we are at the end of the first demo, which was how to prepare, how to do the setup. So now let's do something a little bit more interesting, which is playing the role of Alice and cloning this repo. So in order to do that, I'm going to change to the top folder, and then I'm going to create a new folder, which I'm going to call Alice. So basically, we are here simulating that Alice is on another computer, which is on the same network or even a different network. We are just going to keep everything here because, again, it's an introduction to Git. So I created this folder. I'm going to change there. And now I would like to get everything that the original person did, right? The index.html, the CSS file, but without having to retype everything myself. And the good thing is this git clone command that we are going to use. So how does it work? I'm simply going to say, I want to clone, and then remember clone, you can give a path or a URL. In that case, we give a path, which is, one folder up, and then the folder cat. And then don't forget the period at the end. I want to clone this remote, repository, which is called cat, into the current folder, which is the meaning of this period. So now I do that. Now it is done, which means that if I do a dir at this point, you see that I have brought down index.html and CSS, and also the site.css, which is inside there. So that's pretty cool. All right. So now at this point, we are ready to continue working. We have cloned that, but I think it would be good probably to see, a quick reminder of what we did. And Unai, I believe you have prepared a whiteboard for that, right?
Yes, so we have a whiteboard just explaining a little bit this first scenario. So just sharing it right here, pretty simple. We started with this cats main folder that we created a repository with Git in it. Laurent was configuring, he's the owner of the changes on that repository. So we are working on the main branch, and we just worked by editing and adding some HTML files. So something wrong here, don't worry. And the CSS folder, okay? So just defining the first main base repository we are gonna be working with, and from there, preparing the context for Alice. So we created another folder called Alice, which will clone the cats repository. Okay, so that will have already, we'll see it later on the next part of the demo. We'll have the copy of what the original one had. And by default, when you do a clone, we'll see that there's also a remote reference to the first one. Okay, a remote called origin, automatically that will be pointing to the cats repository. So it knows where it has to take the updates from. Okay, so and synchronizing that happens from cats to Alice. So the direction would be this one right now. Okay, and we'll see how to evolve on this on the next part, right?
Excellent.
Great. So I think that brings us to the first knowledge check of the session. Okay, so please collaborate with us and let's go reading the first one. I'll be reading the possible answers we have. So the first question would be, what is the primary advantage of the distributed nature of Git? Option number A, on one letter A, not number. Git automatically merges saved changes from multiple remote authors into a single project repo. Option B, multiple remote contributors can work together on a project without fear of overriding each other's work. Contributors can check changes from another contributor before merging them into their own. Option C, Git distributes files and folder structure to each contributor's machine across a wide area network for safekeeping. This architecture provides highly secure data storage and ensures that project repo data can't be corrupted. So what do you think, Laurent, while our attendees are thinking on an answer?
Yeah, it's an interesting question, really. And, I think that in those polls, there is always one question which you feel is probably not correct, right? And here, the one with the wide area network for safekeeping and the secure data storage and can't be corrupted. It sounds like a lot of mumbo jumbo, right? And so I feel that it's probably not that one, but maybe I'm wrong. I don't know. No, seriously speaking, though, I believe that if Git was automatically merging changes, that would be pretty bad. You will see that when you do a push or a pull, there is some automatism which is going on with the merge, but there is definitely, Git is definitely going to ask you if there is a doubt, like, do you want to merge manually, and make sure that everything is going on. So it's definitely not answer A. And answer B, on the other hand, multiple remote contributors can work together on a project. Well, that's kind of exactly the idea of Git, right? There is no fear of overwriting each other because there is this merging scenario with a check. And if there is a conflict, if there is something which feels weird, then Git is going to ask, you should do this merge manually and decide manually who wins basically between the remote and the local file. So I think that this is clearly answer B. And I'm curious how many of you on the chat have said B, and I see that everyone in YouTube and Twitch is answering B. And so this is good to know, and it means that you have followed pretty well. And so it's a good success. Unai, what do you think?
Yeah, I think all of them got the answer correctly, and I think they all followed the same tips as you, like what area network wasn't really clear. Automatically merging also was kind of the tips for having another incorrect answer, so option B was the correct one.
Excellent. Cool, so we can move on to the next topic, right?
Yeah, and the next topic will be, now we are connecting repositories between each other. It will be related to synchronizing, of course, and the first terminology we have to be reviewing here will be the pooling, okay? But for pooling, coming back a little bit to this whiteboard scenario I was showing you, what we are going to have in the end is your repo having some remote references. Remote, in the end, what it's defining is, hey, there's another repo located here, and I want to be taking changes from that one. Taking those changes will be Git pooling, okay? Pushing, as we'll see, is sending your changes to somebody. Sending your changes to the remote repository. Pooling will be taking updates from that one into your copy, okay? So those are the two main, let's say one of the two most typical commands that I'm using nowadays. I think if I have to say the most common ones that I'm using would be git commit, git pushing, git pulling. What about you, Laurent?
Yeah, I think you're absolutely right. This is really when you have something which is going on like a normal flow of action. I would say creating the repo happens once, right? So you do it. Cloning happens once in the beginning as well. But then after that, you're really committing, pulling, and committing, pushing, and then pulling also when you're collaborating. So totally agree with you there.
Great.
And
in fact, yeah.
Oh, sorry. Go ahead.
So I was just giving the introduction to the next slide. So maybe people with more system administrator profile, they kind of think that pooling, as it's copying changes from one place to the other, could be quite similar to these two commands that we are mentioning right here. So the SCP command and the rsync command. I don't know your experience, Laurent, but myself personally, I've never used them, but it's quite interesting to know about them.
Yeah, I think, like you say, it's about being a sysadmin, and when you're a developer like myself, and especially on Windows, those are not commands that we use a lot. But good to know that they exist, and good to know that Git is doing something similar, right?
Yeah. So we'll see that in the end, Git is probably implementing these kind of commands on the background. We have the SCP that will, in the end, copy everything, copy from one folder to the other. And the rsync that has a little bit more intelligence behind it is just copying whatever is different from the other path. Okay, so I would say the second one is more related to what pooling will be doing. Even if pooling is a little bit more complete, we'll see that based on what we saw in session number 1, it looks at the history, and those missing pieces we may have on the Git history, those are the commits we are going to be transferring from one place to the other in the end. Okay.
Yeah, exactly. Because this is, in fact, the important thing to know about Git is that it is extremely efficient, right? And so when you pull something, Git is going to look at the commit. And I can probably start sharing again. Git is going to look at the commit, and it's going to know what was the latest commit that I had. Because it keeps a list of all that, so it keeps a history of everything if you want, and then it's going to make a pack by taking only what changed since the last time. And this is really good because, like we said, very often the repository, the main repository, if you want, like the root, the origin, is located on a server somewhere, and very often you pull everything via web protocols such as HTTP, etc. And so you want this process to be as efficient as possible and as fast as possible. And so this is what happens. There is, give me the differences between the last commit that I have here and whatever you have, the latest commit that you have on the remote origin. And then after that, this is bundled together, downloaded, and then it's unpacked. And then after that, the history, the tree, is updated by Git in the local. And like this, we know that we have the latest. So this is pretty good. Creating pull requests. It's also something that we do fairly often when we collaborate, especially when there is a permission issue. So if you have worked like myself, very often we work as a single developer on a repo because we are doing some work and then we are pushing all the time. It's fairly simple because we own this repository and then we can just push into it. But if I start collaborating with something, there is, a safety issue, right? Not just in terms of security, but also simply in terms of not having somebody else who might be maybe, a developer who is new on the project, who doesn't know the whole history of the project. Having this person pushing directly into the repo can be a problem. And so very often what we do is that we disable collaborators. We prevent collaborators from pushing into the repo directly. And this is where the pull request scenario is happening. So how does pull request work? Well, in terms of code, this is what's going to happen. So you're going to say, when I want to push something, I'm going to say git request-pull, and then I'm going to say -p, which is a path, origin-main. So I'm going to say, all right, when I'm pushing something to the origin, to the main branch, don't push directly, but do a pull request instead. And really the main advantage of this pull request scenario, which we are going to illustrate later with a demo, is to provide the owner of the repository with the possibility to do a review before accepting or rejecting the change. And earlier on, we told you that, we talk a little bit about GitHub. I think this is a good place here to talk about GitHub a little bit, because if you have never worked with Git, a good place to start is by looking at open source repositories on GitHub and collaborating with them. And collaborating can be something as simple as correcting a typo in their documentation, for example, right? So if you read the documentation, which is in, for example, in the README file, and then you see there is a typo, there is something, you can actually go and edit that directly. And since you're a collaborator who doesn't have a write privilege on the repo directly, you're probably going to have to submit a pull request, and you're going to see that there is a whole process. In fact, something really interesting is that when you do a pull request, there is also a UI on GitHub for discussion. And this discussion is a great place to know more about the people who maintain this repo, right, Unai?
Yeah, I mean, I think that's the way I work with. I mean, I'm also giving support with Azure DevOps, so I have the both pull request on Azure DevOps, GitHub and so, but here's the main idea. As Laurent was saying, in the end, the original repo main branch may be the version of code that you are publishing to production. So we need to protect it somehow. Okay, and that's what we do with pull request in the end. Instead of sending changes directly, the main branch on the server side will be protected, and people will have to propose changes. I'm saying, hey, these are my changes, this is my experimentation, take a look at it, review it, and if you think it's okay, you will pull it. Okay, you will take it. And that's one of the main powers, I think, in terms of Git. More when we talk about GitHub and so that have discussion panels, they have many automation behind that we'll be covering on next sessions, in which you can make your pull requests really complete, make sure that everything works fine before you accept any change.
And this is what we do when we evaluate and merge a pull request, right?
Yeah, so in the end, as we are going to be showing it right now, we'll have our repositories with remote references, knowing where each other are located. One of them, the experimental one, let's say, will create a pull request. The other one, the original one, will have to review it and we'll have to pull those changes in case we accept them. Okay?
And you can also reject them if you're not happy with those changes, of course, right?
Of course, and that's how mainly I think open source works in the end. In order to keep your original repo quite clean, there's many contributions that will be taken into account, but maybe others will be not good enough, or that's where we have the discussions in order to evolve this pull request original petition, go evolving it in order to make an acceptance of a valuable change in here.
Absolutely. So now I think it's time for a new demo, but I'd love to hear more about people on the chat. So don't hesitate to let us know if you think this is valuable content. If you have questions, don't hesitate to ask as well. If you think we are going too fast or too slow, just let us know. But Unai, I think you have a demo to show us, and this is about making a pull request, right?
Yes, so it's going to be the second part of our exercise. We'll be trying pull requests and so let me just get it ready. Let's open the Cloud Shell that Laurent was talking about in the beginning. I'll have to probably refresh it, because it lost connection to it. So let's just reload this one. Just remembering the Cloud Shell is just a cloud-related shell command in the end with a Linux machine on the background that Laurent and I are using for just sharing the same environment. Okay, similar to the sandbox you are going to be using in the end. Maybe I'll take a little bit of zoom out. There could be great. So I'll have to jump again to that directory that Laurent was showing before, is the learned live repos directory on capital letters, because this is Unix based. Oh, no, cd learn live repos. We have one that is git session number 2, if I'm not wrong.
Git session 2, I think, yep.
Yeah,
exactly.
And there we have the cats folder and Alice folder. So let's locate ourselves in Alice folder. And if we try to run here, let's see what we have. Okay, we are located probably in Alice's folder. If I go for listing all the files, here I can see I have the .git. So this is a Git repository. We have the CSS folder and the index.html. We can see that the actual cloning worked. We have the same content that Laurent was working on the cats folder before. Okay. If we do a git pull right now, we just clone it, so probably we don't have any change to take. But let's try it. Already up to date. Okay, there's no changes on the cats folder created by Laurent that I should be taking yet. Let's try to work with this a little bit and show you a pull request actual flow. Okay. So first thing for that, if I don't remember wrong, Laurent, you didn't specify the Alice related information, right?
That is correct. I didn't.
So let's put
and
it
I didn't need it because I didn't push anything, right? So you need it absolutely when you push, but as long as you're just pulling, you don't need to say who you are. In fact, pulling from a repo which is public is always allowed, right? There is no permission there.
And actually, that's the actual reason. We didn't do a commit, and in the commit is where we are saying who did it and when did he do it. Okay, so now we are specifying, hey, my name is Alice. It's not, it's Unai, but for the situation is Alice. And alice@contoso.com is the email we have to be using. So with that, we have already created a proper environment for creating our first changes. So I'm going to be opening the site style file, so site.css with the code editor, and I'm going to be modifying the second line for this one. So the body will be a little bit different. Okay, so let's create this change, just modifying a little bit the background color for this website, closing the editor. And from here, this time we are going to be using the commit directly. But as you see, it's commit -a, so add all the changes, and M40 change message, so changing background color to light blue. Okay. Now I have an update from Alice's folder that I want to share with Laurent. Okay. And in order to do that, I'm gonna create a pull request. Okay. The main branch from Alice's repository, I wanna introduce my changes into the original's main branch. As we did the cloning in the previous demo, my remote will have a remote reference called origin that is pointing to the cats folder. So that's where we are trying to send these changes. Okay. So we're gonna create here git request pull pointing to the origin main branch. Here we'll see a little bit, hey, these are the changes that I'm trying to propose. We changed one file, one deleted line, one added line. Okay, somebody will have to review this before actually accepting it. So I think it's time to try the first pooling operation, right, Laurent?
Okay.
I'm gonna be maybe impersonating yourself. I'm gonna be jumping into the cats folder right now.
Absolutely.
And from the cats folder, here we have something missing. Okay, so Alice's folder notes about the cats folder because we cloned from it. But the cats folder, it has been cloned. It doesn't know anything yet about Alice's folder. It doesn't know it's existing. Okay, so that's how we are going to be creating our first remote reference manually from the command line with git remote add, and I'm going to call this remote reference remote-alice. I'm going to say to the cat's original repo, hey, there's another repo copy of yours located in Alice's folder. So with that, I have the enough information to pull the first changes. So I know that remote Alice created a pull request before. So there's something pending for me to take, which I can take as we showed before by doing a git pull. Okay, so git pull, remote, Alice main. And that's where we have the file change, one insertion, one deletion. These changes have been taken. Okay, if we actually open it just for those that may not believe me, okay, if somebody doesn't believe me, let's open the site CSS, which was having a change related to the background color, and we see it right here. Okay, the background color change, it's right there. Okay.
And here we see something which is quite interesting, I think, which is that the Git gives you the tools to collaborate, but it is lacking some infrastructure, which is, for example, nobody notified me that Alice did a pull request. That would have been done probably by an email or by a chat message or something. And this is why when we use Git in sites like GitHub or Azure DevOps, etc., in addition to having Git, which is really the foundation of it all, the tooling of it all, there is also all this infrastructure around it, which is very convenient, which is that I would get, for example, a notification if somebody does a pull request to my repo, etc. So this is a nice illustration of the added advantage of using infrastructure around this.
Great. So I think we can share. Well, you can share the screen maybe now again, Laurent,
Yeah,
right? We have another whiteboard to show the situation.
Yeah, absolutely. So we indeed we had some. We did this exercise, and again we saw quite a lot of stuff. So let's maybe recap a little bit with a whiteboard. And so here I prepared a whiteboard, which is going to try to explain a little bit what happened here. And so we had this situation where we had two folders. We had folder 1 and folder 2. Folder 1 being the cats folder, folder 2 being Alice folder. And the cloning is something that is always possible. So again, this is what I mentioned before. Cloning, that's why I made this arrow green, you see. Cloning is always allowed. You can always go on, for example, GitHub or anywhere, and if there is a public repo, you can clone it. You can get the code. This is kind of the basic of open source, saying that the minimum level of open source you can do is at least look into my code, right? You can always clone. So that's good. But then, of course, when you try to push into a repository, this is where the trouble starts, because maybe I don't want you to push into my repository without having a possibility to review the changes first. And this is why pushing very often is not allowed to people who are not officially a collaborator into a project. And this is exactly this process of pull request where Alice can always submit a pull request. Anybody can always submit a pull request to a public repo. But then there is this blue line, which symbolizes here the review process, where the owner of the repo, the maintainer of the repo, if you want, can go and he can say, yes, I'm going to take your changes, or I'm going to reject them, or you can even go and cherry pick and say, all right, this file here is a good idea, but this one not so much. And then you can select like this what you want to add. So this summarizes a little bit what we had before. And at this point, we can do another knowledge check. So let's check a little bit this question. And here the question is, what Git command makes a copy of an existing repository? And here we have three possibilities. We have git clone repo-name, all right, the name of the repo. We have git clone repo path, which is a path of the repo, or we have git copy repo name. So tick-tock, tick-tock. What do you think, Unai? What is the correct answer here?
I think one of the options is quite obviously incorrect, right? Maybe we can give that tip. And between the two others, let's leave it kind of open to see what people are voting. I think our audience have it quite clear. Let's give some few more seconds and give the correct answer. So it's quite sure that it's going to be between the first two, right? Between A and B.
I think that it is quite clear. And honestly, the name is not enough to identify a repository uniquely, right? You can have multiple, I'm sure, I'm ready to bet that there are multiple repositories on the internet in the whole wide world called cats. And so it's probably not a great idea to use the name. So it's probably not option A. As for option C, git copy, well, it could be a possibility, but it so happens that the people who implemented Git decided to use the clone command instead of the copy command. And so that's why it is option B here, which is correct. It is the git clone command, which takes either a URL or a path to an existing repository as a parameter, and then clones it, copies it, makes a deep copy copy of this repo on your local folder, on your local machine if you want. So that's great to hear. And now we have another demo. So this is cool. This is the next demo, which is going to be using the shared repo. And what we are going to do here is going to create a bare repository. And I'm going to explain what is a bare repository. It's a special type of repository. So remember, until earlier, right, we did mkdir cat. So we created a cats folder, and then we did mkdir Alice, and we created the Alice folder. And those are a repository where you have a tree, where you have a whole history coming down. But if you want to set a repository which is kind of the root, like the origin for everybody, it's probably better to have a central repository which nobody really owns. It is owned by all the collaborators if you want. And this repository is what we call a bare repository. Then we are going to set it up for the collaboration, and then we are going to start collaborating using this process, which is going to be a little bit more convenient. So let's go back into the exercise. And here, as you see, I'm just moving on to the next one. But like I said before, here I'm going to continue collaborating here inside this shared session. And if I do dir here, you see that we have still Alice and cat. So we are having here everything that we have worked on before. So let's clear this to have a little bit more space. And then the next thing that I'm going to do is create this bare repository. And so here there is something which is quite interesting, which is that in Linux, you can have a directory which has an extension .git. And this is interesting because for me, who comes from Windows, tell you that I was a little bit surprised the first time I saw that, because typically on Windows we don't give an extension to a folder, we give extensions to files. So here it's interesting to know that share.git is just a folder, just like any other folder. And in fact, if you go to GitHub and you clone a repository from there, you will see that the URL like most of the time, actually probably always ends with .git. And again, this is not pointing to a file, it's actually pointing to a bare repository like that. So this calling a bare repository with the .git extension is a convention that we use here. You don't have to call it that, but this is a convention that we do. Then after that, we are inside the bare repository. And so I'm going to initialize it by giving the --bare option. I'm going to say, all right, this is a bare repository. So it is initialized. It is still empty. This is correct. And then I'm going to do something here. Remember that before, when I was impersonating myself, like saying, okay, I'm going to create that, and I did a checkout with the main branch. Now here, because I'm in a bare repository, I cannot do a checkout, but instead I'm going to use here the symbolic reference, which I'm going to call head, and I'm going to point that to the main branch. So it's a little bit a different process, but basically it is telling the bare repository that, all right, you will put the head, which is like the cursor, if you want, like the top level at this moment, into the main branch. And this is what I will do here with this command. So now I have initialized my bare repository, and I will be ready to copy things to it. So what am I going to do now to push the content into the bare repository? I'm going to go back into the cats folder. All right, so I'm into the bare repository here. Now I'm going to simulate that I'm coming back to my machine. And in fact, here I see that I have a small problem, which is that let's stop here. Oh, you know why? It's because I am in the wrong repo. So let's keep that in mind. Or maybe, you know what? I should probably just change to the Git sessions 2 repo, right? So let's go back to cd .. Okay, dir, and then I'm going to go back into the correct place. And here I'm wondering, let's see who was attentive and who noticed that I made a mistake here. So can you let us know in the chat? I'm sure that somebody was like, no, dude, you're wrong. It's wrong. Okay. So let's go back to Git session 2. Here I'm in the correct place. And this is where I actually want to have my bare repo. So I can go back in time here, I'm going to do this time the correct location. All right, I'm going to initialize this with the bear command. And now I'm going to set the branch. And so sorry about that. This is always a demo effect, right, which happens when you do things live like this. All right, so now I have this, I have the, here, and this is the one that I want to initialize, bear. Okay, and then I promise you I'm going to get it. All right, so let's recap quickly. What did we do here? We went into the correct location, which is the Git session 2. We created this bear repository, and then I initialized it as bear, and then I set the symbolic reference. All right. Now that I have set this symbolic reference, this is where I need to go and push the content from cat into share.git. So this is what I will do now. So let's go here and paste. And now you see that I change into cat. I set here the origin. So remember before we did that already when we did with Alice, right? I said, oh, I want to add a remote, which is called Alice. But this is not very convenient because if you do that, it means that you have to add a remote for just everybody who's collaborating on the project, right? It's not really how we work. What we want to have here, which is a better way of working, is having one central repository, which is like the reference where everybody's pushing and then everybody's pulling from that. And so this is exactly what this command is doing: git remote, add origin, and then I add the bear repository. Now, if I do this with GitHub, I would probably use a URL here instead of having the path, but here we are in the file system. And then I'm going to push what I have in my folder into main, and you see that it has pushed my content into the bear repository, into share.git, and like this we have a reference point where everybody can start collaborating, which is way more convenient. All right, so sorry about this small mishap. I was just in the wrong place, but I think that we managed to recover. So then the next thing I want to do is that I want to take a shortcut if you want. I want to push and pull always from the main branch in here. And it's not always the case, right? Sometimes I want to pull and push from another branch because people are going to start collaborating on different branches for more security. So very often you have the main branch, which is a production branch, which maybe has some continuous integration, continuous deployment attached to it, like, for example, deploying to a website or pushing an Azure function or doing whatever you want to build. That's the main branch, but people are actually working on branches. Now here I want to actually push and pull to the main branch because this is a simple project. And so I'm going to set here the upstream to origin main. So I'm telling here my repository that every time I do a push and a pull, this is going to act here on this main branch in the origin folder, which is the shared Git here, the bear repository. All right. So then we are going to set up for collaborators. And the next step is to have Bob joining the project. Bob is also very interested in cats, and he wants to start doing some work here. And so Bob is going to create his own folder. And again, in reality, he would be on his own machine. So let's do that. We are going to cd ... going back to the root, create the Bob folder, and then change to this Bob folder. And then after that, we are going to clone the repo. And again, we are cloning. That's what we did the first time with Alice. But this time we clone from share.git, which means that we are cloning from the reference repository if you want. And this is going to make our life much easier. So now if I do a dir, you see that we have pulled everything. This is the latest version. Let's go back to Alice, because again, this is collaboration, which means that everybody is going to work. And of course, what Alice wants to do here is to set the remote to this share.git. So here Alice says, all right, I don't want to pull directly from the cats folder because the cat folder belongs to Loho and Unai and they're working on their own. But I want to actually push everything there directly to share.git. So this is done here. And then the next step is to begin collaborating. So if you want to collaborate, you need to set a name and an email, right? We did that for Alice before. We did that also on the cat folder. So let's do that for Bob now. So I'm going to go back to Bob and config the username and the email for Bob. And then after that, we are going to add something to the here to the index.html. So I'm going to copy that. I'm going to do code index.html. And what I want to add is a footer. So I'm going to replace here this horizontal bar, HR, which is a horizontal ruler, with a footer. And I'm going to save that here and close the editor. So this is Bob's contribution. Bob is very good at HTML. And then after that, he wants to push that because he says, okay, I did contribute to the project. I added something. So I'm going to commit that. And here you see that we are using here commit -a, which means that I have done the add period that we did earlier on. I'm just condensing everything into one single command. And then I say I put a footer at the bottom of the page. Again, the importance of a good commit message when you are collaborating. And then I'm going to push. Now, push here, again, it's a shortcut. I'm saying I'm pushing to the origin main because this is how my repository is set up. And you see that it has pushed to shared.git, just like I configured. So at this point, this is cool. We are collaborating, right? This is good. We didn't have this warning. If this warning happens to you, don't worry about it. Just check what is written here. It's just some default behaviors that could happen that you can modify. But now Bob edited the file, but Alice is making some changes as well at the same time. And this is the beauty of this distributed environment, is that multiple people can work at the same time. So let's imagine again that I am Alice now, all right? I'm going to go and edit the this index.html file. So let's do code index.html. And notice that at this point, Alice didn't pull the changes, all right? She's editing her own local copy, right? So at some point, it's going to probably create a conflict, right? We need to be a little bit careful here. You see that there is no footer here, but that's fine. We are just going to add a navigation bar. Let's do that, save and close. And then the next step for Alice is going to modify here the site CSS and to add some, some styling for this navigation bar. So I'm going to change to CSS. I'm going to code site.css. And then here I'm going to add this navigation bar, and let's press save and close the editor. All right. So now I have done some local changes. That's cool. But, Alice is at this point is getting an email from Bob, and Bob says, hey, by the way, I pushed something. And Alice is like, oh, no, you pushed something, but I'm also modifying those files, right? You see my acting classes are really showing up here, right?
Amazing.
Amazing, right? I know the drama, you can read the drama. So Alice is going to say, well, let's see the changes that Bob did, and pulling changes, we know how to do that. We can do a git pull, okay? So let's do that. If I do a git pull now, then we start having some issues because Alice has some changes and Git is unable to merge those changes automatically because they conflict, all right? And this is what here it tells me. It tells me your local changes to the following files would be overwritten by the merge index.html. And really we have a problem here. So how can we work? Well, there are different ways of working. You can do a quick compare and do a manual merge or something like that. What we are going to do here is that we are going to use a new command that we didn't use yet. First of all, we are going to do a difference here. So we are going to say, all right, let's do a git diff, which is going to change to show me what changed. So let's paste that. All right, and then here we go. We don't have an output here for some reason, interestingly. But whatever happens here, even though it didn't want to change me the output here for some reason, I'm not sure. There is some tooling here which is going to show you what changed, and this is very similar to what we saw before, where we saw the insertion and the changes and all that. And clearly, this is going to conflict. And so what we can do here is use this command that we didn't use before, which is stashing. Now, stashing, like the name shows, is going to take all the changes and is going to put that into a stash, into a hiding place, if you want, so that you can reach them later. So let's do that. Let's do git stash. And once we do git stash, we have saved something which is WEP, right? So work in progress. And we have changed this commit, which was change background color to light blue. All right. So this is we are now reset to this old commit, if you want. And now at this point, if I decide to do a pull, then we should be able to do the pull. So let's do the pull first, git pull, all right? This time we don't have a problem. You see that I had one file change, one insertion, one deletion. This sounds correct. And then we are going to restore the file that we changed doing git stash pop. And pop meaning that it's it's a stack if you want. So whatever you put first when you do pop is going to come out first as well. And you can stash multiple things, by the way, in the stash. So let's do that. Now we see that, okay, it has been restored to the changes that I had before. We have two files modified, site CSS and index.html. And so now we are basically to the place where we were before, but at this time it has been merged automatically, which is good. Okay, auto merging index.html. So now the change has been merged, and we can make one more change if we want. So here we know that there is a footer now, so we can go and edit the HTML, the CSS. Sorry, so code site.css. Here we go. And now instead of having just the navigation like that, I'm going to set this style for the navigation and for the footer as well. And now finally, I would say we are ready to commit that. So all the changes that we have, including the merge things, now we can say, all right, I'm going to, let's go back just to the root. And then we can say, all right, now I want to commit, and I want to push that to the main branch into this bare repository. So that was quite a lot of things, but maybe we can explain quickly what we did, right? And I believe you also have something to summarize that, Unai?
Yeah, Laurent. So I have another whiteboard just to summarize everything. As you see, it's just playing some games between the remote paths, cloning, pushing, pulling. This is learning by experience. So yeah, you just need to play with it to get some easiness with this tooling in the end. So absolutely. I was actually trying myself for some reason, Laurent. I was trying the same command as you, and I could find that the git diff origin was actually working. Okay. This was in the point where we were trying to get both changes, but we are also modifying the same file. So we could see here, hey, Bob was modifying this file, this line right here. We are modifying the other one. That's why the pooling wasn't actually working. Okay, and that's where the stashing came to help us in the end, putting our work aside a little bit, getting the changes, popping them up again, and then continue working with that work that you may left a little bit on one side for a moment. Okay. Mm-hmm.
So perfect. It's a good thing that that it's working for you. I know why it was not working for me. It's because I was in the wrong folder. I was in the CSS folder, and so of course he didn't find this index.html. So again, my bad. And yeah, good thing that you can show that. So again, right, the merge failed because of those issues. You can always do a diff and compare this. And let's explain a little bit more clearly what happened, Unai.
Yeah, so in the end, what we had in the beginning was the cats folders was being shared, but it wasn't really a central repository. You saw that the communication between each other was getting a little bit messy. Mm-hmm. So in the end, what we did is create a bare repository, which was going to be in the end the central repository where all the communication is going to flow. Normally, this bare repository, when we work with GitHub, Azure DevOps, and this kind of tooling, will be replaced by GitHub or Azure DevOps. Okay, the main repository will be on the server side on this website, and we'll have different local copies. Each developer will have its own local copy with a remote reference to the original one by default. When you are cloning, there's a remote origin created for you from the repository you just cloned. And from there, pushing, pulling changes, normally jumping into experimentation branches, and from there, pull requesting to the main one. Okay, that's frequent X scenario we are going to be working with, but more about that in the next 3 sessions. Coming back to the session we are delivering right now and the last demo. So we had Alice's folder, the Cats folder, and Bob's folder. This Alice and Cats already had some remote references. What we did is just replace them and point all of them to the shared Git origin repository. So all the communication will flow through that one. Okay, so Bob created a clone for it. It started doing some changes in some files. It pushed those changes into the shared.git. While Alice was also working in the same files, it wanted to pull the changes. That's the first time where we had an issue, so that Alice had to work with stashing those changes for some time, being able to run the pull successfully, popping back the stashing so she could work on her changes and push them back to the shared.git. So we see that how the shared.git bare repository comes in the middle in order to help us the communication and collaboration between these 3 friends that met each other in the pizza party.
Right. And it's important to remind everyone that even though we have a bare repository like the shared.git, it's still a distributed source system, right? Because distributed doesn't mean that you're not going through a shared repository. Distributed means that everybody has a deep copy of of everything which was in this repository. And the fact that we have a shared.git here is really merely for convenience. It is absolutely more convenient to have this situation. But as you saw in the earlier demo, it is actually possible to do a pull and a push from one folder to another without going through a bare repository. So again, it is still absolutely a distributed folder. All right, cool. So let's go to the next knowledge check, because we are almost at the end and we have still a little bit of time here. So let's talk a little bit about the next knowledge check. And first of all, what I would like you to tell me is what Git command can be used to save current changes, but without using a pull request. So basically, if we want to temporarily put them to the side, and here we have 3 possibilities. We have git stash, git save, or git store. So who knows what command is used here? What do you think, Unai?
I think I know it because it was quite recent from the demo, but let's give some time to our attendees to think about it. We have the saving, we have a storing, and a stashing. Let's see if there's some few answers coming from our attendees.
All right, the suspense is killing me, but I really hope that everybody knows. Well, you never know, right? I mean, save and store and stash, it all makes sense. But we just said before, I see votes coming in. Okay, don't be shy. Don't be shy. Let's wait for one more vote. All right, 2 votes for stash. I think it's pretty clear that it is git stash, in fact. And yes, this is the name of the command. You take everything that you change, you stash it. And again, remember that this is a stack mechanism where you can push things, but you can also pop things from there. So the next one would be git stash pop, right? All right, and then we have one more knowledge check. So why don't you take this one, Unai?
Yeah, sure. So suppose you have a project that has 10 files in your local working branch of the repo. You recently updated 3 of the files: talk.yaml, intro.txt, and exercise.json. Now you want to create a pull request for only the changes to the JSON file. What set of Git commands should you use to create a pull request for only those changes? Okay, so we just want to add the changes on the JSON file. So option A would be git add dot period or git add period, git commit with a message, git push origin, working branch. Option B, git add exercise.json, git commit dot -m and the message, plus git push origin working branch. And the last one would be git add exercise, git commit with a message, and git push remote working branch. Which option do you think is the correct one, Laurent?
Yeah, so this is, it's kind of tricky because we have two options here, which are actually legal, which are actually correct from a Git syntax standpoint. But there is only one, and this is where reading, when you do those certification exams, you need to read very carefully the question, because here there is something very specific. It says you only want to save the changes to the JSON file. We only want to save one single file. And so as a reminder, if you do a git add period, it's going to add all the changes to the local folder and to the subfolders. And so this is why it seems indeed that the correct answer is answer B, and it is in fact what the majority have chosen. And I'm sure that the person who chose answer A, and that was also the first person to answer, right? You were very excited. You said, oh, this is syntax that I know, git add period works. And indeed, it's true, it works. But the thing is, read very carefully what it says, because there is only one file that we want to push, and this is what the option B is doing, git add exercise.json. And this is something we have not talked about yet in this particular module. I believe you talked about it in last week module, but not this time. And finally, option C, if you do git add exercise, Linux is going to tell you what is exercise. I don't know what exercise means, because the full qualified name of the file is exercise.json. All right, so at this time, we are at the end of this module. So really, congratulations to everyone. You have learned how to use Git to collaborate with other people that you meet at a pizza party, or wherever we meet developers. I think when we meet developers, there are chances that there is pizza involved. So this is really cool. You have learned how to clone a repo, how to stash changes, how to push changes to a repo. And we also talked about what pull requests are and how to initiate a pull request and why you would want to do that. All right, so like we said, this is one module of a learning path. This learning path has 4 modules. So this is where you can go if you want to try it by yourself. If you go to aka.ms/learn-git-collaborate, then you will land directly into this module, and then you can try the exercises by yourself. So as soon as this is over, we encourage you to head over there and do the exercise again to consolidate what you have learned right now. And Unai, you're going to continue to do more work on that, right?
Yeah, I mean, just a reminder right here. So I did the first session with Peter, Introduction to Git. We just been here explaining the second session, collaborating with Git, Laurent and I. We have other 2 sessions coming, May 10th, edit code through branching and merging. So more on collaboration, not just working with main branches, how you create your own independent branch with changes, experimentations, and so. And finally, Git and GitHub, okay, the normal way of working with this kind of tooling, having GitHub, Azure DevOps, this kind of tooling on the background, making our life with Git a little bit easier. Okay, so just remember to add those sessions on your calendar. If you put aka.ms/learn-git, you can add those appointments to your calendar to remember the live sessions. You can watch the recordings from.
And welcome to episode 3 of Learn Git on Learn TV. Edit code through branching and merging in Git. I'm Stephen Murawski, a principal cloud advocate here at Microsoft. And I'm joined by the fantastic Nitya Narasimhan, who I always remember because it rhymes with persimmon. That's a trick right. Nitya reminded me of. So welcome, Nitya. It's great to be talking about Git with you. And before you start, I just want to say thanks to Jose for the comment. Appreciate you being here with us on YouTube today. Feel free to come join us in the chat on Learn TV at aka.ms/LearnLiveTV. Welcome, Nitya. Thank you for being here with me.
Oh, thank you so much, Steve. And I'm Nitya Narasimhan. I'm a senior cloud advocate at the developer relations team at Microsoft. And I'm super excited to be here today with you to talk about working with Git. It's actually very critical to our workflows today as developers. And no matter what kind of development you do, whether it's with code or with content, it can come in really handy. Don't you think so, Steve?
Oh, definitely. Right. And thanks to tools like GitHub, Git's become entrenched in many different work streams, from book publishing to organizing events and even more than software development. Right. And that's just the stuff I've experienced.
That's right.
Right. So let's dive in here. We're in the third in a series on Learn Git on Learn Live. And we've got previous sessions that you can go see at aka.ms/learnlive. You don't have to worry about the links now. We'll have them for you towards the end. But we also have a session coming up next week on Git and GitHub. Now, I know you've got some thoughts about that, Nitya.
Yes, I do. First of all, I am so glad they're going to do the last session of this series with a focus on Git and GitHub together and kind of talk about the relationships between the two, but also their differences. Because let's be honest, a lot of people conflate Git and GitHub. And the way I always think about it is Git is the tooling system that we're going to use for version control. And GitHub is a cloud-based platform that leverages Git and is built around many of its capabilities, but it also provides you a whole bunch of other capabilities that can help you automate workflows and do a lot more besides in the collaborative teams that you're working in. So I'm super excited about that. But we should get back to our topic today. So today we are going to dig into branching and merging in Git. So if you have to remember just three things, it's branching, merging, Git. So for what we're going to do today, we are going to interactively walk through this module for you, which means you should just pay attention and try to see what we're doing. Definitely go to the chat and ask questions. But when we're done, we really hope you will go to that module, that's aka.ms/learn-git-branching, and do the module yourself. All the research shows that if you want to learn something, it helps if you take hands-on activities and try to do them yourself. And we're hoping that if you go to this right after our session's over, all the concepts will be super fresh in your mind and you'll be able to get through this really fast. But you need to know the objectives, right? So Steve, what are our objectives for this module?
Yeah, so today we're going to dig into the fundamentals of what's going to make you successful in working with Git. Branches are the foundation of that shared experience that Git enables. We're going to talk about how branches work, creating new branches, switching between them, and then we're going to look at merging, right? Merging branches and what happens when there's conflicts. And because this is real life, there are conflicts. And we're not just going to be talking about this stuff. We're going to get hands-on and do this live with you and take your questions live as we're going through this. So please ask them in the chat, right? What do you think of that, Nitya?
I think those are the perfect objectives. So if I recap and I remember this right, we're going to learn to create branches, switch branches, learn to merge branches, and then resolve conflicts. Perfect. So these are great objectives. We'd love to know what you think. Are these the objectives that will fulfill what you came to learn today? Let us know in the chat. We'd love to get feedback and make these materials better. We also would love to get questions from you as we go along. We'll try to answer them interactively or catch up with them at the end or share our answers via other means. But if you're not watching this on Learn TV, go to ak.ms/learnlivetv and come chat with us. We really love to hear from you. And with that, are we ready, Stephen?
We are ready, Nitya. So in this module, we're going to learn what branches are in Git, how to use branches for development, how to merge them, and how to deal with merge conflicts. Now, Learn modules are often structured around a scenario, so let's set up our story. Imagine that we're a new software developer that writes avionics software for commercial airliners. Quality control is critical. Developers work in small teams using Git for version control. Now, we've already learned a little bit about Git, and we've used it to track our changes, fix mistakes, collaborate with other developers through a shared repository, and by using pull requests. However, Git has even more to offer, and you know what? I'm excited to learn. Now, in order to do this learning, we've created a small website that I in the persona of Bob and I in the persona of Alice will be working on to practice those Git skills by creating a website to share pictures of our cats. Now, we've got a couple of friends who are software developers, Alice and Bob, who we're going to be portraying to help us on out. So, but before we do that, let's level set on some terms and some things around branches. So, Nydia, why don't you get us started with a little bit about branches in Git?
Absolutely. And already learned you're a cat person. Wow. Okay. So we're going to talk about branches in Git. This module is going to look at branching and merging. So it's essential that you understand what branches do. So let's go back to the scenario that Stephen just set up. As your project starts building up, you realize you want everyone to work on more than one task. So there's you, there's Bob, there's Alice. You want to work on tasks, but you don't want to get in each other's way. You need a way to keep everyone's tasks separate. And at the same time, you want a way to make sure that people who are working on bug fixes are not kind of stepping on the code of people who are working on perhaps new features, right? Branches in Git make this kind of collaboration really easy. So, Stephen, is there anything more they should know about branches?
Definitely. Right. As you've kind of talked about, branches let you keep commits related to a particular topic together and isolated. And that really makes it easy for me to work on multiple different things in relation to the same project. And lets me review and track those changes in a kind of a logical group. But work on that branch doesn't have to be shared, right? And it doesn't have to interfere with work that's being done on other branches. So the things I'm doing in relation to fixing bug A doesn't have to relate to anything with feature B, and doesn't have to interfere with anything you're doing on feature C, for example, right?
Right.
And so modern software development typically is done entirely in branches. And the goal is to keep our main branch clean, right? One of the cores of the ideas around continuous integration and continuous delivery really come down to keeping that main branch ready to ship, right? Regardless of whether or not we're at a point where we can ship or not, we want that branch to be at a sufficient quality to be able to ship. And so what this lets us do is work off in those branches, and then when we're ready, push those changes to a main branch, or better yet, we submit a pull request to get some code review before we merge those changes. Now, the ease of branches, right, is in working with branches in Git is really based on experiences in working with earlier version control systems, right? And now, Nitya, I know you've got some experience with previous source control systems, so why don't you fill us in?
Oh my God, I have to tell you, I'm going to date myself here, but my earliest encounter with source code control was literally in a system called SCCS, Source Code Control Systems. And at that time, we were looking at just version control within my own kind of local code base, so to speak. And from there went to CVS. And I think a lot of folks went to Subversion and all the other alternatives out there. But once I discovered Git, I really didn't go back. So yes, I remember those days very well. And here's the advantage Git has. So one of the big advantages Git has over the earlier VCSs or version control systems is that in Git, creating a branch is extremely fast. And this is important because half the reason why we do these things is we want to be productive, right? So in Git, creating a branch is effectively the time it takes to write a 40-character hash into a file under .git/heads. That's not much time at all. Switching branches. So creating branches is fast, but how about if you want to switch to a different branch? Switching branches is also fast because Git stores entire files and then unzips them when you need to restore or go to a new branch or look at a different version, instead of trying to reconstruct them from a list of the changes. And that means that in order for you to switch to a new branch, it's as easy as the time it takes to unzip that file. Now, merging in Git, we've been talking about branching, but merging is not necessarily as simple. But the advantage of Git is it's straightforward. And oftentimes, with the right level of practice and tooling, it can become really automated and painless as well. So next, we should look at what branches are and how they work. Right, Stephen?
Definitely. So a branch is really just a chain of commits that branch off from the main line of development, like a branch in a tree. Now, if you're switching to Git from another version control system, you might be accustomed to slightly different terminology. For example, in Subversion, the default branch is named trunk, right? And that actually calls back to the idea of a central repository. Now, Git is a completely distributed version control system, so we have branches everywhere, and branches are really just names for points in time on a commit history. However, in centralized version control, branches there was only one main trunk, right? And but in Git we have a default that it's typically master. However, convention right now is really that we lean towards names like main or default. Trunk is fine. There's nothing magical about the name trunk, but we've been trying to get away from the term master. Now, a branch usually starts with a commit on the default branch. In this case, we're calling it main. And that branch grows a separate history chain as commits are added. So if we look at the diagram, right, we can see that main went A, B, and then at B, we took a branch. And any work that was done on that branch starts from B and then evolves from there, separate from the direction that main is continuing. Right. And so in this I'm sorry, go ahead, Nitya.
Oh, I was just saying, got it.
Okay. And so what we see then is until that branch gets merged back, it's going to continue to diverge, which leads to, one of the findings that we see typically when we talk about software development performance is the faster we get those things merged back in, the easier it is. The longer that branch stays out, the more these things can diverge, the more painful that merge is going to be. Right. And we're going to actually dig in this module on how to make commits to a branch and then how to bring those things back in together. So, Nitya, when do you think we should create branches?
That's a great question. And I think you set this up really well by talking about the fact that you probably want to have branches be there for focused short bursts of work rather than have them be perpetual kind of extensions, right? So a common reason for you to create a new branch is usually when you want to make changes to an existing feature. So to go back to what you were saying, Stephen, the main branch should be as clean as possible. So here you have the main branch, let's say with a feature, you want to make a few changes to it. You know what you want to do. It's going to be a small amount of work. That's a great example of when you should branch from the main, make the changes related to the feature, and then merge it back. Another example could be when you have someone new coming in and they've been assigned a different task. It could be a bug fix. It could be something trying out a completely new experimental feature. So again, it's a great example of when you want to provide a new branch where you can do that experiment in, and then if it works, bring it back into the main, which is kind of like very stable. The two things from a terminology perspective that you want to remember are creating branches and switching to the branch you created. To create a branch, we're going to use the git branch command. So difficult, right? Git branch creates a new branch. Oh my God. But you'll see this in action, and it's the easiest way to remember. Git branch will create your branch. There is a little bit of additional thing on naming the branch, but you'll see that in the demo. Once you've created the branch, how do you switch to it? Well, you kind of go check it out. So git checkout is the command you use when you want to switch to a branch that you just created. Again, git checkout in the name. And you'll see that in the demo. So that's about the branching side of it. Stephen, do you want to go into the merging side?
Yeah. So, once we finalize some of that work in that branch, whether it's that feature or bug fix, we really want to bring that change back into the main branch, because otherwise it's just going to sit there, right? And it's not being useful to anybody. So we use the git merge command to bring those changes back into our main branch. For example, if we were working a branch named my feature, right? I'm an expert at naming. You'll see this throughout the demo. Naming one of the harder problems in software development, and I am a master. Yep. So we got my feature because it's my feature. Like the workflow would look something like this. I would be working on my feature branch, and then I would git checkout main. So I'd get back to the main branch, and then git merge my feature, which would bring the changes from the my feature branch and bring them into the front of my main branch. Now, hopefully we would not have any merge conflicts, But this would be the point where if there were any merge conflicts, any conflicting changes between where main was and where my feature was, then we would get a chance to resolve those conflicts. And we'll actually look at and go hands-on with resolving some conflicts as we bring some branches together later today. So after we get through that, all the changes from my feature would be in main. I think it's time that we do a little bit of Q&A. What do you think, Nydia?
Oh, good. Yes, let's do Q&A because that'll put away the knowledge check. Yes, someone will come save me. Q&A would be great, Stephen.
All right. So what have we just, Nydia, do you want to just quick recap what we covered so far?
Yes, so let's do a quick recap. So in this first section of this module, we went over some of the terminology. So we talked about what branches were, how to create branches, how to switch to a new branch, what merging means, some of the issues that might show up in merging, like conflicts, and how we'll talk about resolving them. But also we talked on the broader basis about what version control systems are, what the value of Git is compared to older version control systems, and how Git and GitHub might differ. Right? So with that, you're just taking me to the knowledge check, aren't you, Stephen?
Let's go to the knowledge check because we've got that shared in the chat as well. So please go and answer those questions. So which of the following statements is true about branches in Git? What do you think, Nydia?
Ooh, okay. I'm going to read through these real carefully and then figure this out. And hopefully by then someone from the chat will even have told us the answer. So let's start at the bottom. Which of the following statements is true is what you're asking. So the first one says default branch in a Git repo is named master, which I remember from what you said is probably true. But it says the branch can never be changed. That's not true because we already talked about why it's important for us sometimes to change that to something like main or trunk. So C is not the right answer. So that leaves us just 2. Let's look at B. B says a branch can't have any other branches that extend from its line of development. I know that's not true because first of all, main is also in some sense one of the branches and we were able to get a branch from there to do something in, but it's also kind of the same pattern. When you're in a branch, you want to do a tiny bit of work, you can create another branch. I remember Stephen saying something briefly. So B is also not true. So by elimination, it must be A, but I'm going to read it just to be sure. Work done on a branch doesn't interfere with work in other branches. So what does the chat say, Stephen? Are they agreeing with me? I think it's A.
They are. Say? We got 100% agreement on A. So I think we are ready to keep stepping forward.
Yay, crushed it. All right. So I guess now we're going to switch over and go to the demo. So do you want to talk briefly about what we're going to see in the demo, Stephen, before we switch over?
Yeah. So what we're going to cover is we are going to we're going to work on creating a branch. And so what we're going to do is set up a bare repository, a base repository, and set up an environment for Bob. We're going to work as Bob and add some base files. And then we're going to clone that repo down and create a branch for Alice so she can contribute to the project as well. And we're going to do that right in Microsoft Learn and Azure Cloud Shell. So let's head over there.
Nice.
Yeah. Yep. So again, this is how when you go to the when our audience goes to Microsoft Learn, they can try this stuff out without having to install anything in their environment and go and get hands-on with this stuff. And all the commands are provided. So we're just going to walk through. We're going to start out by creating this shared bare repository. And so I'm just going to go and I think I need to refresh my Cloud Shell instance there. It likes to hang up after a moment. While it
starts up, is Azure Cloud Shell something that anyone doing this module can just activate and use directly from within Learn?
Yes. So there'll be at the top of the Learn module, there's like a little button that is right here, and you can use up to 20 sandboxes a day, and you get about 2 hours for access to that. So, all right.
Perfect.
So now what we're going to do is we're going to start out. I'm going to create a folder. I'm going to head into that folder, and I'm going to initialize it as a Git repository. Oh, first let me show you just to make sure nothing up my sleeve.
Yes.
Right? Just like the old magician, nothing up my sleeve.
Okay.
We're going to make it now. We're going to apply all the metadata that is needed to say that this is a Git repository. And then because I want to change my default branch name, I have to repoint some of that metadata. And so there's a command git symbolic refs head main. You don't really have to worry about that. If you want to dive into the details, great. But this is going to help us kind of adjust that starting place for our repository.
So just to reinforce this, we're only doing it in this repository because it's a bare repository and there's nothing in there. So we want to reset that main.
Yes, we'll have to do it here, and we'll do it for Bob because until there's a branch that exists, but you'll see we won't have to do this down the road.
Okay. Can't wait.
Yep. So now let's get Bob's environment set up. So I'm going to create a directory for Bob, and then we are going to head into Bob's directory, clone that empty repository that we just created.
Yep.
And then I'm going to do a little configuration. I'm going to set Bob's username and email so that that data gets associated to his commits. And I'm going to make that same, symbolic ref head point to main so that when we start to add files, it all starts on the main branch.
Yeah, and I'm going to take a minute to just say that if you're following this along and you're wondering like what is clone config, there are 2 modules that came before this where you can go step by step and walk through those. So if you haven't already done the other modules, definitely check those out.
All right, next thing we're going to do, let's start to create some content in files. So I'm going to create an index.html file. I'm going to create a directory and a site CSS file, and we'll do an initial commit. So I'm going to add them. Git add period will add all of the files recursively from my current working directory down. And the commit, I'm giving it a message so that every commit that I make in this will have a message associated to it, so I can tell the story of the evolution of my code or my project, however we want to say that. Now,
and then commit M is just the commit message when you do commit M. And okay, got it.
If I leave that off, it would pop open a default editor for me to type a message and prompt me for a message. By doing the M, we just kind of short circuit that process a little bit. Now I need to edit my index.html file. Now, we've got some questions coming in.
Woohoo!
So
also gotta love that we have an interactive code editor in Azure Shell.
Yes. So we've got some questions coming in, Nydia. So when we merge, how do we know or track the changes and merge? We're going to actually get to that. So I'm just going to put a pin in that one, and we're going to come back. And then one of the other questions that we're getting is, and I'm just while I'm putting some boilerplate HTML into the file, right? Is being on your branch, what's better? Git pull origin master or git merge master? And I actually would like to address this one, unless you wanted to take the first crack at it, Nydia.
No, go ahead. What was the question again? Which one is better, git pull origin or git merge?
Yes. So git pull origin master or git merge master. So depending on your workflow and depending on what you want to do, those commands can be slightly different. And let's put a slight pin in this one too, because I think we're going to get to, when we get to the part where we're pulling code, let's actually talk about it, because we can actually show what
I will remind you. So pull and merge. Got it.
Yep. All right. So we've got some HTML added to our file. Now what we want to do is also add some content to a CSS file that we have. So I'm going to change into my assets directory and open up my site CSS. And I heard you mention, but we do have this. It's a stripped down version of the Visual Studio Code editor available right in Cloud Shell. So you can do all this stuff right in Cloud Shell without needing other tools handy.
Yes.
All right, let's put that CSS in there. Now the actual CSS and things don't matter so much. It's just that we've got content in these files, and we're going to change the content in these files over the courses of the exercises.
And this is the web app that, the scenario talked about them setting up for cats.
Yep, to share our favorite cat pictures.
Yes.
So now we want to step back up to the main, to the root of our directory.
Mm-hmm.
We're going to add all the files that we've changed, give it a commit message, and now I want to share my changes with our central repository, right? And so I'm going to push these changes up to my origin,
Mm-hmm.
and I'm telling it that I want to send my main branch. And I've got the set upstream there. Are you familiar with that one, Nydia?
Yes, I was going to ask you to tell me a little bit more about it, because I do remember that this is Bob's directory and he just kind of cloned from shared. And as yet, this is the first branch. So in some sense, he needs to know what the origin repo's branch is that he will be pushing these changes to. So I'm guessing this has something to do with that.
Very good guess. Yeah. So because we've changed the default branch name, some of the default behavior kind of the default expectations may not be there, and different versions of Git handle it slightly differently. But by telling it set upstream, we're telling Git that for the behavior from this repository, that my local main branch should target the origin's main branch. So if I just do a git push from this branch, it should know and figure that out.
Okay.
All right. So
and once it's set forever. I don't have to remind it again. Got it.
Yep. For this particular repository, right? For this
Bob.
instance, right? Yep. For Bob. Now, depending on the version of Git you have, you may get some, different push behavior notifications and things. And there's a command in there if you get something different for older versions of Git on how to change that. But we can see that the results that I have, enumerating 9 objects, it tells me how much I'm pushing up. I went to a new branch, main domain, because you can push from one branch to a different branch name. So our command helped us keep those in sync. And so my output matches the output in the Learn module. So that means we're on track.
All right. So Bob's work is done. And right now, Bob is completely synced up with the shared repo in terms of all the code.
Yep. Now we want Alice to start working with this repository and and create her own branch.
Yes.
All right. So let's do that. We're going to go create a directory for Alice, just like we created one for Bob. And then we're going to do the same thing. We're going to clone the repository and configure her username and email address. Now you'll notice we're not doing the symbolic ref head.
Yeah.
And if we look, she now has files.
Yes.
That she didn't have before. Right. And so she got the files from the current state of the repository. And if we do a git status, we will see that we are on the main branch.
Yes.
So that configuration that we did for Bob and for the Bear repository, those, once there was content there, now the metadata just flows on down to Alice. And so everything should just be there for her and working just fine.
Got it.
So now we need to create a branch and move to it. So we're going to use those commands that you told us about. Git branch.
That's right.
Give it a name, add style.
Adding style. All right. Yeah. Go, Alice.
I add style. That's what I do. I've got nothing but my sweet, sweet style.
Oh my God. I've heard this so many times that it still doesn't get old. Go, Steven. Awesome. So check out add style. So that means we've now switched to this newly created branch in Alice's directory.
Now, one thing, a command that I love, and I'll probably type over and over and over, and you won't see it as much inside of the Learn module itself, but I type it a lot, is git status, because that tells me the state of things in my repository. And so right now it tells me I'm on what branch I'm on, and that there's nothing to commit, no changes in my working tree. We're starting out fresh. So we want to edit our, first we're going to change into our assets directory, and then we're going to open up that CSS file. And we want to add
a cat class. Awesome.
Yes. We've added a cat class, and we can close our editor. And we'll step back up in our directory. And we will do a git commit -a. Now this is another shortcut. So one of the things that's really nice about Git is there are a couple of patterns that you tend to follow a lot. And so the commands tend to offer little shortcuts. So we could do a git add space period to add all the working directory stuff, and then do a git commit and give it a message. Or we could do git commit -a, which will do that add of all the things recursively from my current working directory, and then give it a message, and I can do it all in one step.
Awesome. So this is effectively staging all the new changes that might have happened and committing them with that message all in one shot.
Yeah.
Perfect.
All right. So now we're going to pop back over to our main branch. So we're going to git checkout main. And here's where we can talk about. So we want to get any changes that may have happened while we were working before we try to bring our change sets together, so we can find any conflicts before we try to push them to a central repository. We want to find them locally first, so we can deal with them, rather than putting them out where everybody has to deal with them.
Okay.
Does that make sense?
Yes.
Okay. So we can do a git pull. Now, what git pull is going to do is it does two operations. It does a git fetch, which gets the local repository, or it gets a remote repository, and updates your local copies of it. So if we do git branch -a,
there's all the branches that you have.
That shows all the branches and shows me remotes, and the origin remote, that's where we cloned from.
Right.
And so we have local copies from the last time that we connected to it, of what that status is, of what the status is. So I can tell a difference between, I can say, my repository is 5 commits ahead or 3 commits behind, or some combination thereof from the last time I got and so what pull does is it fetches, so it updates those remotes there, and then merges, then merges it back. So it does it all in one command for us. So if I did a git pull, it's going to go out to my origin and make sure I'm up to date. And it says, okay, hey, you're already up to date. Nothing to see here. Nothing to do. Now, the question that we had was versus a git merge master. And I think what the questioner was asking is in terms of keeping their repository up to date. And so this is one of the patterns: is you go and you bring your main branch up to date, and then you merge your changes onto your main branch, which is what we're going to do here. So now that we've got our main branch.
So just to clarify the question, I didn't see it, so I'm vaguely paraphrasing that. When you look at git pull versus git merge, pull is actually a fetch followed by a merge. So if you're doing a pull, you're actually fetching and then doing the merge. If you just did the merge alone, you would not have done the fetch. Would that be a kind of like a good way to look at the difference between them?
Yeah, I think what the questioner was looking at was, if I've got some changes.
Oh, what's the best way to do it?
I need to catch my branch up to master to minimize the conflicts coming back. And so this is one of the patterns. Okay. And so what we're going to do is we're going to merge. Now we're going to use a flag on this merge of FF only, fast forward only. So that's only changes that can be applied if our branches are in line. The heads of the branches are in line. So we can only, we don't have too much divergence in our trees. And then, which we were able to do because we just added that one. There aren't any. We were up to date, and after that pull, and we were able to pull our changes in on top of that. Now we're going to push our updated main branch back to the central repository. All right, and that is our first run through.
So now if we do a git status, it should say nothing left. We're all in sync. Yes.
We're all in sync. Now, we had a question too come in as well. What does the set upstream option? That tells everybody that the local branch that I'm working on, that I'm pushing, should be associated to the remote branch that I'm pushing to.
Mm-hmm.
So in this case, they were named the same. These things could be named differently, right? Like I could have my local branch and I could push to main in my origin. It gets confusing when you do that. So the typical pattern is, that my branches match my branch names match the upstream repository names. Set upstream just sets the tracking information so that whenever I would just do a git push from the main branch, it knows to push to the remote main branch.
And if you didn't want to push to the default set upstream, you could just specify it explicitly in the git push.
Exactly.
Awesome. So I switched back to slides so we could quickly recap before we did the next exercise. So briefly, I think the demo that you walked through, from what I remember, had these steps, right? So you start by setting up a bare repository. And when you created it, it uses the default master. So you set up the symbolic ref so that we would have the head point to main. But of course, there was nothing there. And so then the first person, who's Bob, cloned that, created some content, pushed it back. And when he did that, he not only set his upstream repo, but by committing it, he actually made that main branch come alive. And they were both in sync. So now the next person who checks out or clones the main repository from shared.git is Alice. She clones that repo and she automatically gets all the changes Bob made and has her default main branch set up for her. Is that a good assessment of the recap?
You got it. That's exactly what happened. So are you ready for another knowledge check?
Never. But that's what we've got all the people on chat for, right? They're going to help me out. I'm sure of it. So if you're watching this, we're going to walk through the knowledge check question and answer. So please do feel free to weigh in. And let's go. Yes, here's the question. You can read it out?
Sure. So which of the following git commands creates a new branch and then changes your working location to that new branch?
Awesome. So I'm going to try to go through these. And as usual, I'm going to start at the bottom. So I'm looking at this and we have to come up with both the right commands, right? So the first one says git branch minus new, my new branch, and git switch minus new branch. I think this is wrong. We never talked about any command called git switch. So let's get this one out of there. So I think this one is wrong. So now we're left with the first and second. So I'm going to look at B. So it says git branch minus new, my new branch, and then git checkout minus new branch. Now, I think the git checkout part sounds right to me because I distinctly remember that if I want to switch branches, I have to go check out that branch, right? But I don't remember seeing any option called minus new. And so if I look between A and B, I kind of think A is the right one. So git branch my new branch creates the new branch, and then git checkout my new branch switches me to it. Am I right?
You are right. So, and our audience has been answering the poll, and we're split between A and B, with with 2/3 of the folks looking at A, and A is correct, right? Git branch, and then the name of the branch will create that new branch. Git checkout will move you there, and as we're going to see in just a moment, there's a shortcut. Just like git pull is a shortcut for git fetch and git merge, we have a switch and git commit with the -A switch does the git add as well as the git commit. We have another shortcut that we can use, git checkout -B, and then the branch name will create the branch name and change you to that in one single step. So
wow, are we going to see that in the next demo?
We are.
Yes. So let me bring up I think this is what it tells me the next demo will be about. So when Alice was working on the CSS for the website, looks like Bob was working at the same time in his home on something else. So do you want to tell us about what the demo is and go there?
Yeah, you outlined the scenario well. So what we're going to do, this is our chance to do a little bit more work. Now we're going to get into more of the merging side of things, and so we're going to, we're going to take a step back from being Alice for a second, and we're going to go over and be Bob. And so since Bob's home working all by his lonesome,
poor Bob.
Yeah, poor Bob. So we're gonna go back to Bob's directory, and we're gonna create a branch for him, and we're gonna use what I just talked about, the git checkout -B, to create a new branch and change directly to that. And so if we do a git status, we can see that we are on that add cat branch, right?
Yeah. Mm-hmm.
Now, and we have nothing to commit. Our working tree is clean. We're good to go. So now I'm going to do some file system operations and some web operations that just to go out and grab some external resources, unzip them. And then that has a couple of images in it, one of which I'm going to use.
Okay.
I'm going to copy it to my assets folder. And then I'm going to remove that zip file and the cat image that I'm not using just to clean up after myself.
Okay, so now the assets folder has a change right now because you've added one image there.
Yes. And so if we look at Git status, we see that we have an untracked file. That means a file that Git doesn't know anything about yet. And so it knows that, hey, there's something here. You haven't told me what to do with it yet. So I'm just going to leave it alone until you tell me to do something.
I'm going to get into the habit of Git statusing all the time. I think it tells you a lot of interesting stuff.
Yeah, that if you work a lot with Git, some of those from the command line, some of the shell extensions for PowerShell, ZSH, Bash that bring that Git status information right into your command prompt can be just wonderful help, especially if you're working with a lot of different repos and a lot of different projects. Can really be a lifesaver. So we've now taken a look, see what we have, and we're going to add that file.
Oh, I think did we change the HTML?
Oh, we did not. So I'm skipping too far along. I'm glad you're here. This is where pair programming is a wonderful process.
I was just feeling bad that Bob didn't get to add his cat.
All right, let's get Bob's cat in there. So we want to replace this. Eventually, we'll put cat pictures here with Bob's cat image.
Yes, Bob deserves to have his cat on that site. Go, Bob.
All right. So now if we do a Git status, we'll see that Git sees one file that it does know about that's been modified and one file that is unknown, right? And that's the cat image. So
got it.
Now let's add those and we'll commit those changes. Got a commit message in there. And now we're going to do our merge dance, right? Where we check back out our main branch. We do a git pull to make sure that we got the current versions of things. And oh, looky here. Here are the changes that we made as Alice not so long ago, right? And so we see that our site CSS file was changed. Now, fortunately, we haven't changed that as part of this effort of getting Bob's cat picture in there. So we probably shouldn't have any merge conflicts.
Yeah, because we only changed index.html and added a file, but we didn't touch site CSS. You're right.
Yep. So we are going to do a quick merge.
And just briefly, I don't know if we talked about this, but that no edit option on a merge just basically says don't change the commit messages, right?
Correct. Yep.
Okay.
And then we will do a push to send these changes that we have now in our main branch back to the shared repository. So now one of the differences that we might see from the last time we did this, when we made our merge last time, we had it was the fast forward merge. This is a recursive merge, and that's because our changes were made from a different starting point than where main was left off, because main got that additional update from the site CSS. But where we started our edits were before that. So we had two different parents. We had two different starting places. And so that's why the recursive strategy was used, not the fast forward.
That is interesting. I did not know that. Awesome. I learned something.
So now that we've got Bob at the most current version of things and our shared repository at the most current version of things, it's time to get Alice caught up, right?
Okay.
We can't let her lag behind too far.
She needs to see Bob's cat.
She does, and she's got her own cat that she wants to share.
She does. So, oh my gosh, Things are getting complicated. Okay.
So we are going to change over to Alice's directory, and we're going to get her caught up on her main branch. And so this brings back over Bobcat, and index.html. And if we were running this locally, we could pull it up in a browser. This is the one part that we can't do from Cloud Shell that we could do if we were doing this locally. But we can see in Learn what we would see, right, is if we pulled the site up from what Alice has, from what Bob has, or what's in the shared repository, because everybody is currently at the same point in time, we would get we'd get this nice little Bobcat image on our Contoso Cats page. Now, that is the happy path of merging, where we don't have a merge conflict. Next, we'll look at an example with a merge conflict, but let's set that scenario up first.
Awesome. Let me switch us back to slides so we can understand what we're going to be looking at next. So we just finished merging Bob's branch, right? So when Alice was working on the CSS for the website, Alice was on StyleCat. I'll never forget that branch name now. Bob worked on home, and he basically added a cat. So Alice changed the site.css. Bob added a cat in assets, and he changed the index.html to include it. And then right now we're at a point where Alice had committed her changes. Bob had maybe pull hers. He committed his changes. Everybody's now in sync across the board. But now we are going to get to demo number 2. And as you keep telling me every single time, life is full of conflicts. So I guess we're going to talk about how conflicts can happen and then how we merge them. How we resolve them.
Yeah, life is all about conflict resolution, right? And working with our source control systems is the same thing. Source control systems are really a method of communication, right? It's how do we come to agreement on what the current state of things is, and how do we resolve conflict? So we've basically taken conversation about something and put it into a tool and process. And so let's see how we can use Git to facilitate our conflict resolution.
Awesome.
All right, let's hop back over to Microsoft Learn and Cloud Shell.
Okay.
All right, so now we need to get both of these folks working again. And so we need a new branch for Alice and a new branch for Bob. So since we're in Alice, we will start by setting up a branch for her to add her cat.
Okay.
And Bob, he wants to add that sweet, sweet style that Alice created for cats to the image that he's already added. So he just found out about that. So he's like, oh, you updated the CSS. I want that for my cat.
Wait up. So this is interesting. So now this time, like in the previous example, we kind of were showing Bob doing his changes and then Alice doing hers and then Bob doing, but now they're both kind of working on their changes at the same time. This gets interesting.
Yep. And it's this is a really straightforward example, but it really is how things end up working out in a lot of cases in real life.
Yes.
When you're working on a shared project, a lot of times you're working on a nice isolated thing, and you can have these nice easy merge commits where everything just resolves nicely. But every now and again, you're going to have these scenarios where you both want to work on the same general area, and there's a chance for collisions here. So now we've got our branches. We're going to get back to Alice, and Alice is going to go get those files that we just did for Bob. We're going to get them for Alice. Now, Bob had the Bobcat. Alice is going to use the Bombay cat image and put that in assets, and then remove the other files, clean up after herself, so that if we look right now, we now have another cat image that we're going to put in our repository. And I won't forget to edit the index.html this time. And so
but this is interesting. Yes. So I'm looking at the existing line in index.html, and it's Bob's line, which basically is a picture of his cat, which was not styled because apparently Bob has no style. And
not yet.
Not yet. He hasn't found out that there's such a thing as cat style, but yes. Okay. So now we're in Alice.
Yep. And so Alice is like, no, you know what? Let's put my cat there, and let's use that style. So Alice's cat is now in our index HTML as of Alice's branch.
Mm-hmm.
And we'll close our editor. And we're going to add our image. So I can tell git add to just point, and I can point it at a directory and tell it to add some specific stuff. Or we could do kind of our git add with the AM.
Combine, add and merge. Yep.
And we get our commit message. And now we do our dance, right? We do our git checkout main pull to make sure we're current, which we are. Then we're going to do git merge. And we're going to do the fast forward only because I know we are now at the because we didn't have any changes, so there's no divergence. Yes. So my fast forward will work just fine.
And this is only because Alice was the first person to make the commit changes on these concurrent things they're doing together.
Yep. And I mean, and that's the thing, when you're working with multiple developers, it's always a race, right? And it's not necessarily a race that you have to win, but it's just a race that you have to know is going on, right? So you have to know, you have to be able to check in and see where the status is of things, because it's not just a race, it's like a relay race, right? You gotta see who's got the baton, right? And where things are at. But there's probably better analogies, but
no, but I actually think this is an interesting point that you make, because it's not just the tooling. I mean, in the real world scenarios, you're going to have project management, which makes sure people are assigned issues to work on that don't necessarily conflict. And also to go back to what you were saying before, where every branch, think of a specific thing you want to do in that branch, right? Don't try to do 3 things, because then your chances of conflict are reduced if each person focuses on one thing and they're all doing independent things. Yep.
Exactly. Now let's get back over and do Bob's work, right?
Yes. Hello, Bob.
So Bob wants to add his.
Bob has discovered cat style.
Just to refresh you, we pushed changes to our shared repository from Alice.
Mm-hmm.
Bob is working on a branch that he took from before Alice's changes were pushed. So Bob's view of the world in the StyleCat branch is, if we look at our index.html, it still has his Bobcat image.
Yes.
No style. So we want to add that style. We want to add our class cat. And so now we've added some style, some class and some style to his cat image.
So this time, just to recap, both Bob and Alice have changed the exact same file, which is index.html.
Yep.
Concurrently in their own local branches.
So we are setting ourselves up for a fun time.
Oh, yes.
So
my middle name is Conflict. Okay.
Yep. So I'm going to do my commit. I'm going to check out. I'm going to jump back over to main to do my little dance and pull. And then we'll get our merge going. So I want to merge that StyleCat. Now let's see what happens.
Aha.
Boom. All right. So auto merging index.html. Merge conflicts detected in index.html, and it cannot automatically merge. Fix the conflicts and commit the results. So what does git status show us? So git status says we're on main. We're up to date with origin main, but we have unmerged paths. So it wants us to fix the conflicts and then commit. Or we can use git merge -- abort to abort the merge. Now, I love that flag. It makes me think of Star Wars and Star Trek and in Star Wars Admiral Akbar coming in and like, it's a trap, abort. Or Star Trek, they pull into the situation that is completely unexpected. Abort. And so whenever if you hit a situation in Git, whether it's in a merge, whether it's in a rebase, some of these more destructive commands and it hits something that it can't figure out, you very often get this chance to abort. And so that's your flag to go back to what things were before you started the operation.
Aha. And in doing that, you're effectively saying, I'm going to abandon what I was doing and just go back to safety.
Yep. It's like,
awesome.
You just sort of nope out of there. You're like, nope, not me. I'm out of there.
Got it. That's an easy one to remember. I'm going to remember that.
Yep. So there are some other options for how you can deal with it, right? So you can abort and get out of there. You can use commands like git reset to force the state of a repository to a particular commit.
Okay.
Or we can manually go resolve the change, go resolve the conflict. And that's what we're going to take a look at now. So we know that they both modified, because it tells me both modified that index.html. So I'm going to go take a look, and if there's merge conflicts, maybe I have multiple changes in this change set.
Yeah.
And some of them were successful. I would see those in green, like they were staged for commit. And then the ones in red are going to be the ones, and the ones that are in the unmerged paths are going to be the ones that I need to go look at manually and take a look at and try to fix.
So that's a good thing to reinforce, that when you merge, conflict doesn't mean the entire file, like the merges didn't go through. There might be just sections of it where there were conflicts, but the other things merged just fine.
Yep. So here we are in our index.html.
And just to remind me, which branch are we in right now?
We're in main.
We're in main. Okay, got it.
Yep, main. Okay. Very often you'll see that referred to, and because we are in the middle of a commit, or in the middle of a merge here, head is the very tip of where our code is, right?
Okay.
Of what we're currently working on. Yep. So it's saying that what's currently in head, which is what we pulled from our shared repository, which was Alice's change of Bombay Cat with that's what was there. Yep. And then there's a delimiter. And then underneath that, it's we have from our style cat is Bob's cat. Yes. And so it's saying that we have both these changes there. What do we want to do? And because we are thinking humans who can understand the intent of the code that we're crafting. What, in this case, what Bob really wants to do is he's like, I want both these cats.
So Steven, 1 second before you just do that, I just want to quickly just look at those symbols. So the top one is showing me what my current repository is from which I ran this merge when the conflict happened. The second one below that, equal to delimiter, the second one is where I was trying to merge from, or like getting the changes merged into from. And so everything between those, it's effectively showing me all the things that are in each branch that conflicted. Got it. Sorry, go ahead.
And if this was a longer file, there could be multiple sections of the file that have conflicts.
Yes. Right. And I just want to also reiterate that those little kind of delimiter symbols are actually not code. So if we somehow miss them and try to save them, it would actually give us problems in compiling it in whatever coding language we were using it, right?
Yep. Or if I tried to pull this up, a web browser would not be happy with these things.
Yes.
Right. So, all right. So I actually want both images. So I'm going to just remove these notations and clean that up so I can have both cats, because there's room for more than one cat in my life. So there's room for more than one cat. And actually, in my household, there's actually room for 3 cats. But in this case, on this website, there's room for 2.
We're going to have to change this whole learn module now. No, I'm kidding. Yeah. Awesome.
So we've made the changes, we've saved the changes, but that doesn't fix our problem yet, right? We still have, if I run git status, it still thinks that we've got that conflict there.
Yeah.
Right. So what we need to do then is add our index.html and commit it. And that's going to tell Git that we are satisfied with the state of index.html and we're ready to proceed. We're ready to move past. So now if I do a git status everything is clean and we're ahead of our remote repository by 2 commits.
So
Why
I'll
2
ask
commits?
I'll ask a silly question right now. If there were more than one file, and it's not in our current thing, but if there had more than one file that had conflicts in them, and you just fixed one but had the other still kind of unresolved, when you tried to commit here, you would still get an error, right? It would still tell you that there are pending conflicts. Is that
yes,
right?
I wouldn't get an error, but my Git status would still show me that there are things to resolve. Yeah.
Okay.
So now so we're ahead of origin main by 2 commits because when we resolved the conflict, so we had our starting point, which was from Alice's changes.
Yes.
And then we had and so that's 0, right? We had our one change that we were bringing in from Bob, which was 1. And then we had our edit to make the merge conflicts go away, which was the second one. So that's why we have 2 commits.
Got it.
Yep. So, so now that we have our commits done or our conflicts merged, we can push this to our central repository, and we can get Alice all caught up. And so if we go and check out Alice and get Alice caught, we see we have a fast forward merge, and we can even go into our code editor and see that Alice has 2 cats too. Right.
Wow.
So
next time we should make them do this with rabbits, so they just proliferate. Okay. Yeah. Got it.
So we've now gone through, creating branches, merging them with no conflicts. We've walked through a simple merge conflict. Why don't we pop back? Because I think we have a couple more questions coming up. And,
awesome.
And I see a question. Well, so why don't we take that?
Okay.
And then we can move into some of those other stuff. So they're asking about, are there some best practices to create a new branch? Some people use git checkout -b in the new branch name. Others use git branch in the new branch, and then git checkout with the branch name. And for me, they're synonymous. I have more opinions about git pull and git fetch than I do about the git branch, the git branching workflow. Unless you're creating like a number of branches and you want to do all from the same point, I personally tend to do git checkout -b. What do you use, Nydia?
I prefer git checkout -b too. The only thing I would add to this is I think when I look for, what's best practices, I tend to focus on the branch naming scheme too. And I have found that like when working with big projects, sometimes it helps to have like, I don't know whether you call it a guide, a style guide, or like a program guide where you actually specify your team members, hey, use this kind of a format for the name. So the branch name tends to be super helpful. But yeah, when creating and switching, always fewer commands, the better. Also, if you're working with command line and you love it, then you can alias a lot of them. So even fewer letters to type in. Yeah.
All right. So
were there any other questions?
Yes, we do have. So a couple of them look like ones we've talked about already. The git pull origin master versus git merge master.
Okay.
And the reason that we do that git pull from our main branch, that's basically what the git pull origin master is talking about, versus the git merge master. Git merge master only we would be bringing our master branch into our topic branch. I tend not to like that. I personally am more of a fan of rebase because it keeps your histories a little cleaner. However, there's room for more than one opinion. But the other question that came up here, and this would be one that falls into the GitHub realm, is when I like a project on GitHub, I usually give it a star and make a fork. Is there a problem with making a fork and never giving a pull request? Do you have any thoughts on that, Nydia?
No, I think when you forked it, you're just making a copy in your own. You mean like fork someone else's project? You're just making a copy in your own space. So I usually find it depends on the reason for why you did that. Like if you want to contribute back to that, then, ideally it's going to end in a pull request. But I know I've done this, and I know a lot of people have done it where you fork a project simply so you can use it locally and try to do something with it. A great example is when you're trying to use a template to build a website and someone has published it, and you can just fork that, use it, and keep going. So you never contribute back, but you're basing it off of the fact that you can still go upstream to get any updates to that project. So I've done stuff like that. But if you're working in a collaborative team, chances are, I think you will always have pull requests somewhere down the line. So it's good to have that best practice there. Does that make sense, Stephen?
Yeah. I mean, ideally, open source projects would love to get pull requests that help them move the project forward, but it's not a requirement. And the one thing to remember is that project will keep moving forward, and your fork might not, right? Your fork does not automatically stay in sync with that remote repository. It's a clone at that particular point in time.
Yes.
So, so that can be moving forward. So you just need to watch for that. And
but you bring up a great point. We should also share resources with them for good practices for open source contributions. I'm sure we have something in that space.
And I think next week's session is going to be a good opportunity too to really dive into that.
You're right.
Git behaviors and GitHub the environment to work in.
Yes.
But let's get finished here, because I think we have a few questions to cover and wrap up.
Awesome.
And then any other questions come in, we will take them at the end.
Sounds good. So I'll put the slides back on, and I think what we just finished was the last of the demos and the most interesting one, in my opinion, where we looked at how you resolve merge conflicts. To recap, in this particular demo, what we looked at was a situation where Alice and Bob concurrently were making changes on the same file with their own personal changes that were definitely going to conflict when they were committed, right? So made a change as Alice, committed it. Everything was fine because no one else had committed a similar change yet. Now Bob made a similar change in the same file. And when he tried to commit, because Alice had made changes in the same file, there was a conflict. And in the terms of the conflict, the code lets you see that conflict in terms of these little special character delimiters, which tells you what the two branches, the one that you're in right now and the one that you're kind of merging from, what the changes are that were in conflict. And then Stephen talked to us about different ways we could resolve it. You could throw up your hands, was it Star Trek style, and just abort?
Yeah.
Or you can manually resolve it. We need a sign for that. Or you can manually resolve it. And that's the exercise we went through. So I guess that means that you're going to put me on the spot for a knowledge check now. Right, Stephen?
I am. And so if you're watching along and you're not on Learn TV to answer this, go to aka.ms/LearnLiveTV. But suppose you're trying to merge changes from your local branch into your project repo, but Git returns a merge conflict error. What can you do to restore the main branch to its correct state?
I really want to play with this one because come on. Now it's never going to get out of my head. But since we're talking about it, we'll just go through the others. So C is what I think is we did talk about git reset hard, but we didn't do git merge. Reset is not an option on merge. So that's absolutely not one of the right answers. So cancel or abort. Now, which one sounds familiar to me? Someone kept drumming Star Trek into me this entire episode. So I am going to go with git merge with an abort option, which effectively rolls you back to your last safe commit. Is that right?
It is. And there is a git reset, but it's not git merge reset. It's git reset. And then there's hard and soft, which are variants based on what they're going to do to other files in the file system. It's a little out of scope for what we're going to cover here today, but that's why that reset may sound familiar, and it is one way that we can deal with conflicts, but it's not part of git merge itself.
Yes.
Right. So.
Yeah, I'll go on to the next one. But before I do that, I'll also say that one of the nice things I really liked about the fact that we have that activatable sandbox is you can try these commands out right in there and see what happens, just if you're curious. And I found I learn a lot by just seeing what happens.
Yeah. And just to catch up, just to let you know, Nydia, everyone in the channel has been is right on track with B for that last one. So,
woohoo!
Yeah.
We got good learners.
Exactly.
Now I'm going to mess them up. This one's going to mess them up. I know, because it messed us up so many times, or me at least. First of all, I'll read out the question. We have 3 code samples here, and it says, which of the following samples is an accurate view of what Git might show? And this is where we need to pay attention for a merge conflict between the MyPenguins branch and the main branch. Now, the big thing that like later on I had to realize is to do this, I needed to know what my current branch was and where I was merging from. And so according to the way this is written, it means that we are in the MyPenguins branch and we are trying to merge from the main. So I think that's it. Let's go look at the answers. And this one, I think the easy one to eliminate was A for me, simply because, I mean, like even without knowing anything about what the context was, you can look at it and see that this is not valid conflict resolution information because it's missing that delimiter, the little equal signs that kind of tell you the two before and like, you know, upcoming and prior conflict merge results. So it has to be B or C. So the only difference between B and C is which one are you in? And from what I remembered, Stephen, you can correct me, the thing at the top, right, is really telling you what branch you're in and where the changes are in the current branch. So in this case, because it started with penguins, I'm going to say C. Are we right or wrong? I know it's a bit convoluted, but yeah, I think it's
yeah.
C.
No, you are correct, right? It is C. Now, if we were in the reverse order, if we were in main, like we were doing our dance where we get check out main and then pull and then try to merge our branch back, then it would be B. But
yeah,
this is the wording of the question. We are right on with C. So great job, Nydia. You've done wonderful on these knowledge checks, and you know this has been a lot of fun.
I get your third cat. We are awful people. All right. So, and yeah, that did confuse me, I will say, the first time, because like, you know, when we've been going through this repeated pattern of like, you know, check out and then pull and then, you know, push back, you're always in the main branch, but this was a bit different.
Yeah. So I do have another question.
Oh, good. Great.
So it was, please, could you talk about rebase versus merge?
Why did you have to ask Stephen this with just like 10 minutes left, right? He could talk about this for hours, but sorry, go ahead, Stephen.
No, it's, do you want to take a stab at it?
No, the only thing I remember, and I'm going to mess this up. So rebase and merge, right? The only way I remember rebase is that if you want to have a cleaner commit history, when you rebase, you effectively are doing the equivalent of looking at where the main tree is. You're looking at where your branch commits are, doing a diff, or at least this is what the process is under the covers, looks at a diff of your commit with that history, and then it keeps those diffs and then pulls the main one and then replays the diffs afterwards. So in a sense, when you commit it back, you can do a fast forward merge and your commit history looks clean. It looks like you were following along the main branch and then you made those changes versus kind of interspersing them. Am I explaining it correctly, Stephen?
Yeah. I mean, ideally, so there are some different commands. Rebase is a flexible command, and but the pattern that I was referring to earlier, and that Nydia was just talking about, is really I'm working along, and while I'm working, my main branch has moved, or whatever branch I'm coming from, right? That's moved along, and in order for me to make it a cleaner experience in merging back, I want to take my work, put it off to the side, and then replay it on top of the current state of things.
Yes.
And for me, that helps catch potential errors and problem and merge conflicts are a little easier to deal with in that state than if I would try to merge my changes into the current state of things. It also, if you're a little OCD about how your merge history looks,
yes,
or your file history looks, right? It's a cleaner line to do it that way, but it's not. One's not right and wrong because they're both effective. If I did a git pull master or git pull main, git merge master into my feature branch, it would catch me up. The merge conflicts might be because of the order of where the commits are, might be different because the order in which you change files matters.
Yes.
And so one may be more painful than the other. I tend to find that the rebase option leads to less painful merge commits and a cleaner line. So that's why I tend to favor it more. But
I think it also helps the collaborators because in some sense you're all following through with the list of commits that are in the head. And you do have a little bit more pain when you have to rebase in case there are conflicts that you have to resolve. But yeah.
Yeah. And then there's an interactive rebase, which allows you to reorder commits and which allows you to reorder, rename, take some out. So you can almost kind of do like little, like it's sort of like code history surgery that you can kind of go in there and move things around and do stuff. And but you can also get yourself in a whole lot of trouble. So I usually would say like practice in a branch that it like do a git checkout -b, give yourself a new branch, play around, get it the state you want, and then go do that somewhere where it matters. Because trying, you can also cause yourself a whole lot of pain.
Do not do this in a production repository for the first time.
Because when you start Git rebase has the ability to rewrite history in Git. And one of the important things about your source code is the history of the evolution of that code. So, there be dragons is a good warning to kind of keep along there.
So I think I'll also reinforce this other thing, which is like when you're working and you're learning a lot of this in your own repository, some of these may not be as apparent to you, but when you're working in a collaborative team environment and you actually rewrite the commit history, other people are going to be affected. So it's kind of worth knowing why you're doing it and kind of knowing that that's a best practice for the team. Doesn't hurt as much if you're the only person working on that repo.
And if you've done something that changes the history, when you push it, you will probably have to do -- force. And if you have to do -- force, it probably means that somebody else may be impacted by your changes. So just a little word of warning. But let's get back, Nitya, because I think we are now, we're pretty much to the end of this module.
We made it. Oh my God.
Congratulations, right? We made it.
We made it. And so this was really a great module. So let's kind of recap. And Stephen, if I missed something, do let me know. So in this module, when we came in, we talked about branching and merging. So I'm going to recap from the start. So first thing we talked about was what are branches? Why do you need them? And how can you create and switch to a branch? When should you use them? Then we talked about how to merge branches. And merging branches is usually a great idea when you have multiple people working on features in various branches, for instance. But that also means that you might have conflicts if there are concurrent changes happening that might actually be in conflict with each other. So we also talked about approaches for how you could resolve merge conflicts, either through something like Git abort, where you just basically throw up your hands and say, let's go run back to a safe space and walk away, or by manually walking through and resolving those conflicts and then making that change go back upstream. So with that, I think that was basically the main points of the summary. Was there anything else I missed, Stephen?
No, I think you hit it pretty well.
Awesome. And just to recap, just to remind you that if you didn't understand any of the commands like clone and all, definitely check out the the two modules that were done before this in the same learning path. And now I think we should be encouraging folks to do what exactly, Stephen?
We want you to go to Microsoft Learn and try this for yourself. And just calling back to what Nitya said was, sometimes you won't see some of these challenges in working with source control if you're just working with it on your own. And this learning path, this particular module in this learning path, gives you an example where there are multiple people working on the same repository. And so we set ourselves up for these potential pain points. And it might not be something you manually edit. Sometimes these changes happen For example, if you're doing node development and there's a lock file for the packages lock file that may change over time, right? Sometimes, depending on who's running it and if somebody updated it or not, like there can be differences and conflicts there. So there's a lot of reasons that you may have conflicts, not just because two people are working on the same file themselves. It may be tooling that updated it. But
yes.
But go check out the Learn module. Go to aka.ms/learn-git-branching. Play around. Try it out in Cloud Shell. And have a little fun with it.
Yeah, and I'll also add to this that
this.
I keep saying this to Stephen. That gives you 2 hours of an activated sandbox, right? Where at the end of that session, they're going to tear it down. So go experiment with that. Like try out different commands, see what happens. You're not going to hurt anyone by running within the sandbox. And this is where I learned a lot. Once you kind of play with the sandbox, try to see if you can install Git in your local environment and do the same experiments. So as an example, in the point where you wanted to actually open up the browser and see the web page, you can see it if you're in your local development environment. So try that out too. It's a lot of fun.
And so we had one final question come in.
Okay.
And somebody asking, are there branch creation patterns that we can check and learn from? And yes, there's a little bit. So there's a little bit written about this in the DevOps Resource Center. So if you go to Microsoft Docs and look for the DevOps Resource Center, you will find there's a whole section, Learn About Git, that talks about some branching patterns, and there's some talks in the like how we do DevOps at Microsoft vein, where they talk about how we structure projects and things. But for me, the absolute most important thing about branches are they should be short-lived. Right? The longer they live, the more painful your life will be, because the longer we wait to get back into main, the more conflicts we potentially can have. So ideally, we want to have those branches be short-lived, like less than a day. Like you should take it out for your day's work and get it back in. And there are coding techniques to help with that. So like if my feature's not done yet, I could use things like feature flags to hide work in progress such that it can't be accessed until it's ready to go. And so feature flags and other practices like that can help you get back into main faster. But again, shorter, better.
Yeah, and I think we should definitely get some of those links you talked about, Stephen, and put it into the notes for this page when these sessions go out. Speaking of which, as we talked about multiple times, this was the third of 4 sessions for this Learn Git with Learn Live series. You can go find this recording and the recordings of the previous episodes at ak.ms/learnlive, and definitely register and check out the session on May 17th, where we're going to talk about Git and GitHub. I have one last slide, but I'll also just kind of jump in on what Stephen was saying. A lot of this, you pick up when you work with teams. There are best practices. There's documentation on how that team chooses to do stuff. But when you do a lot of these, don't forget to do 2 things. Don't forget to document your work, and don't forget to test. There's no better way than to always make sure that your tests run before you do any of these large-scale changes to your code repository. And with that, I think this is the last slide that we have. So I don't know if you had something to say on this, Stephen, but I'm just going to put this out here for a second to kind of showcase the fact that this was the last in that 3-part series that contributes to one learning path. If you just go finish all these, you can earn a badge on Microsoft Learn. So that's great. And then the other 3, the one which says for the intro to GitHub products is not going to be covered in any of our live sessions, but it's a quick and easy self-start read if you want to understand all the products that GitHub has. And what they're really going to cover in the next session is 5 and 6. So the contribution, remember we're talking about open source contributions, looks like they're going to do something there too. So that'll be cool.
Yeah, and I just want to call out a couple of things before we sign off for the afternoon. First off, Microsoft Build's coming up. We have 8 Learn Live sessions scheduled around Microsoft Build starting on May 25th. Right. And then I also want to say thank you to a couple of the folks watching on Twitch. We have TRP 8472 saying, that he thinks that this is going to be it's going to help out a load, and appreciates the way that we explained it. Doesn't sound too daunting, which is great. Git is a huge topic, but ultimately there are a small handful of commands that can get you 80% of the way there. You can do most of your work without getting into too much trouble, too much serious trouble, and then gradually learn the bits that you need to with Git as you go. Right? Once you understand branching, merging, adding files, pulling and committing to to remote repositories, most of your work is done.
Hey there, everyone. Welcome to this fourth and last episode, unfortunately, where we try to help you in learning about Git here on Learn Live, where we will share another couple of interesting topics and mainly focusing on GitHub and VS Code this time. So we're going to step a little bit away from the ones who joined in any of the previous sessions we did here, talking about Git. Where now we're going to step away from the command line integration and moving on to VS Code, one of the prime tools we're going to use as a developer, maybe as a DevOps engineer. And for the ones who were not here in the previous sessions, my name is Peter, joining in from Belgium for now, an Azure technical trainer here at Microsoft. And I'm super honored and very excited to announce my colleague, presenter for today, John Papa. Hey, John, how's it going? Thank you for being here.
Yeah, thanks for having me. I'm excited to be presenting this with you. You've done many of these now, and this is my first Learn Live. I'm a principal cloud advocate with Microsoft. If those of you who don't know me, you can find me up on Twitter at the address here on the screen, John_Papa. And Peter, if I understand it correctly, you have gone through all the Git command line stuff. So today is all about VS Code with Git, right?
Yeah, that's right. Maybe just as a little reminder, and I know this is like edition 4, and somehow it seems like we only talked about Git only yesterday. But in fact, it's actually, it started about 3 weeks ago, where we introduced Git, like really starting from the basics. That was on April 26th. For the ones who missed it, we have all the recordings available on Learn Live. And if you're following the Microsoft Dev channel on YouTube, you could also watch them there again. After that, we talked about collaboration, where the first session was mainly I'm like working in my little cubicle, just on my own, creating some code and running some check-ins, commits. And then obviously we expanded it, talking about collaboration. And then in the session last week, we expanded with other really cool Git features, discussing branching and merging. Now for today's session again, we're going to step away from the Git command. The assumption is that the ones who joined us before, you already know the Git commands. We talked about the Learn module. I hope that some of you were actually checking in, going through the exercise. And today we're going to mainly use the graphical interface, using GitHub and using code, but a lot of the examples that we used in the command line will somehow be familiar, but you don't have to memorize them. That's really good. Now, again, if you missed any of the previous sessions, you could start at aka.ms/learn-git-live. And just as a reminder, this is a live session, so you picked up that I'm presenting from Belgium. And what about you, John? What's your location?
I'm in sunny Orlando, Florida, just outside of Disney World area.
That sounds nice. Well, for me, it's like 11 p.m., but perfectly fine, full of energy, like always when I'm presenting, and specifically on Learn Live, because I really like that live interaction. I would say to the audience that's already here, let us know where you're checking in from. Obviously, if you do have any questions, feel free to let us know. If you're new to VS Code or you're already a super expert user and you want to share some interesting tips and tricks, always nice to see that popping up on the chat as well. And just let us know, keep the interaction going. We're here for probably a bit more than 75 minutes. And as long as you're here, we're going to stay here as well. So looking forward to get some feedback there. Now, just as a other reminder, besides having the opportunity to send questions, let us know how you're doing. If you're already using Git, if you're using GitHub, if you're using VS Code, always nice to know. But in the end, the main purpose, I would say, of Learn Live is presenting some exciting videos, helping you picking up some new technologies, in a somehow fun way, but in the end, it's still about learning, right? So most of the information we're going to use today, at least for the first half, is coming from another Learn module, one of the close to 2,000 different modules we have in meantime. And you can follow along where the first part is the presentation, where you can follow along on the Learn module. And the second part, for the ones who are already familiar with the Learn Live concept, you know that we're going to spice it up with a couple of exercises and turning them into some live demos. And you can follow along using another short link, aka.ms/learn git VS Code with dashes in between the keywords. And feel free to, again, follow along if you got any questions. If you're stuck, let us know. And John, why don't you kick it up from here on the second part of the session?
Yeah, so after we go through the first part, which we go through VS Code and GitHub and how the integration works, we're also going to go through what it's like to contribute to an open source project up on GitHub. So this will cover a little bit of the best practices, and we'll actually walk through creating this stuff together. So anybody can do it. Should be a lot of fun.
So we can do this together? That's what you mean?
Absolutely.
Way cool.
All right, so with that, let's start sharing some ideas about how we can use these tools. And the big two tools we're going to use today are a web browser, so we can get to GitHub, and the other tool is Visual Studio Code. So Visual Studio Code is a lightweight, free coding editor that Microsoft, our employer, makes and software developers around the world use. Now, just because it's free doesn't mean everyone should run out and get this. I was one of those people who, for years, was changing my coding editor. And when Visual Studio Code first came out, I started giving it a test drive, and it really helped me along. The big things I looked for was that it's really fast to load, fast to use, it's free, and the extension model really makes it amazing because while there may not be a feature built into it that you want, there's a bunch of extensions, as we're going to show today, which really light it up. And one of the big extensions we're going to show is GitHub's extension for VS Code. And as we know, GitHub is a version control source system if you've gone through this series. So one of the keys for today is the problems that we're going to address. Now imagine that you are starting to contribute to a project up on GitHub. There's a lot of steps that you normally have to go through. You're going to get a copy of your repository locally. And even getting that copy locally might involve several steps. Peter, every time you want to clone a repository, there's several ways to do it. What's the first thing you do?
Using VS Code and clicking around for now.
Yeah, that's because it's easy, right? Before VS Code, we had to use like command line tools to do this, or go between the browser and the command line and back and forth. So you get this copy locally, and then you got to browse all the code and the history up on the GitHub website, and you want to figure out what the context is for why was this code change made? Why was that made? Who made it? How long ago was it? And all this stuff is a lot of context switching. Not about you, Peter, but it drives me nuts having to go between the browser and other tools.
Yeah, no, makes sense. And well, again, I already talked, and obviously I presented the first session on command line, but when we discussed about like presenting these 4 sessions, I was like, why should we go through like the Git and command line? Because is there actually anybody still doing it, right? Once you're so familiar in using VS Code, I'm like, nobody's going to do it. But the interesting thing is that actually a lot of our customers and partners, based on feedback in the chat, were actually telling us that they're heavily relying on it. So I think it's like the best of both worlds. If the VS Code interface, GitHub integration is not helping you out, feel free to check back in command line. So nothing's wrong with learning the basics, I would say.
Absolutely. Knowing the tools to make things easier and knowing the command line both are really great. I certainly use a little of each, but to be honest, I'm more leaning towards VS Code these days.
Cool. So what you're saying is that it's actually possible that by the end of this session, so let's say in the next 70-something minutes, that our audience should actually know like most of how to get started integrating GitHub and VS Code together?
Absolutely. There's like 5 or 6 commands I use every day, and that's like 90% of what you need to know, I think.
Sounds cool. I'm looking forward to that already. But let's maybe start with, starting with the starting point, I would say. So we talked about VS Code, it's a tool. And while you were talking about all the cool stuff in VS Code, I actually checked the website, and it looks pretty easy. By the way, the website, for the ones who never used it before and never installed it, again, if you want to follow along, feel free to do so. And you could go to code.visualstudio.com. Let me quickly switch open my browser. There we go. This is, by the way, the Learn module for the ones who've never seen Learn before. If you go to that short link we mentioned earlier, you could literally follow along what we're going to talk about, sorry. And from here, it's always like partly a lesson, partly an exercise where you can get some hands-on experience. For this one, there's no real Azure account needed like what we did in the previous sessions, using that Azure Cloud Shell to actually guide you through, but you don't have to do that anymore. It's all running from your local machine. Now, I wanted to send you to this website. So what I did while John was talking about all the cool stuff between VS Code and GitHub and trying to pull this over and not remembering command line anymore, it's super convenient. So something I didn't really know is that you have the exact same code interface, whether you're using Linux, Mac OS, or Windows. I'm using Windows. Are you using Windows, or are you more like a Mac boy, Mac fan?
I'm a Mac OS person these days, absolutely.
Awesome. So we can even do the same demos on different operating systems. That's even better. Talk about integration. I think it's another benefit. But from here, it's really as convenient as going to the download section or downloading it from here. Apparently, there's a stable build, and I can imagine that you can participate in some preview builds, which I'm not going to do for now because I don't want to blow up my demos for the session. But it should be pretty convenient. The other nice thing that I discovered is that you don't need admin permissions on your local machine to install it, which could make it a bit convenient in corporate environments. On the other side, if you're responsible for publishing software, you go like, wait a minute, I don't want my users to publish software on corporate machines without admin permissions. You could still distribute the code install files using your traditional software deployment system. And from there, the next step is signing in. Now, why do you need to sign in? Literally like any other, I would say, decent web application, where we're going to store source code and do a lot of other magic that we already did in previous Git demos. It means that you need to identify who you are. Now, we're going to walk you through a couple of scenarios, but there's actually quite a lot of different ways to identify, authorize, and authenticate yourself in using a GitHub project. Sometimes you're going to clone, like what John already mentioned. You're going to clone a project. You get a copy of it, and you can start working. From there, you're going to collaborate, so literally following the pace that we used at the previous sessions. Every now and then, you're going to start from your local machine and then uploading, committing changes, pushing them into a project. And that's where you really need to identify who you are. So you're going to start with creating a GitHub account. I don't have a live demo on that one because I already have my account. It's as easy as going to www.github.com. And the first thing it's going to ask you is like, can you please identify yourself? Now, if you're just want to look around, because a lot of the source code you're going to find on there is open sourced, which means that you don't really need to identify who you are. But in the second part of the session, you're going to find out that like contributing to open source is actually worthwhile, where you can literally help the open source community. And is that something you're doing, John?
I am, and it's a really good thing for folks to get into, and there's easy ways to slide in, but we won't give away all the magic. We're going to go in the second half.
Obviously not. Now you're going to see that again, we're mainly talking about the integration between VS Code, our DevOps environment, and GitHub, where we're going to store our source control and making commits, making changes again, anything we already talked about in previous sessions, but now just using those two tools. And although the authentication could be a little bit complex, depending a bit how you want to use it, you could log on with a GitHub account. You could log on with SSH keys if you're coming from a Linux or Mac OS. But one of the biggest benefits is that you do have the visual code integration and technically making use of that to handle your authentication. So again, once you created your account, it's actually super convenient. You have your account in GitHub. You can close the browser. You don't need it open anymore. And from there, you're going to do everything from VS Code. And something that you already mentioned, John, is that you don't want to flip over from like the browser back to code, from the browser back to code, from code back to browser. And technically, you don't really have to do that anymore. It's all like really integrated. And again, for the audience, that's what we're going to show you. So one thing I noticed is that once you have your VS Code up and running, and you got your GitHub account. The only thing you need to do is literally hooking the two worlds together. And there's an account option in VS Code. You open your browser window. Out of the VS Code, you define your permissions, and from there you literally identify who you are, and you can take it away.
You know, one of the really powerful things we mentioned, Peter, about VS Code is how you can use all the extensions with VS Code. So what's cool about this is the product doesn't keep getting bigger and bigger and bigger. VS Code's actually very small and fast, but we can add in different extensions to augment what's happening. So what we're doing here is you can access your VS Code, you can access GitHub through VS Code with a bunch of extensions. Now there's a feature in this, which we're going to show you in the demo in just a moment, where you go and you set up which extensions are trusted. This is so certain information about logging in from GitHub to VS Code can work for you. So you'll see a screen like this as we go through the demo that actually shows you, okay, here's our GitHub pull request, for example, for the extension. Let's go ahead and give this permissions so we can access the information and log in. We'll go through that in the demo a little bit later, though, Peter, won't we?
I guess so, yeah.
And then we're also going to talk about the features of the GitHub extension inside of VS Code. Now, what things can you do? Well, let's talk about the most common ones. You're going to be able to clone your repositories, search for repositories that you created, or even look at things like create pull requests, go access pull requests, check them out locally, look at the issues. They even find issues or pull requests assigned to you, which is really fantastic if you work on a large project at your company or an open source, because then you can say, only show me the issues that were assigned to me so I can just work on those as opposed to the entire list. So we're going to look at the built-in features as they come up next here. You want to take it away, Peter?
Yeah, sounds way too easy, but you already know, and I hope I can share that same excitement to our audience. So yeah, like you mentioned, I love it where you're like announcing demos, but then shifting them over to me where I actually have to do all the work. But what we're going to do here is literally what we just talked about. So again, we already have a GitHub account. We installed VS Code on our local machine. And from there, the next step is building up that integration, signing in. And in short, it's hooking into the extensions. For the ones who don't know, if it's the first time you're using VS Code, again, we do have the chat integration. If you got any questions, if you got any cool stories that you want to share, good or bad, feel free to let us know. If you're struggling with something, I think this is the best way to let us know as well. And more than happy to give you some feedback on how to avoid any of those challenges in the future. So briefly, what I'm going to do is building up that integration. I have my GitHub account. I got my VS Code installed. And from there, I'm going through the extensions, where an extension is, I would say, really what makes VS Code even more awesome than it already is. Today, we're mainly going to use extensions for GitHub, but there's an extension pretty much for everything. If you're working with Docker containers, with Kubernetes, with Terraform templates, Bicep, if anyone who's into infrastructure as code, could be Terraform, ARM templates. Our newer way of working, Bicep, we briefly touched on it in previous sessions as well. You got extensions for all those little pieces of magic that makes your day-to-day work in GitHub and in VS Code even more enjoyable. So enough talking for now, I would say. Let me switch to my code environment. And by the way, I installed a little theme. What is a theme? It's where you can customize your look and feel. So I know some DevOps engineers, they like a dark mode, but it's a little bit harder for presenting. So we switch typically to like a light mode. The one I'm using is another extension actually published last year at a .NET conference where they announced .NET 5. And it's reflecting that interesting purple, where for me, like 11 in the evening, it's like making my eyes a little bit more quiet, I would say, and making it super convenient to work in this layout, pretty much the whole day. So let's start with extensions. So there's this little spot up here called extensions. You can find the same in the menu, but you'll figure out once you start using code, you're going to make it pretty convenient and finding it from there. And once you start opening up that extension pane, you're going to see that it's like showing a huge amount of extensions. There's another way you can find them. You go back to that same visualstudio.com website where you downloaded code in the first place, and you could search for marketplace extensions over there. And it's literally a super long collection. I never really looked how many we do offer, but it's amazing. Provided by Microsoft, provided by vendors, overall provided by community. So from here, you start searching for GitHub, and you're going to find that a lot of them are, I would say, official ones coming from GitHub, and other ones are coming from Microsoft employees, coming from MVPs, Microsoft trainers, again, partners, overall community. They're literally contributing, to the success of the VS Code environment. So one of the tools John was talking about is this GitHub pull request. So you select it, you install it. Again, to speed up the demo a little bit, I already have it on my machine. If you like some of the GitHub main colors that you find on the GitHub website, there's a theme for it. And then, for example, this one is offering similar integrations, but it's not offered by GitHub as an official one. But nothing blocks you. It doesn't mean that if it's not coming from the official source, that it's not good enough. So a lot of community work and effort has been put into it. But let's focus on the first one.
So Peter, if I could pause you for a moment, you mentioned GitHub as an official source. Mm-hmm. Can you point out real quick to everybody how they know that it's from GitHub versus some other place?
Oh, yeah, sure. So for each and every plugin or extension, I should say, it always mentions the source. So up here it says GitHub, up here it says GitHub. And easy said, at least for the list we're having here on screen, this would not be from GitHub unless this person actually didn't check it out. Is maybe working for GitHub or Microsoft, that would still be considered as an official source. So that's how you can identify it.
And it's perfectly fine to use an extension from another person. I mean, I've got my own extensions that I've published, for example. But in this case, if you're looking for the right one, the big key is looking for something that's published by GitHub, right?
Mm-hmm. And then, well, the other reference I would say is obviously like the amount of downloads. It's not always like a guarantee for success, but it shouldn't be a surprise that the more downloads you have with next to that a pretty good ranking, it typically means that it's actually working as it should be, or at least the features that are provided by the extension are actually doing what it needs to do. And then in the middle, you can find some details, like what is the functionality I'm going to get out of installing this extension, and really enriching, making your VS Code, again, even more awesome than it already was. So I installed this pull request extension. And from there, I went to my account option down here, where now it says to, and I'll show you in a little bit larger view what's behind this. So again, it's the first time you install that extension, it's going to ask you to authenticate, where my GitHub user is PE Tender. For anyone, if you want to contribute to some of my repos projects, we'll guide you through some scenarios later on how to do that. And once I have this GitHub pull requests and issues, that's the extension we installed. The only thing I need to do is signing in, where it's going to redirect me to the GitHub in the browser. Makes sense. It's like GitHub validating who I am. And obviously, I need to authorize. And that's pretty much all that I need to do. It's going to read out some personal user data. I would say don't freak out. What it's trying to read out, it's literally telling you, like, I want to know who you are, reading out your email address. Why? Because later on, if we're going to like run commits, you already might remember from previous sessions that you somehow need to identify who you are. And that's going to make it so much easier in following up, like who you are, who pushed commits. And authorizing, providing my password. Do I remember my password? Good question.
1, 2, 3, 4, right?
No, I'm even sure that GitHub is not accepting it as, oh, why is it so hard to type a password and talking at the same time? Just give me a second. That should do it. There we go. Success. Site is trying to open code. Cool. So that's literally what John was talking about, right? Where you start with code, you go to the browser, and then you go back to code. So little piece of magic. Do I want to open an extension? It's coming from Git. Just a warning for the audience, just click open without reading what's actually happening in the backend. validating that it's coming from a safe source. It's VS Code and GitHub authentication. Sounds good. And that's basically everything we need to do. I'm not going to move on with GitHub Code Spaces. It's another extension I already had on my machine, but that's not relevant for the demo. But that's literally all it takes. So now we have this really cool, nice integration.
And that's just a one-time thing, right, Peter?
It's a one-time thing. Yeah, I signed out to literally go to the demo again to make sure that I could show you from the start what it actually looked like. And that should be about it, I guess. You're going to add something into it, John, and maybe covering a little bit on repos and how to publish them?
Oh, I think so. Maybe I'll do something special as we come up through here. So once we log into GitHub, and as Peter mentioned, you do this generally once, and it's been, I don't know, months since the last time I did this, probably since I reinstalled the operating system on my machine over here. So you do it once, you're hooked in, and you're good to go. But after that, we're going to go through and figure out now how you can publish your own repository using VS Code, or Visual Studio Code, through the extensions. So one of the cool parts is you can just start working. Imagine the scenario. You're on your machine, you're working on code, it's not in GitHub, you get this great idea for a project, you start moving forward, and then suddenly you realize, I need to publish this on GitHub. And maybe I should have gone to GitHub first. How do I do this? So one of the cool things here is you can actually use the extension to publish your project directly from VS Code, which we're going to take a look at.
Sounds way too easy.
It is. We got to make it harder. So at this point, let's say you want to go through publishing. Why isn't this hard? Or why isn't this easy? You think about the steps you have to go through. If you've done this a lot, you probably think this is easy. And easy is relative to everybody. It's always relative to the experience you have. But first, generally what I used to do is, let's say I started coding locally. And then I'd say, oh, I want to put this on GitHub. I'd then go up to GitHub, to the website, to my repo, log in. There's a couple steps there. And then I'd go create a GitHub repo on github.com, enter the name of the repository, and then I'd select the checkboxes that it wants. I'd also want to go back to my machine and run git init locally, so I've got to figure that out. I have to add a remote endpoint. What's that? That's the name of basically the URL, so my local machine can figure out where is it on GitHub. Okay. I have to specify the items that I want to publish to GitHub, because why is that important? If you're like me, you've at least done this once where you have some kind of secrets file locally and you accidentally publish it to a GitHub repo. Well, that's not good, right? Like, let's not go there.
Don't do that. You should know really, better than that. Come on.
And then you got to figure out and start Googling, how do I get rid of that off of GitHub? And it's, no, don't want to go there. So the first thing I do is I specify a gitignore file, and which ignores files. So basically, let's say I had a file locally called .env for environments, pretty common, and I've got some passwords in it for a database. So locally, that's great. I don't want it in GitHub, though, so anybody can grab my password. So the first thing I would do is set up a gitignore file locally, and that tells GitHub to stop and don't take this file. After that, then I have to stage my files, which is just a fancy way of saying identify the files that you want to push up. And then we add a commit message. Why? Because we're going to be committing, basically means commit it up to GitHub. So we have to add a message for what were we doing with this set of changes for these files. And then finally, we actually push it from our machine up to the repository in the browser. And not about you, but I've already forgotten half the steps I just said.
Yeah, you lost me there.
Yep. But the good news is there's a better way, and Peter is going to show us.
I'm going to make it so much easier. Well, I'm going to talk about it first, and then you're probably going to show it, right?
Okay.
So, yeah, we need to come to an agreement here, but I'll talk about it. Let's do it this way. I already did that first demo, so you might jump in and show something from your side. I've never seen VS Code on Mac, by the way, so it could be an interesting way to see how it looks and feels. But you talked about publishing. It's like, I don't know, 7, 8, maybe 9 different steps you need to go through. And again, I remember we did all of that in the previous sessions with all the Git comments, and it's I'm not going to say it's a nightmare, but it's just way too hard in my opinion. And just to be clear, there's nothing wrong with it. We don't want to force anyone to like forget all the command line stuff and then move to code and GitHub integration. But hopefully you got this aha moment or even the wow moment. At least that's what I had like 3 years ago. And I'm still using it every single day. So in short, what you can do, there's a couple of different ways to do this. And you're going to find out in John's demo that it's like super, super easy. The first thing after using the VS Code base install, you don't need to deploy any other extensions. It's already source control ready, where you should remember from previous sessions that source control means we're going to interact with our repositories. In this case, using GitHub repos. So you literally open VS Code, you go to that SCM little pane in the extension bar, right on top of it, I think, at least on a Windows machine, but we'll find out. And from there, you can just literally select it. Or another option is using our command palette. And the command palette is like the top menu with a couple of keywords, a lot of capabilities, because every now and then, I'm not really, I would say, like a 100% coder. As you find out in my introduction, I'm mainly providing training every single week. But I know a lot of developers, and they're not even using a mouse anymore, where it's everything is literally done from like short keys. And that's where that command palette could become pretty convenient. So you go into VS Code, you select that little bar on the left-hand side, or you can go through the command palette. Super convenient. A couple of screenshots here, but I'm quite sure that you're all eager to see a first demo coming up from John. So what you do is selecting that little source control icon with a couple of animations in the middle that John will talk about, or using that top menu, opening the command palette, and depending on the extension, based on the extensions you already have, it's literally injecting a lot of command integration where you can just literally search for him. You can click around, but I think, John, you need to convince them with another demo.
I think that sounds like a grand idea. So this next demo is based on the same exercise that Peter started with, and we're going to build on it. So I'm going to go and create my own set of code, my own stuff locally, and then we're going to use the tools that Peter just explained and walk through VS Code to publish my code in a new repository up on GitHub through Visual Studio Code. So the basic steps here, we're going to create a project. We're going to create a README file. Everyone should always have that. We're going to create a .env file that we're going to have for development. We're going to publish things up to GitHub. Then we're going to go look at it at GitHub. And we'll take a look at this gitignore file that gets created for us to kind of find out what that's all about.
To make sure that you're not uploading secrets.
Yeah, I'm not a very secretive person, so we're not going to do that.
My encrypted password.txt.
So I'm going to take the control here and share my screen. And let's see how this goes. And Peter, if you could let me know as soon as it's there.
It's there.
Awesome. So I'm just going to show you first, the first step in this whole thing is to create a folder on your local machine. And I've got a little terminal window. It's a tiny one up here. And we're just going to use it for a minute. And I'll blow it up super big so you can see what's going on. Now, I like to put things into a folder. I have a folder called Play on my computer because that's what we're going to do. Peter and I are going to play with you and create some new projects. So first, let's create a new folder in here. I'm going to use the command, real old command line. You can do this through Finder on a Mac or Explorer on Windows as well, if you wanted to do that. And we'll call this the MS-Learn demo. And now if I go into that, you'll see if I do a quick list, there's nothing in it. But what I could do is get rid of the terminal, go over to the VS Code Insiders. I'm actually using the, I guess it's unstable, Peter. It's the Insiders version of VS Code, which is actually a daily download from the VS Code team. And the reason I use this is because it gives you new features every day. And it's actually the version the VS Code team uses to write VS Code. So it's kind of like Inception. So I use this version because I get new features faster. And I recommend everyone else try it too. So what I can do is go up to here to File, Open, or hit Command-O on my machine. And then what I can do is go down to my Play folder and MS-Learn Demo, select Open. And there's my folder. You'll notice I'll get rid of the welcome screen. There's nothing here. I don't know about you, but an empty screen kind of scares me sometimes, Peter. It's like, what do I do next? So there's a couple things here we want to do. I want to create a file called README. And there's a few ways to do this. First, I can right-click over on the left in the Explorer and choose New File. Or I could choose File, New File. Or if you're a command line person, you can hit Command-N. You can see the command up in the menu. And here's a good tip for everybody. If you want to learn how to use the keyboard with VS Code faster, when you're going to the File menu and you see these commands, always look to the right and see what is that command. So I can hit Command-N, and it opens up a new file for me. So the file is not yet saved, and I want to save this as README. So I can hit Command-S or Control-S, or I can come up here and press Save in the File menu. Let's do that, and we'll call this readme.md, and the convention is to put README in capital letters. And then it'll appear over on the left as a README file, and there we go. Now I'm looking at the instructions from the Learn module, and it says I should create a README file with this content in it. So I just copied and pasted that, and real quick, there's my README file. Now, something you want to remember is to save this file. Now, I'm going to give you another tip that's not in the Learn module, which I really recommend. Up under File, you'll notice I have Autosave turned on. Autosave is exactly what you think. It automatically saves your files, which protects you from things like this. Let's say you put something really, really important right there. Now, because I have autosave on, it's now saved. But if I didn't, I'd have to press save first. So all that would then be saved for me automatically. So do you use autosave, Peter?
I'm pretty sure I do. I already forgot that I enabled it, but I'm pretty sure it's there.
It is nice, though.
Yeah, I would have lost a lot of code already.
Yeah, and we're going to create a second file, Peter, because, hey, one's not enough. And this time, I'm going to go up and do File New from over here. And I'll do File New. In this one, I'm going to paste in the contents before we save the file. It's going to be my environment file with my connection string for my database, which please don't let that be your connection string. And now I'm going to hit Command-S to save it. And this time, I'm going to type .env.development. Now, when I do a dot file, it's going to actually prompt me to say, did you really mean to do that? Because those are like reserved file names. Yes, I did, because this is my secrets file. So now you're going to see .env development, and you're going to see the README. And just to make it easier, I'm going to drag the .env development side by side so we can see both files at once inside of VS Code. Nice little feature. All right, now that we have all of this, we've saved everything, and we've got our README, we've got our development file. The next step is to publish this up to GitHub. Now, over on the left, you're going to see a bunch of little icons here. And what this one right here is, with the little dots and the lines, is source control. We're going to click on that, and it's giving me two commands. I can initialize my repository, which means locally, or I can publish it to GitHub, which is also going to do the init for my repository. So we're going to click on Publish to GitHub. Now it's going to ask me, do I want a private or public repository? So I'm going to make this public so you can all see it too as we go through this. And that's what we recommend. You can do private if you don't want others to get to it yet. And then it's going to ask me which of these files should be included. Now notice I said I have secrets and database connection strings in the environment file. I don't want that to be included. So I'm going to uncheck that right here. And then I'm going to click OK. So by doing this, a couple things are going to happen. First, you can start seeing in the bottom left, there was a little circle spinning around. In the upper left, the source control had a progress bar. And in the bottom right, just to make it complete, to make you look in all three directions here, there's a message, which my Teams window is blocking. It says it's successfully published, thankfully, up to my repository. Now, do you want to see it? Do you want to press the button with me, Peter?
Go ahead. I trust you.
All right, I'll press the button. And I'll drag this window over from my browser. And here is johnpapa/mslearn demo. And we can see we've got my really, really important README file. And we can also see there's a git ignore. So let's go look back in our project and click on the upper left. That's the Explorer. And notice we have a third file. So if I click on that third file, it added .env.development. And it did this because we specifically told it, don't push this file up. So it created the git ignore file, which is a convention with GitHub, to say, don't look at these, don't push them up. And that file does get pushed automatically but it says this is the pattern of files. So anything with the file name of .env development, which is this one over here, will stay local, but not up into GitHub for you. What do you think, Peter? Not too bad?
No, pretty cool. Actually, there's a question from the audience, and well, you showed us like 2 different files. You excluded one in like the git ignore, but the question is, do we have to specify the files that you want to include in the repo one by one, or is that SCM plugin smart enough to detect like any changes in the folder? Like, let's say you're creating, I don't know, some kind of application source code with like 300 files in there in 200 different folders. Is it intelligent enough to detect it, or do you literally need to click all of them, or like Control A? How does that
That's
work?
a really good question. And let me answer this in 2 parts. So when you're first pushing your repository, which is what we were doing here, VS Code will ask you specifically for which files do you want to include, and it selects them all by default. So when you're first doing it, you probably don't have 500 files, hopefully. I mean, you should do this before you get there, I would recommend.
Yep.
In this case, we had 2. And that's why I initially unselected or deselected one of them. I took up the check mark. But let's say we fast forward now and I've got 500 files, which is very common in subfolders. What this tool will do, if you look over here on the left, notice what happens as I change my README. If I say hello, Peter, with a lowercase p, now, once the autosave kicks in, you'll see over on the left, there's a little 1 in a blue badge over the source control right here. And that 1 blue is showing us the changes. And we're going to learn more about what those changes do as we get a little further along inside of this demo. So to answer your question, yes, VS Code will track all the changes for you.
Nice. I like it. Let's see how good we can switch back to Belgium from Florida. Taking a plane would probably take us a little while, but
yeah, I don't even know if we can fly yet. So
it's under discussion, I think, and it seems like the US can probably visit Europe faster than Europeans can visit the US, but we're not going to talk about it for now.
We want to stay positive today.
Yeah, let's try to do that. So yeah, thanks for the demo, great stuff. And in the meantime, we answered that question. So let us know how it arrived on the other side of the world. And for the ones who forgot about it, again, you can follow along. You can go through the demos and the exercise out of the Learn module. And we're still here for another 40-something minutes, I guess. So feel free to let us know how you're doing. If you got any questions, more than happy to go through them and answer them. But let's move on a little bit and talking about cloning repositories. So what is cloning? It's literally like sharing everything you're working on with your peers, could be your colleagues, could be a public project like the one you created, sharing it with the rest of the world, and then maybe influencing that open source model a little bit. So now imagine that you want to contribute to another project. So up till now in the demos, we talked about something that you as an individual, you create John's little project and uploading it, but maybe you're on the other side of the GitHub platform and you want to start contributing to it. So one of the first actions you need to take is cloning it from that online GitHub repo. Again, could be public, could be a private. Like we're not just sharing code with the rest of the world. If it's like our internal, I don't know, corporate business application, you could still use GitHub, but maybe I would recommend moving it into a private type of a repository. So there's a couple of things you can do here. So you're going to contribute, which means, again, we're going to share code. It's already up and available in our GitHub repository. And we're going to bring this to our local machine, or the other way around. Once we're going to make some changes and we're going to upload them again, that's literally what we're talking about here. So in short, little reminder, bringing back, I don't know, stepping back in time, back to the history like 2-3 weeks back, where we initially talked about Git on your local machine. And in the second session, we talked about literally contributing. So when you clone a repository from GitHub, it's literally creating a full copy, everything that's in that repository. it's literally synchronizing everything to your local machine. Now, if you use that Git command line, you needed to provide your GitHub credentials using that Git set command at the beginning, Git setup, where you provided your user.name and the user.email to identify who you were. Next to that, you needed to define that remote URL, and from there running like git clone pointing to that URL, what we called remote endpoint before. And from there, it's literally copying everything to your local machine. But we could probably optimize this a little bit more. Can you talk a bit about it, John?
Yeah, totally possible. One of the nice things is this will look like, the screenshot here will look like what I showed a few moments ago in the demo. It's a little bit different. So we still have two blue buttons, but this time the key blue button is we can clone a repository. So when you open up VS Code by itself, one of the options in the Explorer is, hey, what do you want to do? It's trying to help you with that blank screen syndrome I mentioned. So you can click on the clone repository button and automatically will ask you which repository would you like to clone. And it can help you find it. If you don't have this, you can just go over into the File menu and look up the View menu and look at Explorer, and then you could do Clone Repository as well. You can also use the command palette to get here. So there's always multiple ways. My old reliable in VS Code is the command palette, which the way you open the command palette is hitting the F1 key, whether it's Mac or Windows. Works on both machines. So that's super cool to do. And once you do that, you can then git clone your repo right from Visual Studio Code. But now what? All right, so we clone a repo, which effectively means pulling it down off of the internet. Now you want to contribute to it. So a lot of times you're going to want to start with a project to look at what files are there and what's in the history. Well, one of the great things about the extensions is you can look at the timeline of what's happened to this file. Notice a screenshot here. In the timeline, we can see the initial README, the oldest one's in the bottom, shows us here that we've got this commit for the README. We've got our initial commit from Burke Holland, a good friend of ours, works at Microsoft. So Burke made a change for the initial commit, and then he went in and updated the README with a second commit. So you can actually look at the timeline, when it happened, who did it, and you can actually click on it to see what happened. This is incredibly helpful when you want to look at file changes, especially when you're doing diffs, right, Peter?
I'm pretty sure.
So what's a diff?
I was just going to ask, I forgot about it. Remind me, what's a diff?
So what's the diff? It sounds like slang for something my kids would say to me, Dad, what's the diff? Well, the diff in VS Code it stands for difference. And you're going to look at the before and the after of a commit. So here what we're showing, it's not important to read the actual file, but on the left-hand side and the right-hand side are the same file, but with the diff shown. So on the left is the original version of the file. On the right is the changes that were made, which is currently there. It's the difference. So it's a convenient way to show you side by side what's been added, changed, or removed. And on the right-hand side in this one, we can see it's in green. I'm colorblind, so I'm hoping that's green. I believe that's actually adding content to the file. So it'll show you in green or in red to allow you to see what's added or changed, which is super easy to look at in this particular way. It's better, in my opinion, than having to go back up to the browser, go look at the history, and try to figure out what changed here. Instead, we can choose VS Code to show it.
Yeah, running this from command line. I'm never going to do that again.
I remember those days. Whew.
Well, you said it's easy, so I'm going to challenge myself and switching to the next demo, and I just want to try it out. This seems like too easy, almost impossible to be that easy. So I just, I like to convince anyone at midnight my time to just convince you that it's really that easy. I'm going to show you. So in short, again, what we're going to do here is connecting my VS Code environment, cloning a new repository from GitHub, so it's already there. I'm going to clone it to my local machine, and I'm going to inspect what our friend Burke was actually doing. And again, showing you how easy and straightforward it can be. So let me first close up a couple of things here. And one of the other interesting ways to do that is you don't need to close code and opening it up again and starting all over. You could literally just open a new window. And what this is going to do is keeping the old one live and at the same time starting a new one. Now you could go like, wait a minute, that's actually pretty interesting. But what happens if I close one of them? So maybe you don't need that last window in the back anymore because that's still there from my previous demo. I don't need it anymore. Obviously, it's just like any other window. On Windows or Mac, you could literally like move it around, doing some cool stuff with it. So I'm going to close this one, where now I'm just in my new window. Let's see if I can maximize it without any annoying pop-ups, apparently. Ooh, close. There we go. Because otherwise, I don't have my comment palette option here anymore that John was talking about. But I could go back to our source control, because again, source control, that's referring to everything we stored in our repositories, in this case, GitHub. And the other option is up here. It's already there. And from here, command palette, you can start. I want to do some cloning where, cool, it's git clone. Why is it not GitHub in this case? Because it's relying on the good old Git in the backend. So we're going to do source control, and we're going to clone a repository. Confirming, and it's going to ask me like, what repository do you want me to use? Now, as you can see again in the previous demo, my first demo at least, I identified myself as being PE Tender. That's my GitHub account. And it automatically assumes like, hey, you got all your projects, all your repos in GitHub. So probably most logical step is that you just want to clone them to your local machine. Now, luckily, I already did that for most of my projects. So let's check back what Burke has been working on last couple of days or weeks. And it's somewhere public on our Microsoft Docs, and it's a Learn module. And I don't know Burke that well, but I know he's pretty good in Python, so I guess it's Python. And let's try this one, products. There we go. So next it's going to ask me like, select a folder on your local machine. So let's create something on my local disk. I got OneDrive, like my personal backup system, but let's keep it easy for now, although that could actually work. But you probably don't really need a backup because you already have all the files in GitHub, so that would be like a waste of cloud space. And we're going to call this one the Python products. That's the name. Now, the nice thing is that the GitHub integration with code is not forcing you to like reuse the name for the folder to be the same name as the name of the GitHub repo. So that's another interesting one. Every now and then it could become a little bit more complex to like remember what is the actual local file name or the folder name that I'm using, like my local repo if you want, and how it reflects. We're now from here. Let's see if I'm fast enough. The cloning was even faster than I could zoom in, where it was cloning, and it asked me like, do you want to open it up? And even better, do you want to open it up in a new window? So I'm going to keep it easy for now because I just showed you how to open a new window. But technically, what it allows you to do is literally hopping around from one window, one project to another. And all the data is in here. So we can see up here, this is the repository coming from my local machine. It's literally Explorer on my local machine. And we can see some additional information here. So let's check back in that README file, because I think that's where one of the changes happened. Or let's check back what happened. And what we already talked about before, you saw the screenshot. In the meantime, it's a little bit more outdated, what Burke was doing at that moment in time. But we could see that, like any good practice, we talked about it before, Burke created this repo, creating that README file, and from there committing some changes. And from here, what we talked about before, you can see that it started from like a blank README file and eventually adding some changes. And that's really how convenient it can be. The other nice thing I discovered is that, remember in session 2, we talked about collaboration. Session 3, last week, we talked about branching. And you can immediately follow along like, I cloned a repo, and this is the branch I'm using. And the full history, there's only like 2 items in this one, just for the sake of the demo, not making it too complex. But if you got like a whole team working on it, you got 500 commits happening every week, you could literally go back and validating like what has been changed. So again, all this is cool. I like it way too much instead of relying on the command line. You already know that. Good. Now, I think we're a bit, about a little bit more than halfway through. So what we typically do in a Learn Live session is validating how well the audience is following along. And I just checked there's, for now, no questions coming in. That means that or everybody's already up to date, or our demos are so amazing and they're probably just literally fell on the ground that everything is just working as it should be without memorizing any command line. But let's check back how well they are up to date on what we've been talking about. So let's start with the first question here. What would be the best way to prevent files from being published to GitHub? So from your local machine, publishing them to GitHub. And you want to prevent files from publishing. So you have your local project, you're going to upload it. So when everything works out fine, the question shows up on your end of the world and you can participate. Let us know in the chat. Just answer if it's A, B, C, or D. I mean, it shouldn't be harder than this. But John, why not helping our audience a little bit? Like, let me look into your brain, at least a little GitHub part, what we talked about up till now, and let me know what you would go for.
Let's do it. First of all, I'm going to let everybody know that probably like you, I'm not a big fan of tests. So let's find out how well we can do together on this quiz. Now, I always try to read the question carefully because I'm one of those people who reads questions and then usually misses key words. How about you, Peter?
Oh, yeah, I'm a Microsoft certified trainer and I'm trying to help our customers and partners every single week. And obviously, there's a lot of questions coming up like, yeah, but what's the exam like? And one of the first things I tell them, if you want to optimize your passing rate, make sure that you read the question carefully. That's like almost half of the reason why you fail or pass.
So I'm gonna start there and take our advice. What's the best way to prevent files from being published to GitHub when you're publishing a new project that has not yet been initialized with Git? And I'm thinking the key here is interesting. When I'm publishing, so Peter and I showed in the demo a few minutes ago, we're publishing a project. I think it was my demo where I created some code locally and then I published by clicking the blue button on the left. And then, if I remember correctly, it popped up a box asking me some questions. So let's read these. Now, with that context, let's go through these. I'm going to take and start at the bottom because I see one that's just doesn't seem right to me. Cancel the selection? Wait a minute. Cancel the selection of items. Well, maybe there's items on that list. That could be it. What about C? Let's go to C now. Add a gitignore file during publishing. Peter, were we even offered the option of adding a gitignore file after we published?
I don't remember, but I was checking feedback from our audience, so I might have missed it.
Yeah, it didn't ask me if I wanted to do that, so I'm going to say no. Right-click the files and add to gitignore. That is a thing you can do. I happen to know that, but again, we're publishing already, so that's too late. So it's not B either. Add a gitignore file to your project. Again, that's something you could do, but again, I think the key word here is when you're publishing a new project. So let's go back to D. Cancel the selection of items. We did get asked for items we could cancel that you don't want to publish, and I didn't want to publish my environment file during publishing. So I'm going to go with D.
Cool. Let's see what the audience thinks. So we actually got 50-50 for answer A, and the other half is going for option D as well. So nobody's going for B or C. Little drum roll. And
there's nothing wrong with it, right, Peter? I mean, you can add a gitignore file to your project, but that not while you're publishing. It's already in process.
Yeah, I liked it. When I saw the question, my thing was like, yeah, it's going to be A. I mean, gitignore, you talked about it. We joked about it, like, don't store this is my encrypted password.txt, so just move it into that gitignore.
Yeah.
But that's not really helping you during publishing. So it's actually even more interesting where you got the benefit of using that gitignore file. But on top of that, you could still select the files that you want to publish. There's part of the repo, but you don't want to publish them yet because maybe, I don't know, you got lunchtime and after lunch you want to validate. So indeed, best option here is answer D.
Absolutely.
Oh no, we got a second question coming in.
Yep. So on this one, it's asking, how do we set the origin remote for the repository that you clone from VS Code? So Peter, do you think VS Code sets it automatically? Maybe?
I would hope so, man. I would hope so. I mean, with all the cool stuff we talked about so far, that would be even more amazing.
And then the second option is, do we select add origin when prompted after you clone? I don't remember you doing that at all. So I'm going to say no to B. Run git remote add origin. That's a terminal command line thing. And after the clone finishes, I mean, that's something we could do. But again, I didn't see you do that. So I'm going to say it's not B or C. I like A and D because the word automatically is in both those answers. Now, I'm going to let you guess. I got it down to A and D. Which one do you think it is?
The tricky part here is that, yeah, that automatic thing really like amazes me, I would say, and I would really love it. But we talked about Git, we talked about GitHub primarily, and we talked about VS Code. So I actually have no idea like who's like the trigger, who's the brain behind this little piece of magic. So I'm going to check what the audience tells, first of all, before exposing what I think it is. So we got a full vote for the first answer. Answer A. VS Code is doing all the magic for you. So I'm going to be super positive for our participants in the audience, and I'm just going to follow them. I know this doesn't work.
And we did spend a lot of time in VS Code, right? I mean,
it would be pretty amazing. Let's see what comes up. Cool. Looks like Visual Studio Code is defining it automatically for us, making our life as DevOps engineers way too easy. Thanks for the ones who participated. Little applause for the ones who had the correct answer. Since all of you went for option A, thanks for participating. We got a couple more questions coming up later on. But I would say let's move on and talk about some other stuff.
Yeah, Peter, I think most of our audience has followed along that pretty well there. And we're at halftime of our presentation. We're about an hour into what we're doing. We've got about a half hour left for just to give you all a time check where we are. But this second half is actually a little bit shorter. This one is less about the tools and more about how do you contribute to open source projects up on GitHub. So Peter and I are going to kind of walk through this module and have a discussion with you about how you can think about doing this and what you can do. So let's move along. And the open source community, or OSS, you hear it a lot, you can rely heavily on community people for long-term sustainability. So basically, what does that mean? All these projects out there, someone creates them or a team of people, and then it requires the community to kind of help create issues, identify problems, to help update with pull requests. A pull request is just a magical, crazy word. First time I heard it, I'm like, what does that even mean? Request somebody to pull my arm or something? It means you want somebody to automatically take your code and merge it into the project, basically make a fix or refactor. So in the spirit of open source, what you might do is say, you know what, I've been using this library for a while. Maybe I want to contribute back to it. And during the demo that we're going to get to in a minute, I'm going to randomly select a repository that Peter has authored, and I'm going to choose to contribute back to some code that Peter has written. Now, what he chooses to do with that, we will find out and see.
If you're contributing, I'm just accepting it.
I appreciate that. And one of the keys here is identifying how you can help or where you can help. One of the worst parts of open source, not even worse, it's just scary, quite frankly. It's kind of like that blank screen syndrome, is where do you go? Like, how do you know what to help with? Oh my gosh, the first time I went to the Angular repository about a decade ago, I was like, I want to contribute to this. I like this repository. I like these people. Where do I even start? And it can be a little scary, but it doesn't have to be. And this is a place for all of us to contribute to. And we can contribute with a single character that's a change to a file with like a typo, or we can contribute with actually adding code and multiple unit tests if we want to repository. So there's lots of ways we can make this happen. So I mentioned some of the ideas here. Here's some really simple ways you can get started. First, it's a lot easier than you might think it is if you're familiar with the project and the community. So find something you know. I know Peter. He's done not too scary to me, maybe a little sometimes. So I'm going to go to one of his repos, and I'm going to go ahead and look there and one of his projects. And then I'm going to look at the README file. One of the first things I do is always read the README. And sometimes you see incorrect words or spellings, or a hyperlink is broken, or there's just a little typo somewhere. And it's really easy to see some of those. And a lot of times, people like Peter on open source will be very welcoming of you making that change. So that's the kind of thing I recommend people look for the first time they go in. What about you, Peter?
No, I totally agree. But I think one of the main challenges is like, how do you know what's available? And I actually discovered an interesting one where it shouldn't be a surprise that most of the open source examples that come to mind are probably stored in GitHub. And GitHub actually provides a built-in search capability. You go to the GitHub portal, and on top there's a search. And literally, you can search for anything. If you're like really good in machine learning, up here in the screenshot, but again, it doesn't need to be a Microsoft project. It doesn't need to be a GitHub-related project. It's basically anything. If you're into IoT, if you're into overall Azure, if you're into, I don't know, any other technology you could think of, just search for it, open it up, and then you're going to find out, like in this case, machine learning. I know machine learning is a pretty hot topic, but close to 200 million repositories on GitHub. And I'm quite sure that this screenshot is a little bit outdated because we started working on the sessions like more than 6-7 weeks back. So it's probably even more than 200. So the next thing you can do is obviously narrowing it down a little bit. So just an example again here. So you dive into the highest level, you're going to search for machine learning. And from there, you start looking around, maybe exploring the README file, like John mentioned already. And based on that, you can literally identify like, oh, this looks like an interesting project. Or maybe it's interesting up to a level where you can start contributing, because there's a lot of open source content available. Could be sample files, could be source code snippets, could be documentation. Pretty much anything you find on GitHub, I would say. And it might be a little bit overwhelming. I mean, 200 million just for that one single search. And why not using that topic, drilling down, narrowing search, and literally finding not just what looks interesting, but also finding where you can contribute.
Sounds good, Peter. And one of the things we mentioned is familiarizing yourself with an open source or OSS project is important. So every community is a little bit different, but there's some basic conventions that will help everybody familiarize yourselves with those projects. Look for these 4 files in your project. So when you go into a project, look for the license file first of all. So license file describes what the license is and what the rules are for basically using this open source project, whether it's an MIT license or Apache or whatever it happens to be. The README file is the main file that you're going to look at. It usually serves a couple main purposes. What is the project, which is quite frankly really important, especially if you have a project called something like Peacock, which I do. How does somebody know what a peacock is, right? Besides the bird. So in the README, it should explain what is this? Why would someone want to use it? Those are really important things. And then explain things like how do you install it? If it's installation, where do you find it? How do you get started with it? And maybe some basic documentation. The contributing file is shows you how you can actually make contributions to the project. So based upon who the open source community or authors are for that project, they'll outline in the contributing file what guidelines they want you to follow. Like, you can contribute, but once you do this, please make sure you follow this format. Or if you're going to make a pull request, please first do this. For example, something I like in contributing for my projects is to ask people to first search the issues in the pull request to see, is the same thing you're asking for already being asked by somebody else? If so, use that. And then the 4th file is a code of conduct. I find this super important in this day and age. It's effectively the way of what behaviors will be tolerated and are encouraged on the platform. It's a little scary using open source, and I've said that a few times. That's because you're putting yourself out there and you're telling somebody, here's all my code. I don't know about you, but sharing my code with the world sometimes opens me up for a little bit of criticism. Mm-hmm. So I'm asking, be nice, get to the point. Remember, there's people behind all the code, and treat people the way you want to be treated. So in the code of conduct, we'll kind of explain how you're expected to behave up there. And I always look for that in projects that I'm going to contribute to. Makes sense. The next part of this, Peter, is to identify what tasks to work on. And one of the things I like to do is if you go over to the issues or pull requests, you can see labels. In the labels, there's some common things like good first issue. This is great for people who are just starting. It's good for your first issue to try to tackle. Or help wanted means that the owners of this repo are saying, we want your help. I often do this for docs. And then the next step of this is to sponsor a project. This is another thing you can do, which a lot of GitHub projects will have a sponsor button at the top, which you can see here in the screenshot. And this will allow you, if you really like something, a lot of open source, they don't get paid to do this. And to keep things moving, some of these people do it in their spare time. I know I like to help contribute to some of this, and you can contribute money to it. It's totally optional, but it's a nice way to give back to people who really put some great code out there.
No,
so I think it's time to talk about contributing.
Yeah, I actually got a question on that because, I mean, up till now, you literally set the scene about like what is open source, what's the mindset, what's the concept. Next to that, you talked about how GitHub actually helps you and really stimulates like that open source model. So I think we need to talk a little bit about like what does it mean to actually contribute to such an open source project, right?
Yeah, so, and Peter, just to kind of set the stage for everybody, you're going to walk through some of these steps, but then we're going to go through a demo together on how this works. And I know we've got about 20 minutes left, so I want to make sure we leave time for the live parts too.
Cool. I got the message there. Sounds good. So we started from the search, like what is available on GitHub, what is out of this massive pool of open source projects. You start looking for something where you can contribute. And what it means is you identify where you can literally be of help. Now, the next step is preparing yourself to contribute, which means how can I communicate? What are the technical skills that I need? Next to that, you're going to probably clone it to your local machine, integrating pull requests. And remember, we talked about pull requests in the previous session, where it's no guarantee for success, I would say, where you could be like super enthusiastic, like, oh, I got an answer to that question that we talked about in the previous slide. And you're going to suggest your answer, but it's still up to the open source repository or the project owner or multiple owners to actually accept your answer. So don't get, I would say, like too disencouraged. Like I went through this whole process. I'm like super enthusiastic about contributing, but they're not accepting it. And important there is, again, communication. I know it's all online and we've been using the virtual world a lot more than we used to do, but it's still like following a couple of guidelines. Communicate. Let the stakeholders know what you're working on. Tell them that you got something where you could help. You can literally contribute. Look at SNEs, which means that you could pick up that question, but maybe somebody else was already working on that. Or the other one is where you could find that linked pull request, which means that somebody's already working on it. So the SNE is typically like some responsible. He's like taking ownership to or fix it or maybe just do follow-up. And he might be looking for your contribution. But if you already see a linked pull request, it means that somebody else was already working on that. So I would say try not to like become too frustrated if you cannot really find a project right away. Looking around, start small, start with something that could help you. And then once you found a project, we go back to what John showed you in the previous demo. We're going to create that pull request. You clone it to your local machine. From there, you're going to make changes. And eventually, we're going to like offer a suggestion. Like, this is my contribution, and I want to offer it to you. Can you please accept it? That's literally what a pull request is all about. Now, there's a whole process. Again, John warned us a little bit about time. We want to make sure that you got the whole process. You can see it in action. But before that, let's quickly show you like what it looks like to just make sure that you have a really good understanding that the demo is not going way too fast and go like, wait a minute, this is like not going anymore. So what you're going to do is cloning to your local machine. You're going to make changes. You're going to commit the changes. You integrate that pull request, and you're going to offer to the other side, like this is my recommendation, my suggestion, my answer. And from there, they go through a couple of validation checks, which could be a lot of different things. In our Microsoft Docs, we're going through grammar, we're going through a lot of keywords. We're probably validating the technical suggestions you offer. So it could be a mix between automation and a little bit of manual reviews. And then hopefully once everything is worked out fine, you can move on. Or maybe you can control yourself, like, well, I want to offer this, but I don't want to use it in a full official answer yet, using that pull request, but squeezing it into a draft pull request. Now, the main difference is that the draft pull request can not be merged anymore until it's marked ready for review, which means that somebody's like literally looking over. Again, could be automated, could be manual. And it's not like a full commit out of a pull request if you want. Does that make sense?
It does. Those drafts are nice because the draft means that it protects people from, you create a pull request and you're not quite ready for it to be merged. So in the past, we used to write words in big capital letters, do not merge, but it doesn't stop anybody.
Yeah.
So at this point, we need to respond to comments. And it's really worth saying at this point, Peter and I talked quite a bit about the way we communicate on GitHub is important. Just like any social media or any other online site, it's easy to quickly just go, Peter, what's wrong with you? You wrote this code and it's terrible and it ruined my day.
Don't do that.
Don't do that. Yeah. It's very easy to do that. Or a lot of times the things that we type it in a kind way, but when you read it back, it doesn't always come off like that. So really important to be respectful in our exchanges and to follow the code of conduct. I always like to make sure that after I type a message, that I read it over before I press save or commit to it to send off to Peter, as we're going to do, as I edit his repo, because maybe that person reads it differently than I intended it. So try to be as open and friendly as you want, because again, it's a community. It's not, Peter, you did something wrong, I'm going to ruin your day.
Now, there's a question coming up since we talked about like comments and reflecting commits. So there's actually a question from our audience. Is there any like best practice, some guidance on what kind of format or convention we need to use, where John in the audience at least, is positioning the 7 rules of a great Git commit message? I love that question because it comes up in every session we did the last 3 weeks. And I know there's a lot of like buzz around it, like what would be a good commit message? For me personally, I try to limit it to like 50 characters. That's like literally following the Git best practice as well. By the way, if you do this out of GitHub in the portal, it's literally telling you like, hey, watch out. We got some best practice that the commit message should be clear, brief, not too overwhelming, because you're going to use it as some kind of timeline, what I showed you in the demo, literally scrolling through the project history and finding out what happened. So don't make it too long, too complex, but be clear, be brief on this is like the change that happened. But maybe we could squeeze that in the next demo again. I think it's about time we're going to walk through the demo because we might run out of time, and that would be sad if we cannot complete the full demo in time.
Absolutely. Let's click over the demo, and I'm going to share my screen over here. We'll go back. Peter, can you see my Visual Studio Code?
Yes, I can see it.
Okay. So I'm going to go over. I'm going to go right to Peter's repository. I picked out a repository where Peter has my first SWA deployment. I think that means static web apps, because that's a product that just went general availability last week and I'm deeply involved in. So I want to check this out. So here we've got his first repo up there. Now, let's say I look at his README and I'm like, this README could use a lot more content. So what I could do is go over to the issues and I could be really mean to Peter and say, why are you such a terrible person? Why don't you add more to your README? Or I could say, you know what? I'm going to go fix this myself. I'm going to try to contribute back. So that's what I'm going to choose. And right here, you see this green button on my screen called Code. If I drop that down, you're going to get a couple of options. There's an HTTPS option, SSH, or GitHub CLI. So you can use any of these tools to clone the repo. And that's if I owned it. Now, I don't own this repo, so I'm not going to do that quite yet. First, I'm going to use a command in the upper right called fork. Now, besides being something you eat with, a fork is how you can basically take a copy of Peter's repository and put it on your own organization. I'm going to choose John Papa. And now notice it's forking ptender, my first SWA deployment. It should only take a few seconds. And in the upper left, you'll see it says John Papa. I've got my own repo of this. It's a fork of Peter's. So now at this point, I've got my own copy, and I can make my own code. So I'm going to choose code here, and I'm going to choose HTTPS, and I can click on this URL if I'd like to. Right there, that will copy it to my clipboard. Now I could go use terminal, but instead, let's go back into VS Code right here, and I'm going to use the command palette. I'm going to hit F1, and I'm going to open up here to say clone. We're going to do a git clone. I want to clone my own repo. I'm going to choose the repository up here to clone from GitHub. So I'm going to put that up into the URL, and it's going to ask me, where do you want to put this? I'm going to put it in my play folder, and we'll create a new folder here just for fun. I'm going to call it the fun folder. Now I'm going to select my repository location. It's cloning it. And it says, would you like to add it to the workspace or would you like to open it? I'm going to open this one right here. Just going to refresh it inside VS Code. And now we can see there's the files. There's my README. That was the same README he had up on the website. And I'm going to make a change. I'm going to say something like, okay, install instructions. Let's imagine that those installation instructions have a couple steps. Like first, get the code. And these are just fake instructions. I'm having a little hard time typing the word code. There we go. Then after that, we're going to say, enjoy the code. And 3, delete the code. These are really fake instructions. And let's say I wanted to save this for him. Now, what I could do is create my own branch. So again, I'm going to open up inside the command palette with F1. I'm going to choose here to git checkout to create a branch. And in this case, I'm going to create a branch called, we'll do something up here. We'll say refactor, just giving it a prefix. This is going to be README. I'm then going to use the command palette again to commit my changes and say added more README. And then I'm going to use the command palette again, F1 a lot, to say push. Now it's going to ask me if I want to create this in my upstream. Upstream basically means what's up in the cloud. So I'm going to tell it to go ahead and do that. And I can push it to mine or I can push it to Peter's. So what I can do here is say go right to the upstream, but I don't have permissions to that. So instead, I'm going to go right here to the origin. It's going to push it. And then when it's done, it says, hey, would you like to create a pull request for this? Now, I could do it right from here by clicking on this button and say, from this branch, go ahead and create a pull request for Peter against his main branch. And I can look at the changes. I can say, you really want to do this. And a smiley face. Everyone loves smiley faces, or you can get really fancy and put emojis in there. And I'm going to choose create. Now, once I do that, you can see I've got my pull request right here, but I want to switch over to you, Peter, to let you share, see what it looks like on your end, because it's now in your hands.
Good. Let's see what's happening. And before I switch screens, I'm quickly going to check if my browser is still open. I was checking some feedback from the audience, but you worked on my first deployment, right?
Yes.
Okay. Just going to refresh my browser. While it's refreshing, let me switch back to my screen.
It was my first SWA deployment, I believe is the repo.
Yep, that's the one. It's still open. Way cool.
And look at that. There's a number 1 up there in pull requests.
From here, way cool. Let's have a look. You added more stuff to the README file. I can see that it's you, John Papa, making some changes to workflows awaiting approval. That's way cool. The branch has changed. I accept it because I like your comments. And from here, since I'm in charge, I could merge the pull requests. And it's really that easy. That's all we need to do. Super convenient collaboration, everything we talked about in previous sessions. But just having a look at time, I think it's about literally time to wrap up. So
yeah, we got about 5 minutes, I think.
Yeah, it looks pretty good, but we got a super important message coming up, even more important than everything we talked about in the last 85 minutes. So hold on tight, we're almost there. So a little wrap up. What we did is introducing you to VS Code, talking about GitHub, how those two worlds are nicely working together. So you discovered how collaboration works, how the project cloning was working. We talked about open source integration, helping literally building up, leveraging on that open source community model. Remember that you need to be polite. You need to contribute on the project where you can be successful as well. And if you want to take it even up to the next level, you could also look into that GitHub project sponsorship. So you're not sponsoring GitHub, just to be clear. You're really helping the open source community. And then from there, after you find out, like, this is what I can work on, just start creating your first contribution, submit a pull request, similar to what we showed you in the demo. Hopefully you get accepted. I'm not saying hopefully in a way that it's never going to happen. But again, just watch out what you're contributing to. Make sure that you can be successful, that you can help the project being successful. That's most important. Now, from here, last couple of words. We talked about Git 3 weeks back. Next, we talked about collaboration, talked about branching. All the Git commands are still available. The sessions are there. I hope you enjoyed it, what we did with VS Code integration together with GitHub. Again, not stepping away, not pushing you away from Git command line at all, but literally showing you how it can be a super exciting tool. What's the important message, ladies and gentlemen? It's Build Week coming up next week. Make sure you register if you're not registered already. If you are, let us know in the chat. It's always interesting to know, like, what's the audience going to be like? What are your interesting sessions? If you're looking for sessions, it's next week, May 25, 26, 27. It's all virtual for now, so super easy. Go to that Build website. If you don't want to watch all the sessions, but like I would say the most important ones, maybe at least for now, you could also check back in your trusted environment, being the Learn Live that you already followed along the last couple of weeks, and we're going to stream some build sessions. There's no way we can show you all sessions, so just a couple of examples. It's going from identity to IoT, static web apps, what we used in our last demo as well, Microsoft Graph integration, Power Apps integration. I used to know that Build was like a developer-only conference, but now it's literally overall Microsoft Cloud, on-prem hybrid, whatever you name it, whatever you want it, it's all going to happen on the Build conference. I think with that, we got like 2 minutes left. Let us know in the chat what you liked about the session. If you still got any questions, remember, it's all part of that Learn online module, aka.ms/learn git VS Code. That's the URL you needed to use. There's one question coming in. Let's see, John, if you could help me out here. So there's a question. When I like a project on GitHub, I usually give it a star and make a fork. Is there a problem with making a fork and never giving a pull request?
Oh, that's a great question. Yeah, I mean, maybe you make a fork because you just want to try a local copy for yourself and you want to explore it and you want to have it your own. The nice thing about making a fork is you grab a moment in time of what that repository looks like. So absolutely, you don't have to make a pull request everything you fork. In fact, I don't. But in case you want to, you can always fork it and then make a pull request. So no, there are no expectations up there. You do you.
And I also think that, like, when you use that fork scenario, it's giving you access to all the source files and the source code. And it could actually help you, like, drilling in, like, the code. Maybe it's like some sample app that you want to run yourself. That could also help you in figuring out, like, oh, based on the README file and based on the questions, it looks like a cool project. But maybe once you've looked into the fork, it's maybe a bit too challenging, or the other way around, where you were not convinced about going through the README, but once you saw the inside by using that fork, you go like, wait, I want to contribute. I'm going to fire up a pull request here.
Hey, Peter, you know what time it is?
I think it's time they're going to kick us off the platform.
I think it is. I want to tell everybody from both Peter and I, thank you so much for the entire series, and thank you for Learn Live for supporting us. And please check us out at Build.
Let's do so. I'm going to thank you all as well. I was here at the start 3 weeks back. I was super enthusiastic, convincing you about Git command line with all the cool stuff that comes in with Git. I hope you followed along, you enjoyed it, you learned from it, and thank you for being here. Learn Life is not going away. We're going to be here.